Hi everyone, my name is Ivan Grohodkov.
Hey everybody, it's me, Lady Ada.
Okay, and then how does the future look for ULP?
Hi, we're excited to be here at Espressif DevCon.
Hi ESP, turn on the light.
How can I get started with IDF?
How we can start with Matter?
I love this question. If you want to read right now, that you can try.
Yes,
on
so
Discord.
the service is already available.
Hello everyone, welcome to DevCon.
Nice to meet you.
Welcome to Espressif DevCon23.
Espressif DevCon23 is unmissable. See you there.
Hello world, welcome to Espressif DevCon23. You're watching the second day of our live broadcast from Brno in the Czech Republic. Today is also the International Programmers Day, so happy day to all our fellow programmers watching us live right now across the world. This day honors programmers and innovators who make our lives more convenient with their programs. In honor of all programmers out there, we have prepared for you yet another day packed with exciting talks by guest speakers and Espressif engineers. I'm Yanis from Espressif's marketing department, and this is Radim Karnish, a software engineer at Espressif Systems here in Brno, developing open source tools for IoT devices. Hi Radim, good to have you here today. How's it going?
Hi Yanis, it's so good to be here with you. I was watching yesterday's broadcast of DevCon23 and was very impressed with the level of the presentations and the entire production. So let me tell you, I'm really thrilled to be closely involved in the presentation of the event today.
Thank you for this, Radim. Was there anything you particularly liked or was close to your specialism? Or maybe did you learn something new about Espressif's products and services?
Well, honestly, I enjoyed every second of day one, so it's just impossible to choose just one talk. Overall, day one was filled with informative sessions, simply a treat for any fan of AIoT technologies. I gained a deeper understanding of our product's capabilities and how they can be applied in real-world scenarios. It's always great to see how engineers across the globe are pushing the boundaries of what's possible with Espressif technology.
Fantastic. So, let's cut straight to the chase. We'll start our broadcast today with none other than Espressif's Director of Technical Marketing, Amey Inamdar, for the second keynote speech of DevCon23. Amey will focus on the latest products by Espressif, particularly ESP32H2, C6 and P4, along with any relevant software and solutions. He will also talk about Espressif's upcoming products in light of emerging market trends. Let's see what he has to say.
Hello all. Welcome to the second day of the Espressif Developer Conference 2023. My name is Amey Inamdar and I'm Director of Technical Marketing at Espressif. I hope you enjoyed the first day when we had many interesting talks delivered by my colleagues. We are going to begin the second day by introducing all the new products, important features in our SDKs, and different solutions that we developed during the last 1 year. In this session, I'm going to talk about our two new SoCs, ESP32H2 and ESP32C6, that are now in mass production. I will also talk about some of the development kits that we made available recently. Then I'll talk about various SDKs that we have and what are some of the important features that we developed in the last 1 year. Then I'll give you an overview of how Espressif provides comprehensive support for building Matter devices using our hardware and software. Espressif also has a cloud solution, ESP Rainmaker, and a remote device observability solution called ESP Insights. I'll talk about some of the new developments that we did in both these solutions. Then I will talk about a few of our new solutions that our team has built. And then finally, I would be glad to answer your questions that may come up. Okay, so let's begin with the new SoCs, ESP32H2 and ESP32C6. So ESP32H2 is our first 802.15.4 and BLE on the SoC. Yes, it does not have Wi-Fi connectivity. This is a single core RISC-V MCU capable of running at 96 MHz with 320 kilobytes of RAM. This has all the required peripherals, and this is a very well-suited SoC if you are considering to build a thread product or a Matter product with thread protocol support or purely a ZigBee product. Again, this SoC continues to have the security features such as secure boot, flash encryption, and also has ECDSA-based digital signature peripheral, which acts as an integrated hardware secure element right within the SoC. Then ESP32C6 is Wi-Fi plus 802.15.4 plus BLE connectivity SoC. So yes, it has all the three radios. And then it is a single core RISC-V MCU capable of running at 160 MHz. It also has a low power core capable of running at 20 MHz, and that is also a RISC-V core. It has 512 kilobytes of RAM, and it basically uses the hardware coexistence to share the RF between all these three protocols. It has all the commonly required peripherals and also has support for peripherals such as two-wire or automotive interface as well as SDIO slave. Again, this SoC also continues to have secure boot, flash encryption, and digital signature peripheral type of security features required for building any secure and trusted IoT device. So now let's move on to the development boards that we developed recently. So the first one I would talk about is ESP32S3 Box 3, which is a successor of an older S3 box, which received overwhelming response from all the developers. So it has a very interesting form factor to work with. And in this specific board, we have added more memory, that it has more PSRAM, 16 megabyte PSRAM availability. The design is slimmer and sleeker, and it comes with different IO expansion slots, which basically takes the usability to the next level. Then the next board I would like to talk about is a ESP Thread Border Router Dev Kit. It essentially is a two-module board or a two-chip board based on ESP32S3 and ESP32H2. It can be used for building a thread border router, but it can also be used to build some additional devices such as ZigBee to Matter gateway or ZigBee to cloud type of bridges. In this case, ESP32S3 acts as a master MCU and ESP32H2 acts as a radio co-processor supporting 802.15.4 radio. With having a separate 802.15.4 radio, we can provide really high performance when it comes to a thread border router. And for this board, we have a complete reference design available, including the schematic, BOM, and also the software that is run on both the chips. Then the next board I would like to talk about is ESP32C3 LCD evaluation board. So this has very unique form factor. So this is a circular display with ESP32C3, and it also comes with a rotary encoder switch with 360 degrees rotation. The display is based on I2C and SPI, and it has 1.28 inches LCD screen with 240 by 240 resolution. Additionally, this board also has on-board infrared receiver and transmitter, so you can build remote control type of applications easily using this board. It also has a small speaker on board to provide audio feedback to the users. Of course, again, schematic and layout is openly available even for this. Now, let's talk about some of the SDKs and software features that we have added recently. So first to talk about is ESP-IDF. ESP-IDF, as you know, is the base platform that we provide to build all the applications on all different SoCs that we have. So we released new ESP-IDF version 5.1 in this June of 2023. And with that, the service period availability for this version will be till June 24. So all the patches will be ported actively till June 2024. And it will be in the maintenance period till December 2025. So the security patches will be maintained till December 2025. So if you are starting to build any new application right now, IDF 5.1 is the best SDK to start working with. This SDK supports newly announced ESP32C6 and H2 SoCs, and it also has multiple different software component upgrades such as Nimble BLE stack has been upgraded, Embed TLS stack has been upgraded, GCC, GDB, OpenOCD, these tools have been upgraded as well. The default C++ support also now has moved to C++23. In terms of Wi-Fi connectivity, it has support for Wi-Fi aware, that is neighborhood aware networks, and also it supports WPA3 using in the soft API mode. Of course, as ESP32C6 is supported, this SDK version also supports 802.11ax protocol. In terms of peripheral, it adds new drivers for event task matrix as well as parallel I/O interface. There are multiple new USB subsystem examples available that include USB camera, that is USB UVC, USB HID, host, as well as USB mass storage. ESP-IDF also has a special target called Linux, whereby you can compile IDF for Linux for an easy development. We have added for support for FreeRTOS, LWIP stack, TCP transport, and TCP TLS, even for the Linux target in this SDK version, so that your development on Linux platform becomes much easier. The next thing I would like to talk about is IDF Component Manager. So IDF Component Manager is equivalent to an NPM registry or PIP registry for Python. So ESP registry we maintain, which basically comprises of different components which you can use in your projects. So these components come from either from us directly or even from third parties. We are very glad to say that ESP registry is now open for public contributions. So you can have your own component built and you can register that with ESP registry using your GitHub account. We have released the complete documentation to allow you to do this, to do the same. We have also released GitHub CI action so that you can easily upload your newly refreshed component into the registry. We are very proud to say that we have 179 components already published and more than 20,000 component downloads per day. And yes, this download count does not include automated download that happens from the CI. To talk about the 802.15.4 software, because we have two new SoCs supporting 802.15.4 radio, we support Thread, ZigBee, both the protocols. On Thread side, we have Open Thread support present in ESP-IDF 5.1, and you can also use ESP32H2 or ESP32C6 just as a Open Thread radio coprocessor with some other host. That support is also available in IDF. ESP Thread BR, this SDK basically implements Thread border router, and this implementation is now already certified for Thread 1.3. On ZigBee side, ESP ZigBee SDK is the SDK based on DSR ZBoss stack that we use internally, and it provides a bunch of examples for you to build ZigBee-based devices using ESP32H2 or C6 SoCs. ZigBee radio coprocessor functionality can also be used with, say, ESP32H2, and we have examples for the same available in this repository. In fact, we also have implementation for ZigBee to Matter bridge implementation, and then it is available in ESP Matter SDK. Now let me talk about two other commonly used SDKs by developers, Arduino and Zephyr. So Arduino recently announced Arduino Nano ESP32, which is the first official Arduino board in which ESP32S3 is used as a main processor. It uses Arduino ESP32 core that we have implemented to support Arduino. And on Arduino ESP32, we have started developing version 3.0, which is going to be based on IDF 5.1. There is also work ongoing to support ESP32C6 and ESP32H2 chips in Arduino. On the Zephyr side, we supported Wi-Fi protected modes, which also includes WPA3 support now. We have also added ESP32S3 support in Zephyr. Asymmetric multiprocessing, which was work in progress last time, has now concluded, and support for asymmetric multiprocessing is now available in Zephyr substrate repository. Also, ESP32C6 and H2 support in Zephyr is right now in progress. Moving ahead, Rust language is very important for us, and we see quite a significant promise in Rust language to build memory-safe embedded systems. So we have made good progress, and yesterday you heard from my colleagues about some of the developments that we did on the Rust side. Just to summarize them, we implemented async bare metal Wi-Fi support, so you can use Wi-Fi functionality even with the bare metal mode in the async fashion. Also, the bare metal support for ESP32H2 and C6 is ready. Standard library support for ESP32C6 is also ready based on ESP-IDF, and device driver supporting async mode is also available for both standard libraries based implementation as well as bare metal implementation. As you know, some of our chips like ESP32S3 and upcoming ESP32P4 has quite a good AI functionality or machine learning capabilities. We also provide many machine learning SDKs from our side. You might have heard of ESP-WHO, which is an object or face recognition SDK, and ESP-Skynet, which is the speech recognition SDK. But underlying these SDKs, we also provide you ability to build your own machine learning models with ease. There are two other SDKs which play that role. We have support for TensorFlow Lite Micro, which is a standard TensorFlow Lite implementation, which is optimized for SoCs like ESP32S3 to take advantage of its AI acceleration. However, a bunch of functionality still comes from TF Lite side, including the quantization decisions and so on. So to improve on the performance or to get the best possible performance, we also have a repository called ESP-DL. DL stands for Deep Learning. And one of the key features that we added recently to ESP-DL is TVM compiler support. TVM compiler basically provides a unified way to work with embedded systems with different GPU or TPU capabilities. So we have added support for ESP32S3 in the TVM compiler, and with that, you can use models such as TensorFlow Lite, FreeRTOS, or ONNX easily using ESP-DL platform supporting TVM compiler. So with TVM compiler, we get much reduced quantization loss, and also keeping the performance very good. So you can use standard models with best performance with this. Moving ahead, as you may know that ESP SoCs also are used for audio purpose. Customers build different audio-centric applications on that. And we have a SDK called ESP-IDF. We recently released version 2.6 for this SDK, which is based on IDF 5.1. Multiple components of ESP-IDF can now be used in a separate component fashion, so that if you are interested in using a part of IDF, it's very easy to do that. Importantly, we also added support for software-based H264 encoding in ESP-RTC. Now let me talk about Matter support. So as you know, Espressif has been providing quite comprehensive Matter solutions to all the developers. We have an open source SDK called ESP Matter, which is based on Connected Home IP SDK. Connected Home IP SDK is where the entire authoritative implementation of the specification is maintained by the community. So we have added support for all our different SoCs in Connected Home IP, and then we have built our own ESP Matter SDK on top of that. To talk about ESP Matter SDK, now has releases for both Matter 1.0 and 1.1 specification, and its master branch is currently tracking version 1.2 of Matter specification. We have also recently added support for ESP32C2 to support Matter devices over Wi-Fi. ESP Matter SDK now works with IDF 5.0 and 5.1. We also added support for Ethernet-based commissioning. And then, importantly, with ESP Matter SDK, The ESP32 series chips can also act as a commissioner, so they can provide a commissioning functionality to commission other Matter devices. At the same time, we also now have controller example available on ESP32, which can basically control other devices, other Matter compatible devices. One more Matter-centric product that we have is ESP zero code modules, which essentially is a zero code type of module where you can configure you can configure a module to act as a light bulb or a socket or any commonly used device type. So for that, we announced ESP zero code console recently, and it supports all the basic devices supported in Matter protocol. You can easily configure the I/O configuration and drivers connected to those I/Os to simply define your device and get a fully ready Matter firmware directly in your browser. Once your firmware is ready, you can easily use ESP Launchpad there itself to load that firmware onto your module and have a complete experience of a Matter accessory without going out of your browser. The next important thing on the Matter side is DAC pre-provisioning service. Matter has this concept of having a unique device certificate signed using CSN approved authority. So for simplifying our customers' manufacturing line, we support DAC pre-provisioning service, and this service is now available on all the different modules for all the different SoCs that we have. Now to talk about ESP Rainmaker, which is Espressif's private cloud platform, and ESP Insights. So ESP Rainmaker, as I told you, is the cloud software that you can deploy in your own AWS account, where you get complete control and you can build your own IoT cloud. Importantly, we added a support for Matter Fabric in ESP Rainmaker recently. So with that, you can build your own Matter ecosystem where you can have your own Matter compatible phone applications that can work with not only with your own devices, but also other third-party Matter devices. You can have the Matter device database synchronization across different controllers that you may have. And we also intend to take it forward to provide remote control for all your Matter devices through the controller that we. That is one of the important features that we developed recently. Now moving on, so we also supported command response framework in Rainmaker. Earlier it was all device parameters updates based framework, but with command response framework, you can now have a synchronous communication between any other entity, such as phone apps and the devices. We also did a bunch of improvements on over-the-air upgrades capabilities by supporting MQTT-based OTA or priority-based OTA and also user approval-driven OTA. To talk about ESP Insights, we improved quite a many different metrics that come with ESP Insights. It also now has command response support, so you can selectively enable diagnostics on particular device or a particular set of devices. Alerts and notifications are now available for any behavioral anomalies that may happen in your systems enabled with ESP Insights. It also supports multi-admin support so that you can share the logs of particular devices with other users or other developers that you want to. And it also now supports connector functionality so that if you have your own cloud or if you have your own third-party cloud which is getting the diagnostic data, then you can build cloud-to-cloud connectors to have integration with ESP Insights. Now let me talk about some of the new Espressif solutions that our teams have built. So the first one is ESP Mesh Lite. As you may remember, we have ESP Wi-Fi Mesh. ESP Mesh Lite is a successor of ESP Wi-Fi Mesh, and one of the key improvements that we have done is a complete IP connectivity to all the participants of the mesh. Earlier, you may remember that ESP Wi-Fi Mesh has different MAC-based communication within the mesh, and then the root node had to communicate with the IP network to the outside world. But in the case of ESP Mesh Lite, all the nodes get IP connectivity so that they can directly communicate, say, with cloud. There is no special infrastructure needed because now your router can absorb the root node, but all the intermediate nodes in the ESP Mesh Lite provide network address translation so that your main router is not burdened with so many devices. We also continue to reuse the good parts from the ESP Wi-Fi mesh, such as self-provisioning, self-healing. These features are already available in Mesh Lite as well. And also we have Rainmaker integration available for ESP Mesh Lite. The next thing I would like to talk about is ESP Now Matter Bridge. You may know that we have a coin cell operated button solutions. So you can have switches completely built on a coin cell and they can talk ESP Now protocol. With this ESP Now Matter Bridge implementation, basically any other device enabled with ESP32C3 or ESP32S3 type of SoCs can act as a ESP Now to Matter bridge. It talks ESP Now protocol on one side and Matter protocol on other side. So with this type of bridge, now all these low power ESP Now devices can be first class citizen of your Matter network, and using device binding, you can bind these low power ESP Now devices to control your own defined devices in your home which are Matter compatible. It gives you a lot of flexibility, and then it also improves the usability of these ESP Now buttons to the great extent. We have worked significantly to enhance power consumption of both the button itself as well as ESP Now Matter bridge. Then USB camera with LCD display. Imagine you have a video doorbell type of applications to be developed. So ESP32S3 with its JPEG decoding, the display capabilities of 800 by 480 resolution display, it can act as a USB camera display solution whereby it can take in the camera input and can also render it on the screen with 800 by 480 resolution at 15 frames per second. The video at the same time can also be transmitted to the mobile app that you may have. So with this, you can build real video doorbell type of applications. And we already have a reference implementation available on our GitHub. Then I would like to talk about ESP motor control, which is yet another solution from our side. And this is based on MCPWM and LED controller peripherals that ESP32 and ESP32S3 SoCs have. With this solution, we can support up to 4-way field-oriented control-based motor control, and also we can support sensorless motor control to implement BLDC type of applications. This project is also available through the component manager. So to conclude, as you can see, we have made significant progress in last year on so many fronts. Also, most of the development has been strongly developer focused, and that is what our core DNA is. We will continue to move forward, and your feedback is very important for us to provide different solutions that are meaningful for you. Thank you for watching this session, and we can take your questions now.
Hello everyone, and welcome to the second day of Espressif DevCon23. My name is Pedro Minatel. I'm developer advocate here at Espressif, and I will be the host for today's Q&A. So for the first Q&A, we have Ame here. Hi Ame, how are you today?
Hi everyone. Hi Pedro.
So I'm really happy to see you here for the first keynote of the first keynote of the day, but the second keynote for Espressif DevCon. And now I think we have already some questions here in the chat. Most questions are related to P4. So the first one is, when can we expect ESP32 P4 dev boards, and when they will be available in India?
Yeah, I understand the community is really excited to have P4 in their hands. And then, yes, we have some early samples of P4 and they're looking really good. In terms of the mass production version, we are hopeful that we will have the ESP32 P4 samples towards the end of year. And that's when we'll also try to make the development kits available based on P4. And we are continuing to make the modules and dev kits always easily available through multiple different sources, including DigiKey, Mouser, all these type of stores. And we are continuing to work further on in this direction to also make them available into specific regions like India by having more and more ways to find you these products very easily. So yes, they will be available towards the end of this year.
Oh, that's great news. We have one more question here. The second question is, can the ESP32C6 support a single chip thread border router?
That's a very good question. So yes, because ESP32C6 has both the radios, that is 802.15.4 radio supporting thread, and Wi-Fi radio supporting the IP connectivity on the Wi-Fi side. The question is quite logical, whether it can support the thread border router use cases without having to have a two-chip solution. Yes, we can support thread border router on a single chip C6. However, the performance may not be the best in that case. And in that case, low power thread devices may require more number of transmissions and may have to wait for longer, reducing their battery life. So while it is possible to create a single chip thread border router, from the performance perspective, we really advise our customers to use ESP32 S3 plus H2 or C3 plus H2 type of two-chip solutions, so that the 802.15.4 radio is continuously available for receive. So that's the reason from the performance perspective, we really advise to use the two-chip solution.
Okay, I see. We have a third question here related to P4 as well. But the question is it possible to pair ESP32P4 with any other Espressif connectivity chip? And how will be the developer experience in that case?
Certainly. We have developed ESP32P4 software considering this in mind, and yes, ESP32P4 can be paired with any other Espressif chip to provide Wi-Fi, Bluetooth, or 802.15.4 connectivity to ESP32P4. And the way we are structuring our software through the Wi-Fi drivers or ESP hosted type of SDKs to provide the seamless experience to users, so that the API does not change. So if you have, say, application developed on ESP32 S3, it will be very easily migratable to ESP32P4 plus some connectivity chip paired together. So in nutshell, the developer experience will remain consistent even in the two-chip solution.
Okay, so I think we have time. We have two more questions here in the chat. So question is, can we use ESP32C6 as Zigbee hub?
ESP32C6 as a Zigbee hub, yes. The point is, if when you use it as a Zigbee hub, you may also want to connect some other radio, typically say a Wi-Fi connectivity to it simultaneously. And due to the reason that I mentioned previously in the context of thread border router, the same considerations apply. So from the coexistence perspective, while it is possible to build such a type of device, from the performance perspective, it is always better to have a dedicated 802.15.4 radio, so that it can be in the receive mode all the time, which will provide better performance without reducing the life of battery operated tiny Zigbee devices. Yes, from that perspective, again, here also we strongly advise two-chip solution for Zigbee gateway type of devices.
Okay, so thank you. So I think we can go to the last question, and of course, like if you have any other question, you can ask in the chat. We will be happy to answer later in text mode. So the last question is, how does it work with Espressif modules and Wi-Fi Alliance certifications? If I do a firmware upgrade for my end device, can I still use Espressif certificate in my product?
Yes, that's a very good question. Yes, so Espressif modules come with Wi-Fi Alliance certification, and our customers can use the derivative certification whereby they can they need not go to the lab to do the certification. They can use the base certification that Espressif has taken, and then they can use the derivative certification to use the logos. And unless and until the software components remain intact in terms of the supported IDF versions and supported Wi-Fi drivers that come from Espressif, the certification too remains valid in those cases. So in such cases, you don't have to worry about the Wi-Fi certification on a recurring basis, as long as you use the components that are provided by Espressif.
Okay, thank you. So thank you so much for answering the questions and for your very informative keynote. So that's it. So I'm really happy to have you here today.
Thanks, everyone, and have a great day. And I'm hopeful that you will also like all the rest of the talks that we have scheduled for today.
Yeah, for sure. And now we can go back to the studio.
That was a brilliant presentation and Q&A session. I particularly like the part about ESP32P4.
Yes, the mighty ESP32P4, our latest SoC. It is not available yet, but when it does become available, we expect it to be a game changer, as it packs in tons of I/O and security features. In fact, it targets edge computing applications that need high-performance processing, advanced human-machine interface, and strong security. ESP32P4 will be supported through Espressif's mature IoT development framework, ESP-IDF, so that our customers can benefit from their familiarity with our field-proven platform that already powers millions of connected devices.
Speaking of ESP-IDF, Darian, our next speaker, has prepared a relevant presentation which is basically a beginner's guide to key concepts and resources for ESP-IDF. Darian will explain in simple words how beginners, or generally people with limited programming experience, can get started with ESP-IDF. His presentation will surely be of interest to IoT educators and students alike. Let's take a listen.
Hi everyone, my name is Darian, and my presentation today is titled ESP-IDF Getting Started, a beginner's guide to key concepts and resources. I'm a senior embedded software engineer at Espressif, and I'm part of the software platforms team. So what was the motivation for this presentation? Over the years, we've noticed a significant number of users who had difficulty getting started with IDF. Thus, if any of these Reddit threads resonate with you, then this presentation is for you. The goal of this presentation is to briefly cover the main concepts you need to be familiar with in order to get started using IDF. So what am I going to be covering in this presentation? First, I'll take a look at why you may want to use IDF. And next, I'll go over the general IDF workflows, such as building and flashing. Then I'll briefly talk about the IDF programming model. And afterwards, I'll go over how to find IDF features for your product. And lastly, I'll give a brief introduction to IDF's build system and where else to get resources. So before we begin, here are some notes about this presentation. I've embedded some hyperlinks in the slide, so if you see this icon on the slide, there's a hyperlink. Next, all of the information about the IDF presentation is based off IDF version 5.1. And for any demos of using IDF, I'll be showing them via command line on Ubuntu and also via the Eclipse IDE on Windows. And lastly, all of the demos are run on an ESP32 rover kit. So without further ado, let's begin. So let's first talk about why you may want to use IDF. Let's say you've just decided to develop an ESP-based project and you're choosing which SDK to use. What are some of the things you might want to consider when choosing an SDK? Firstly, which development language does the SDK support? Do you want to develop your project in C and C++, or do you prefer a higher language like Python or JavaScript? Next, what features does the SDK provide? Does it have all of the libraries and networking stacks that you want? And you also have to consider how configurable the SDK is. Are you able to fine-tune the SDK to your project's requirements? And how well maintained is the SDK? Will you be able to receive support and updates during development? And how easy is the SDK to use? Does it support a development environment that you're comfortable with? And what types of testing and debugging tools does the SDK offer? So, what is ESP-IDF? If you don't know already, ESP-IDF stands for Espressif IoT Development Framework, and is one of the many SDKs you can use to develop ESP-based projects. It's entirely hosted on GitHub, and it's open source as well. On the surface, it just seems like a GitHub repository, but as we'll see later, the repository is just a centerpiece of a much wider SDK containing various tools and libraries. So given the considerations we've just discussed, here are some of the reasons why you may want to use IDF. Firstly, IDF projects and IDF itself are written in C and C++. IDF contains a lot of components, including a Wi-Fi stack, a network stack, a Bluetooth stack, etc. And it also has a component manager to download more components if the ones in IDF aren't enough. In terms of configurability, IDF can be configured at the component level. And IDF is also actively maintained with constant bug fix and new feature releases. So, generally speaking, new chips and features are supported on IDF first, before any of the other SDKs. And in terms of ease of use, IDF can be used from command line or through one of the supported IDEs. And finally, IDF supports a wide range of tools for debugging and testing, such as GDB for debugging and the Unity test framework for testing. So, let's say you've chosen IDF. You might be wondering next, how do you use it? So let's look at the basic workflow of an IDF project. First things first, you need to decide which dev environment to use. What are the options? Firstly, you can use it from command line paired with a text editor of your choice. Or, IDF also supports integration with Eclipse as a plugin or standalone IDE. And there's also integration with VS Code as an extension. For this presentation, I'll be demonstrating the workflow in command line and the Eclipse IDE. So next, we need to install IDF. The exact instruction for installations would depend on your environment, but the underlying process is pretty similar. First, we need to install the system package dependencies, such as Python, Git, and CMake. Next, we use Git to clone the IDF repository from GitHub, and once cloned, we'll run the IDF's install script, which handles the rest of the installation. The script will install the toolchain and a bunch of Python packages inside a virtual environment. And at this point, the installation is complete, so let's create a project. The next thing we need to do is run the export script, which exposes all the tools we've just installed. And finally, when compiling a project, the IDF component manager will also help download any external components that your project may use. So, what does IDF installation actually look like in practice? If you're using command on Linux, the installation will go something like this. First, we install the system package dependencies such as Git, Python, and CMake. Next, we create an ESP directory, and we clone the IDF repository into that directory. Then we run the install script, the export script, and finally, we should be able to call the IDF-py command. This is the main command for most IDF operations in command line. And just to expand a bit about IDF-py, here are some of the subcommands it offers. You see that it covers most of the operations you need during development, such as creating a project, configuring the project, building it, flashing it, and also monitoring it when it executes. As for the installation on Eclipse, it's done through a Windows installer. And once you've stepped through the installer, you should be able to use IDF through Eclipse's native user interface. So now that we're done with installing, let's create a project. Well, this is quite simple. In command line, you just use a create project command. And in Eclipse, you just press the create project button. The result is a new project with the following files and directories. But you might be wondering, what are those files and directories for? So let's take a look. So firstly, we have the main directory. And this basically represents something called the main component. And within the main component, there's a CMake file to register the main component. And there's also a source file for the main component. And this source file basically contains the app main function, which serves as the entry point for our project. And lastly, at the project directory, we have another CMake file, which declares the entire project. So now that we've created a project, what do we do? The general workflow of IDF can be split into 4 steps. First, we need to configure the project to generate a configuration file. Next, we need to build the project to generate binary files. Afterwards, we need to write those binary files into ESP's flash memory. This is known as flashing. And finally, the ESP executes those binary files from flash, where we can monitor the execution's output. So let's look at configuration in practice. In command line, you first have to set which ESP chip you're using. This is also known as the target. Then you call the menu config command, and by doing that, it will launch the kconfig user interface, which allows you to set all the configuration options. In Eclipse, similarly, we first have to set our targets. However, we have to build the project first, and then afterwards, if we click on the SDK config file, this will launch the configuration menu inside Eclipse. So after configuring a project, you should see 2 new things in your project directory. First, it's a build directory, and this is basically a directory to store all of the temporary files generated during your typical IDF workflow. And secondly, there's the SDK config file, and this basically stores all of the configuration values. So if we take a look inside the SDK config file, we'll see that a lot of all the configuration values are grouped by component, and every configuration option that is offered by a component will have a value inside this file. So now that we've configured the project, we need to build the project. In command line, we simply use the all command, and Eclipse, we simply press the build button. But in either case, the build should generate an output log similar to this. So some things to notice about the build log is that the build system compiles all source files of all components. But on repeated builds, it will only build the source files that have changed. So you notice that on first build, the build might take a very long time, but if you try to rebuild it, it's much quicker the second time around. And the second thing to notice is that the build generates 3 binary files, and these are the partition table, the bootloader, and the application binary. You don't need to understand what the 3 binary files do for now. Just know that our project's code is compiled into the application binary. So we now need to flash the 3 binary files to ESP. But before we cover flashing, it's useful to understand the ESP's hardware. So here we have an ESP32 development kit, and on the development kit is an ESP32 module. Inside the module is an ESP32 chip that's connected via SPI to a flash chip and optionally a RAM chip. Note that all of these chips are inside the module. So how does the ESP communicate with the PC? This is done through a UART to USB bridge, which routes to the USB port to the PC. And you also notice that the bridge is connected to the enable and IO0 pins. This is used by the PC to reset the ESP from software and also to put the ESP into a download mode. However, the enable and IO0 pins are also routed to buttons for you to control manually. So what does the flashing process look like? We have 3 binary files, and we need to flash them to the SPI flash chip. The first step is to put the ESP into download mode, and this can be done using the enable and IO0 pins. Next, we need to transmit the binary files over UART to the ESP. The ESP being in download mode will then forward the data to the SPI flash. And when all the binary files get flashed, the flashing process is complete. So what does flashing look like in practice? In command line, we first have to find the ESP serial port. It's usually one of the dev TTY USB files, and then we call the flash command with the serial port as an argument. Similarly, in Eclipse, we have to find the ESP serial port using the Windows Device Manager, and it's usually one of the COM ports. Next, we create a new launch target in Eclipse with the correct port number, and then we press the run button to flash. And the resulting flash log should look something like this. Notice that the ESP tool gets invoked by the IDF build system to handle the flashing. And once the flashing is complete, the ESP is reset back into execution mode. So let's monitor the execution of the ESP. So how do we do that? In command line, we use the monitor command with the same port argument, and Eclipse, you simply open a new terminal tab. In both cases, the IDF monitor is launched in order to monitor the UART output of the ESP. So typically, your monitor log should look something like this. Let's take a deeper look. Here, the ESP has just been reset into execution mode, and then afterwards, it immediately jumps to the first stage bootloader. And all the first stage bootloader does is to load the second stage bootloader. And once loaded, we jump to the second stage bootloader. Next, now we're in the second stage bootloader, and the second stage bootloader reads the partition table in order to find an application binary. Then we load the application binary, and then we jump to the application binary. So now we're in the app binary, and here we can actually see the application's name. The application does some system initialization, such as starting the operating system, and finally it calls app main. Now, we finally arrived in the app main function, where we call hello world, and it gets printed. This log basically outlines the typical IDF boot process, and if you want to know more about the boot process, go visit the link in the slide. Now that we've covered the basics of IDF project workflow, we now need to learn how to program an IDF project. So here's the app main entry function. Where do we go from here? What if we use a super loop, similar to what you'd find in Arduino or an STM32? While this may be valid, it's not actually optimal. To illustrate this, let's use a very simple example. Let's say I'm trying to build a simple project where I can press a button to cause the ESP32 to read from an I2C sensor. Then the sensor value gets pushed to a LCD screen. In this case, my super loop would look something like this, where I check for a GPIO press, handle the debounce, read from the I2C sensor, and then push the sensor value to the LCD screen. That's simple enough, but what happens if one of the stages takes too long, for example, the LCD update? Then the entire loop will be stuck while the LCD is updating. And what's more is if we had more subsystems, like a file system or a Wi-Fi stack, then each loop iteration would get quite long. So, and also, how do we pass data between the different subsystems? So these are some of the common issues with a superloop. But what if we could run each subsystem in parallel? What if each subsystem was its own thread running in its own loop, and each loop could then block on or wait for some event? And then also each thread could also give events to other threads. This is in essence what multi-threading is, and our application will look something like this. But multi-threading requires an operating system. And lucky for you, IDF supports FreeRTOS out of the box. Well, what is FreeRTOS, you might ask? It's a real-time operating system, aka an RTOS, that is integrated directly into IDF. And you can use RTOS API, you can use the FreeRTOS API to make a project multi-threaded. So what are some of the key features of FreeRTOS? It's a kernel that is very small and simple. It's free and open source, and it provides all the basic features you might expect out of a real-time operating system. So what would multi-threading look like using FreeRTOS? Well, firstly, FreeRTOS refers to threads as tasks, and each task is implemented as a C function. And each task will generally have an infinite loop, and inside the infinite loop, each task can call FreeRTOS API to block on some event. And you can also call on FreeRTOS API to give some event, and finally, when the task is done running, the task needs to delete itself and never return. So, FreeRTOS tasks can be in one of 4 states at any one time, these states being running, ready, blocked, and suspended. A running task is a task that's currently being executed by the CPU. A ready task is a task that's ready to execute, but it's not currently being executed because the CPU is executing another task. And a block task is basically a task that's waiting for some event. So it won't be executed by the CPU, thus won't consume any CPU time. And finally, a suspended task is just a task that's blocked indefinitely. So some of you might be asking, how can a task be ready? Won't all ready tasks run in parallel? Well, in actuality, a CPU can only ever execute one task at a time. But if the CPU switches between ready tasks fast enough, it will look like they're running in parallel. So if FreeRTOS is switching between tasks, how does it choose which task to switch to? So this brings us to the FreeRTOS scheduling algorithm. In other words, how does FreeRTOS choose which task to switch to? The FreeRTOS scheduling algorithm can basically be summarized as a fixed priority preemptive scheduler with time slicing. Fixed priority means that every task is assigned a priority, and the scheduler always chooses the highest priority ready state task to execute. Preemptive means that the scheduler can switch out an executing task at any moment. This means if a higher priority task suddenly becomes ready, the scheduler executes the higher priority task immediately. And furthermore, and lastly, time slicing means that if there are multiple ready tasks of the same priority, the scheduler will switch between them in a round-robin fashion. And the frequency of this switching is governed by a periodic system tick. So this basically summarizes all of the core concepts of FreeRTOS. Unfortunately, I won't have time in this presentation to go further in depth, so I'm leaving some links to extra resources here. The next important concept of the programming model is memory. So this is a traditional C memory model that you might have learned in school. There's a text section for code, data, and BSS for static data, and the heap and stack go in opposite directions. But what are some issues with this model? If there are multiple tasks in FreeRTOS, shouldn't each task have its own stack? And what if the memory in ESP32 is not uniform? So here's a simplified version of IDF's memory model. There are a couple of things to notice here. Firstly, an ESP's physical memory is not uniform. There are different types of internal memory, such as DRAM, IRAM, and RTC memory. There's also external memory, such as SPI flash and SPI RAM, and these are accessed through an internal cache. As a result, the memory model would look something like this, where there are multiple BSS and data sections for each different type of memory. There's also a heap that can map to different types of memory. And finally, there are multiple stacks that can be allocated statically or dynamically. If you didn't understand any of this, don't worry. The key takeaways that I want you to keep in mind are that the ESP has different types of memory, multiple task stacks exist at the same time, and furthermore, these task stacks can be allocated statically and dynamically. Unfortunately, I don't have time to go further into memory, so I've also linked some resources here. So now let's move on to IDF features. How would you know which feature to use and where to find them? So to demonstrate this, let's work through our previous example involving the button, an I2C sensor, and an LCD. How do I know which feature to use? First, I'm going to break down my project into subsystems. In this case, they're the button, the sensor, and the LCD. Next, for each subsystem, I'll have to look around for a suitable component. In this case, the GPIO driver, I2C driver, and LVGL component would be useful. Afterwards, For each component, I'm going to look at the component's API reference and then figure out how to implement all of my glue logic. In this case, I might use two tasks where the sensor task blocks on a button press from the GPIO driver, and then when a button press arrives, it triggers an I2C sensor read to get a sensor value. And finally, it passes that sensor value to the LCD task using the FreeRTOS queue. Likewise, the LCD task blocks on the FreeRTOS queue, and as soon as it receives a new sensor value, it triggers an LCD update. So now you might be wondering, where do I find these components? There are three main sources for IDF components. Firstly, there are components within IDF. To see what IDF has, simply go to the API reference, and this should list all of the components and APIs you can call within your project. But if IDF doesn't have a component you want, you should also take a look at the IDF component registry. These are components maintained outside of IDF and can be pulled into your project using the component manager. And finally, you have the final option of just writing your own component. But this doesn't mean writing it from scratch. You could also find some third-party library or third-party source code and then turn that into an IDF component. So now some of you might be wondering, what are components? So first, let's talk a bit about our build system and what components are. The IDF build system is based on CMake. This basically means that we've added some custom features on top of pure CMake. What are some of these additions? Well, firstly, IDF has a concept of components, and you can think of them as libraries but with extra features. And to accommodate these components, IDF has had to add some CMake wrapper commands for you to call. And thirdly, CMake is integrated into the IDF PI command, which means you don't have to call CMake directly. When you call IDF PI, CMake gets launched automatically for you. And finally, it's still possible to use pure CMakes, but some extra steps need to be taken. So what are components? IDF component is basically a library with extra stuff in it. Let's look at what an IDF component typically consists of. First and foremost, a component includes source files and include directories. This is the same with a CMake library as well. But a component can also include linker fragments. And these are basically scripts to specify the memory placement of data and functions of the component. And some components also embed binary data. Other components can directly contain precompiled libraries. Almost all of the components have a configuration file. And most components also contain unit tests. While it's possible to incorporate all of these extra things using pure CMake commands, the amount of boilerplate code will be significant. Thus, IDF has provided wrapper commands to conveniently wrap all of these extra things into a single command. So how does registering a component compare to, registering a CMake library? In pure CMake, we might register a library and its source files and then specify other library dependencies. With a component, it's actually quite analogous. There's the IDF component register command where you specify all of the source files and include directories for this component. Then you might specify other component dependencies, and finally, any linker fragments for this component. Likewise, how does declaring an IDF project compare to declaring a CMake executable, for example? In pure CMake, you might create your project and an executable and then list all of the library dependencies for this executable. In IDF, we first pull in all this in the top level CMake file. We first pull in all the IDF CMake wrapper commands. Then we declare the directories of where to look for components. And finally, we declare a project. And that's pretty much it. Hopefully, I've summarized the very basics of the IDF build system. If you want to learn more about the build system, there's a very thorough build system document linked in the slide. So now we've come to our last section, which covers where to get more help and resources. So while you're developing an IDF, you're eventually bound to run into something called a GRU meditation error. So some of you are asking what that is, and basically it just means a fatal error. In other words, an error that's non-recoverable. So let's do a simple demo here to recreate a fatal error. Can you guess what's going to happen here? So hopefully you've noticed that this is a null pointer access, which causes a fatal error. As a result, you should get a panic log that looks something like this. So when you see one of these panic logs, it's important that you not panic, pun intended. There's actually a lot of information that can be gleaned from these panic logs. So let's analyze this panic log. So typically, a log will contain 4 pieces of useful information. Firstly, there's a fatal error cause. In other words, what was the reason for this error? In this case, we access a null pointer, so we should get a stored prohibited error. Next, there's a register dump. These are the CPU register values at the moment that the error occurred. And because we access a null pointer, the exception virtual address register is of particular interest. This basically shows the address access that caused the error, and in our case, it's the null pointer. And thirdly, there's a backtrace. This basically prints the addresses of the function calls that led up to the error. And finally, if we're running IDF Monitor would decode those addresses automatically. So hopefully that basically covers how to understand these fatal errors. If you want more details about fatal errors, please click the link above in the slide. So now, let's say you run into a bunch of fatal errors and you still can't find the root cause. In this case, IDF offers numerous debugging tools. For runtime debugging, we have GDB, which allows you to set breakpoints and also step over the code line by line. However, this requires a JTAG interface. If you can't use a JTAG interface for whatever reason, we also have application tracing and also GDB stub, which just require UART. And for post-mortem debugging, which means debugging after a device has crashed, we have GDB stub and also core dump. Core dump basically dumps some critical information about the ESP32 at the time of crash, such as the backtraces of all the tasks and some register dumps as well. So finally, let's say you've debugged and you still can't find the issue and you're totally stuck. Where can you get help? Firstly, you can consider reporting an issue on our IDF's GitHub repo. If you have a feature request, you can also request on the GitHub, but please, for both issues and feature requests, please follow the issue template. Or if you've written your own feature, you can also consider contributing it to our IDF repo. Secondly, we also have the ESP32 forum where you can ask questions and discuss issues with other users. So, unfortunately, that's all the time I have for today. I hope this presentation has provided enough for you to get started using IDF. Thanks for watching, and I'm happy to take any questions.
Hello, everyone, and welcome to another Q&A session. And for this Q&A, we have Darian. Hi, Darian. How are you today?
Hi, Pedro. I'm doing fine.
Yeah,
Thanks for having me.
Yeah, and thank you so much for this masterclass. So, like, people are, like, really excited about this material. Like, IDF is for some people, like, they're like scared about. So this is something that we are showing that it's not that scary. So first of all, I'd like just to ask you if you have any advice for new developers or developers that they are like starting with IDF right now. How can they get started with IDF in the easiest or more friendly way?
Well, I think in terms of learning IDF, there are a couple of key things that like people need to learn before they jump straight in. Like a couple of, like, first and foremost, like you have to be pretty fluent in C programming to get started with IDF, and also learning FreeRTOS would be like one of the key things you need to learn as well. But yeah, to make things easier, I think they basically like learning like memory, like basics of like some C API, like new lib or like standard C API, and learning how to use FreeRTOS and C programming would be a good starter. And then all of the other things in IDF, you would learn step by step when you like get to the point where you start to need to use them. And I think one of the nice things about IDF is the features are so broad that if you get very good at using IDF, you've pretty much covered most of the skill sets that you need as an embedded software engineer. So I'd highly recommend like fresh graduates or like students to like dip their toes into IDF.
I see. And in addition to that, we have one question that it's related to the material that we create, like videos, tutorials, and like especially for memory configuration, build system, SDK config, CMake, and in general, like things that we are doing to like create this knowledge database. So basically, I could answer this question by like we are planning a lot of content. We are already doing the webinar series. We have this DevCon as well. So this is mainly for like to bring things like for the community, but as well, like we do have our blog, blog.espressif.com. So you can go there and see like a lot of blog posts and as well like some tutorials. And do you have, Darian, anything to add to this topic?
Yeah, I think like in general, like the field of embedded software is more difficult to pick up than like other fields, like pure software, like Python or JavaScript, simply due to the fact that there's not as much like good information out there. And like I like to say that like we are like as an IDF engineer, we are aware of this problem, and we do have some things in our roadmap to like address this, such as like creating tutorials or certain webinars.
Yeah, so we are working hard to, like to bring more knowledge to the community, like to developers community in general. Yeah, so since we have no more questions from the audience, you are like still able to ask in the chat. Like we'll be able to answer after this Q&A session, and of course like during the whole day. And yeah, so thank you so much, Darian, for your amazing talk.
All right, thanks for having me, Pedro.
Yeah, and now we can go back to the studio.
Thanks.
That was a fantastic talk. I always like Darian's talks. He's a very communicative presenter, isn't he?
He certainly is. But it's now time to move on to our next topic, continuous integration.
Right, so as you all know, continuous integration is the practice of automating the integration of code changes from multiple contributors into a single software project. And with ESP-IDF, which is one of the most popular IoT development platforms, we have come up with certain ways of doing it.
Continuous integration plays an important role in our daily development to ensure that our code changes are correct and the result is robust. Our next presenter, Fu Hangxi, covers how we are organizing CI, the open source tools we have created and shared, and how developers can use these tools to set up CI for their own projects.
Great! So let's listen to what Fu Hangxi has to say.
Hi, today's topic would be streamlining development with CI/CD. I will talk about how the benefits you can get and show a template for that, which introduce some best practices. So this talk will basically covers 4 parts, like how we do CI/CD internally and what kind of tools we develop for CI/CD purposes, and how to use CI/CD in your project, and what else can CI/CD do while we're releasing the project. So this is the first part, how we do CI/CD internally. This graph is a high-level overview of our internal process, like what common CI/CD process do. Every time our developers push a commit, a pipeline including static code analysis and build jobs, test jobs will be triggered. If the deadline is passed, the commit will be merged into our main branch. And we also have an extra stage, which is collect test reports to monitor how the test cases goes on various maintained versions of ESP-IDF. And this could help us improve our test coverage in our future development. When we are having a CI/CD process, we face some difficulties. The first one is that we release new target chips every year. Besides, we also need to continue use our old release chips. These kind of workflow makes our test matrix grows larger and larger. The second difficulty is that we also need to support multiple configurations. A configuration is held in a single file called SDA-config, if you are familiar with ESP-IDF. This file usually modified via idf.py menu config to customize the configuration of the project. A single project contains one configuration file or multiple of them to test with a different combination of configuration items. The third difficulty is that when we are researching what kind of test frameworks we can use, we found out that there's a lack of test framework that could interact with multiple serial devices. Some of our tests needs multiple devices interact with each other. For example, a test case that can test the Bluetooth connection between these two devices. And the last difficulty we met is that we also need to support different operating systems and different platforms. For example, for operating systems, obviously it's Windows, Linux, and Macs. And for different platforms, we have to support ESP-IDF, Arduino, and also QEMU. And recently, we are also coordinate with Walkwe, so we can, also considering supporting that. So here are the tools we developed for CI/CD. The first one is called IDF Build Apps. This is a tool to build multiple ESP-IDF applications in the CI systems. This tool is to solve the previous first two issues. Here I linked the repository, GitHub repository, and also the documentation site. You may also scan the QR code to the GitHub repository if you're interested. The second tool is also maintained by us, PyTest Embedded. This is a PyTest plugin that is designed for embedded testing. It can easily interact with zero ports, and I'll go through all the key features later. Here I also posted the repo link here and the QR code as well. First of all, let's go through the IDF build apps. Let's talk about a few concepts here. A project, which is a directory that contains all the required C files and CMake list files, and as well as some additional supporting elements like a partition table or data. And for the configuration, which we mentioned earlier, it is a single file, which is usually the SCA config file. And target here means our target chips. This is the hardware we established. And also the application here is the executable that is built according to the project. So as you may see, different targets and different configurations here. It generates a kind of build matrix for our test purposes. So the key features here for this tool is that it generates build matrix as the last graph. And the second key feature is that it also provides a way, which is the manifest file, for fine-grained control over the build matrix. So in some use cases, some configurations can only be applied to a specific set of targets. For example, we definitely no need to test ESP32H2 with some Wi-Fi test apps, since ESP32H2 does not even support Wi-Fi. So with this feature, we can save both CI resources and our developers' time. And the third key feature is that this tool also supports skip the build slightly according to modified components and files. The next tool we built is PyTest Embedded. This graph shows the workflow of what does the plugin help the developers do before running the test. So this is basically about the setup phase. First of all, it would check the build binary, which is the app, and gather the app info. For example, the target, ESP32, or those configurations. And if we're testing it on QEMU, it will first merge the binaries into one single image. So QEMU will use this image, this bootable image, execute it, and create a process and redirect the output of the QEMU process into our the main test process. And when we're testing it on a real target, well, we usually test it on a host machine, which connects to our ESP boards. For example, the host machines could be x86 machine or even a Raspberry Pi. So the host machine will connect it to our, and the PyTest embedded plugin will detect the port, the serial port connected to our board, and flash the app via the serial port, and then run the test script. It also got a few key features. The first one is it supports all the operating systems and platforms, as we mentioned earlier. And the second one is that it can run on different platforms without any code change. So basically, you don't need to modify your test scripts, not a single line, just run with different CLI parameters. I'll show you later. And the third key feature is that it will automatically set up the firmwares while set up. So the developers mainly can only focus on the test case itself. No need to worry about which platform I'm in or which operating system I'm in. So here, this slide shows that we can use this script to test on different platforms. This part is a very simple, basic test function, test hello world. So basically, it only expects the hello world string from the serial output or the QEMU output. So for example, if we're running it on the Arduino platform, we can pass this with a parameter called embedded services ESP Arduino. Different parameter will enable different modules. So internally, it will call different functions. So for ESP-IDF with real target, we can pass parameter as ESP-IDF. And with QEMU, we can pass the parameter with IDF and QEMU. Okay, so this is the third part, how to set up the CI/CD for your project. This is a release process, very simple. Like we suppose all the commits will be made in the dev branches, and the dev branches will be merged into the main branches, and only release these the main branches by tagging. So each tag represents a production release. So on the dev branches, we create pull requests. Pull requests will trigger a pipeline, which includes only build stage jobs and the test stage jobs. On tag triggered pipeline, which is the production release, it includes build stage jobs, test stage jobs, and the release stage jobs. On the GitHub Actions, we can also test with real targets and test with QEMU. For real targets, GitHub also supports, we set up the self-hosted runners connected with ESP devices. So if you have some free Raspberry Pis, you can connect it with ESP devices and follow this link. This link will guide you how to add your Raspberry Pi into a GitHub runner. In this demo, we will show you how to test with QEMU. This is much simpler. Like if your project is an open source project, you can, well, it's free, totally free. And you can, the ESP-IDF QEMU is still in beta phase, but you can try it right now. Here I also linked one of my repo, also the QR code here. This repo includes the QEMU Docker file and also the slides, today's slides. Okay, so now I'm going to show you a demo with the real GitHub Actions. So this is the QEMU Docker file which I created. It's based on Espressif IDF Docker image, as you may see here, and it includes the latest release of our QEMU as well. Here it installs all the required runtime libraries, and that's it. It also deployed to the Docker Hub, so you may also use the link I posted earlier, Docker Hub HSU Dev QEMU. And this repo is a template repo that you can use directly by clicking use. Here, this workflow includes that a variety of build matrix jobs for different ESP-IDF branches and targets. And later on the test stage, it will include also QEMU test jobs, apps built by the last step. On the last step, it will also upload all your artifacts, so you may check it on the summary tab of the GitHub action as well. And on the release stage, which will be triggered on the tag pipelines, it will also publish to our component registry. This file is called build and test application. So here it defines a few variables and run with only C code modification with pull requests. This is a build jobs. As you may see here, we defined a matrix of IDF branches and targets. It will run with our maintained, self-maintained Docker image, Espressif IDF. It supports all the maintained release branches Docker images. Here is first install all the required Python dependencies for build, IDF build apps, and then build the test applications with ESP-IDF. Here it calls method and upload the required binaries. The ELF file here listed is not required, it is optional. It could help you debug when your app fails the test. And this shows the target test. Target test will be run on QEMU. Here the test matrix is as defined earlier, the same, IDF branch and target. It will first download the artifacts built on the laptop, install all the required Python packages, and run the test app. Finally, it will create JUnit reports and upload the artifacts. This is the published component GitHub action. It will be only triggered on the tag pipelines. It will push the component to the component registry. As you hear, we also maintain the GitHub action called upload components CI action. Once this job is successfully run, we can our uploaded component via our component registry, components.expressif.com. So other developers may also use your component, and the release is done. Okay, so the build stage includes the build matrix jobs, the text matrix job, and on the release stage, we release to the component registry. This is the workflow of GitHub Actions. And finally, What else can CI/CD do while releasing? First of all, you can sign your app with HSM. HSM is a way that we can secure our built binaries with hardware. You may also deploy your app with ESP Insights. ESP Insights is a tool that we can deploy our built binaries into network-connected devices. We can also generate software bill of materials. This is a file that can show you all the dependencies. Here I also posted all the QR codes aside. And thanks for watching.
Hello, everyone, and welcome to the Q&A session. And now we have the speaker here in the studio, Hanxi. How are you today?
Feeling great. Hi, everyone.
Yeah, nice. So for the first question, we'd like to ask you, like, if I got like a small project, shall I follow the same process?
Not really. Like the IDF Build Apps tool is made for the CI perspective. So if you got a huge build matrix, you may use it perfectly. When you're having a small project, calling idf.py build directly could be a simpler solution. And we also have a GitHub action called Espressif /ESP-IDF CI action. It's another good GitHub action repo. The only thing that matters to the PyTest embedded is the binary path of your test app, which you want to flash into the DUT. And the default value is the build directory, and you may also override it by extra CLI arguments or parameterization inside the test script.
Okay, thank you. And can you just talk about the future plan of the IDF Build Apps tools?
Yeah, this is a quite interesting tool, and we use a lot in our internal CI process. We will support JUnit XML report output in the next release. The report can also include a lot more information, like the build machine specs, the build time, build logs, build errors, etc. The build could the report could be used by like collecting different CI/CD reports and other purposes. And the maintainer could use this information to track or optimize the whole build process.
Okay, nice. Thank you. So thank you so much for being here with me in person. So I'm not alone in the studio. And thank you for like giving your talk, sharing your knowledge with our audience. Yeah, thank you.
No problem.
And now we can go back to the studio.
See you guys.
And now it's time for the first guest speaker of the day, Gabor Kishvamoshi, a really skilled software developer. His expressive lies within embedded systems and graphics programming. In fact, he is the creator of LVGL, an open-source graphics library for embedded systems that is known for its efficiency and versatility. Gabor has a deep understanding of the challenges in developing software for resource-constrained embedded systems. A tangible proof of this is his work on LVGL, which has been widely praised for its efficiency, versatility, and ease of use.
Today, Gabor will introduce the beta version of Squareline Studio V2, which is a complete rework of the current user interface editor. The new Squareline Studio has a much better UI and UX, as it runs in a browser. Many new features such as the timeline animation editor, advanced file manager, and real-time collaboration will be supported out of the box. Gabor will demonstrate how the new Squareline Studio works and how you can easily export a ready-to-use UI project for ESP-IDF. So, let's attend his presentation carefully.
Welcome everyone. In my presentation, I will talk about introducing Squareline Studio version 2. My name is Gábor Kisrámosi, and I'm the author of the LVGL library. I published it in 2016 on GitHub, and since then I'm leading its development as well. In 2020, I have established my company called LVGL LLC. With this company, we are doing some UI-related services like UI development and consulting, and we need this company just to have a legal background for the open source LVGL library as well. In the presentation, I will introduce you LVGL itself, the current version of Squareline Studio, which is version 1, the new version of Squareline, and of course, I will talk about our future plans as well. Let's start with LVGL. So LVGL stands for Light and Versatile Graphics Library. So it's a graphics library which helps you to create impressive user interfaces on resource-constrained embedded devices as well. It's a full-featured solution. It comes with more than 30 built-in widgets like charts, keyboards, sliders, bars, drop-downs, and basically you can find all the widgets in LVGL that you can see in an Android or an iOS application. It comes with a powerful style and layout system as well. These are inspired by CSS. CSS is the styling scheme of the web pages, so the same concept which makes the web pages so powerful and versatile is available in LVGL as well. It comes with a powerful typography support too, which supports many languages. It includes the Asian languages like Japanese, Korean, or Chinese, the Asian and Persian languages, including right to left and left to right, writing directions, and of course, all the Latin-like languages as well. It's a free and open source solution, which is fully available on GitHub and distributed under MIT license. In the practice, the MIT license means that you can use the software in a commercial project as well. You only need to add a sentence in your documentation, user guide or README, stating that we have used LVGL in our project to create the user interface. And that's it. You can use LVGL for free in any project. I can proudly say LVGL is a quite popular solution. It's downloaded in every minute from GitHub, and it's already supported by the leading vendors of this industry. LVGL runs on basically on any modern device. It includes any microcontroller, any microprocessor with normal or real-time operating systems or bare metal as well. And you can drive OLED, monochrome, e-paper, TFT displays, or even monitors with it. On this slide, you can see a few UIs that we have created with LVGL and Squareline Studio. If you click on this link, it will open our website, which is lvgl.io, and in the demos menu, you will find something more interesting. These are interactive examples, so you can click on these buttons and try out how an LVGL UI looks like in the practice. So on this first demo, we call it widgets demo because it shows most of the widgets of LVGL with a default style. So if you create a button, it will look like this. For example, the scroll bar of the pages look like this by default. So if you just create a few widgets, they already have a nice appearance. Here we have a slider, some switches, a text area and a virtual keyboard. This text area is a password version. Here you can pick a date. Here you can check out some charts. This one is a line chart. This is a bar chart. And some meters after that. And on the third tab, we have some other charts and some lists. This nice scrolling behavior with this momentum and elastic scrolling at the end is working out of the box in LVGL. You can also change the main color of this theme with one click. The second UI is an example UI for an e-bike. It was created in our UI editor tool called Squareline Studio without writing a single line of code. So this whole UI was put together only by a designer. The third one is a smartwatch. It was also created in Squareline only by a designer. Yeah, that's it. We have some more demos here. You can check out all these later if you wish. A few words about our services. So with LVG LLC, we are doing various kinds of services to make the UI development simpler for you. First of all, we are doing a graphics design. It means you can just send us some layouts or hand-drawn screens, or just describe what you want to see on your final user interface, and our designers can develop beautiful screens for you, considering the limits of your hardware. We can also implement the UIs that we have designed, or we can also work based on the designs that you have provided. Besides that, we can help you with optimizing your drivers. If you have any questions with GPUs, DMA, caching, or other things, how to buffer the rendered images or things like these, you can contact us and we can talk about all these questions. We are doing a general consulting service as well. So if you have graphics designers, UI developers, and hardware experts as well, you might still have questions about how to implement things, how to solve specific issues, how to approach a problem, what are the best practices. So if you have questions like these, you can also contact us and we can talk about all your issues. And finally, we are doing a board certification service. It's for board manufacturers who create displays and boards together and sell it to their customers. These board manufacturers can send their devices to us. We run a benchmark demo on them, and record a video, write a blog post, and publish the results. This way, the users can compare all the boards that we have certified in a fair comparison, because all these demos are running the same. All these boards are running the same demo, so it's easy how they perform compared to each other. If you would like to use LVGL in the Espressif ecosystem, you can do it very easily because LVGL is available in Espressif Component Manager. I can proudly say that it's the second most downloaded component with more than 300,000 downloads. Let's continue with Squareline Studio. So Squareline Studio is the official visual drag-and-drop UI editor of LVGL. Its main purpose is to make the UI development faster and simpler. Using Squareline Studio, even a designer can create fully functional UIs. Our goal was to make it possible for the designer to create as much things as possible in Squareline Studio and leave only the application logic, the API, the business logic, and the real programming stuff to the software developers. Squareline Studio comes with a flexible licensing. First, you can try it out in a 30-day soft trial period. After that, you can use it for free for personal purposes, or you can choose you can choose from our cost-effective subscription plans for professional business use cases. The first version of Squareline Studio was released more than a year ago in 2022 February. Since then, we have more than 30,000 users, and it's already used by very large companies with billion-dollar revenue range. Instead of just talking about the main features of Squareline Studio, I'd like to show it to you in the practice. So this is the software. Here you can create a new project, or you can load an example. I will use this 3D printer to demonstrate what you can do with Squareline. Just click the Create button. Wait a few seconds while it's being created. Okay, so here you can see the screens of this user interface. And if you go to the project settings, you can see that now the target for this UI is some desktop environment. However, you can easily change it to Espressif, select a development board like this one for S3, click the Apply Changes button, and that's it. Now if you export a project, it will work on the selected development board. So you can change the target board at any time during the development. Okay, let's see what we can do with Squareline Studio. First of all, what you can see here is a pixel-perfect preview. So the UI that you design in Squareline will look exactly the same on the target hardware than what you see here. If you click on these widgets, they are selected and their position can be changed. However, if you click this play button, the UI will be interactive immediately. You don't have to compile it, start it as a separate application. You can just click on this play button and try out the UI. As you could see, the animations were played, and now this button is active. So if I click on it, it will load the new screen, play the animations again, and we can just try out our UI. Similarly to the other UIs that we have seen with Squareline Studio, this one was also created only by a designer. Okay. The things that you can do with Squareline Studio are organized into these panels. So we have the widgets panel here, where you can see the basic building blocks of your UI. You can choose an arc, button, image, label, panel, tab view, text area, calendar, and many others to build up your UI. We also have a hierarchy panel where you can see the structure of your user interface. As you can see here, you can see the widgets in a nested hierarchy. So a parent widget can have children, and those children can have adult children, and so on. On the right-hand side, we have the inspector panel, where you can change the name of the widget, some layouts and coordinate-related properties. You can change the alignment. Here we have some flags to make the widget hidden or visible, clickable or not clickable, and some other options like these. Below that, you can set the state of the widget. For example, a widget can be checked and disabled or focused, and any combination of these. For example, a checkbox can be checked and disabled at the same time, which is really a valid use case for this combined states. Below that, you can change the properties of the given widget type. Right now, this label is selected, so we can see the label-related properties here. To change the text, you can just write something new here. Below that, we have the style section, where you can apply some new styles to change the appearance of the widget. For example, if I want to add some background here, I need to open the background section. I will pick a color from here, some lighter blue. Let's adjust it a little bit. I can add some radius as well. All these are rendered in real time by LVGL under the hood, so you don't have to use images for all these effects, but you can set them dynamically and also change them dynamically as the UI is running. We can add some space between the edges and the content, and also change the color of the text. Something like that. I'd like to show you another important thing in the first version of Squareline Studio, and these are the components. Typically on every UI, there are items which are used multiple times. For example, this button is used here, but it's used on the next screen, and here as well, and here as well, so many places. If you just create these buttons one by one and you need to change something, it would be very boring and time consuming. Instead, you can just create this button once. I show it in the hierarchy. So we have the button here and we have a label on it. Once you have created this small group of widgets, you can convert them to a component. The components that you have created are shown here. So for example, we have this button component here. And now you can create any instances, any number of instances of this component. Moreover, if you click this Edit Component button, and you change a style here, for example, the color of this label, let's make it blue. And if you save the component and go to the next screen, you can see that it's updated here as well. And of course, on this screen as well. So it's super easy to change the appearance and the content of these components. Once you have created your UI, of course, you can export it. You can create a template project. If you have selected an Espressif development board, it will create ready-to-use projects for the development board, or you can just export the UI files. These UI files that you can export are platform independent. These are just simple C files containing LVGL function calls, and of course your UI as well. So you can export these files into any project. You can put together your custom project on any hardware, and you can select a folder where these UI files will be exported. Okay, that's it about the first version of Squareline. Oh, just one more thing. On the launcher screen where we have created the project, you can also select the development boards directly. So you can start a new project on a given development board. But as I mentioned, you can change the development board during the UI development process as well at any time. Let's continue with the second version of Squareline Studio. Again, instead of just talking about the changes, I like to show it to you in the practice. Okay, so this is the second version of Squareline Studio. You might immediately notice two things. The first is that it's running in a browser. While the first version was a normal desktop application, the second version of Squareline Studio can be opened in any web browser. This way, you can edit your user interfaces from any places, and you can access to all the assets, all the projects, anywhere you are. The other thing that you probably noticed is that the style and the design of the new version has been completely changed. We have optimized it a lot. We made it a lot cleaner and easier to use. You can still see this play button. So this instant play mode is still available. And here we have a pixel perfect preview again. So what you will see here will be exactly the same as it would look like on the target hardware. You can also change the position of these panels to customize your workplace. You can, for example, move this terminal here, and the screens panel, let's say here. Let's move it back for now. The widgets are moved to this top bar. So you can just select a widget here. Let's say we want to select an arc. On the inspector panel here, you can easily align it to the center. And if you click the play button, you can just try it out. Okay. I will delete this arc. And now I will show you how to put together a nice UI and also show you the great features of Squareline Studio version 2. Here we have created a few assets to get started with. You can just select all these and drag them into this assets panel. I drag this image to the screen to create it, align it to the center. This will be our reference, so this will be the UI that we want to put together right now. Let's create a new screen. And add the background image to it. Align it to the center. And let's continue with this panel. We will get started with a panel widget. I will try to set roughly the same size. And now we need to change its style. Let's go to the styles panel. And here you can see that we have the local styles. These local styles are applied only on the given widget. In Squareline Studio version 1, only this option was available. However, in the new version, you can create new styles by clicking this button. We have this new style. Let's change its name to gray panel, for example. And let's add it. To this gray panel, we can add some style parameters or style properties. We want to change the background color, the background radius, and by default, this panel has some border, so we need to set the border width as well. The border width is 0 by default, so when we add it, it will remove the border automatically. By clicking on this color, you can just pick a color for this panel. Let's pick it from the background. Okay, and let's change the opacity a little bit. Okay. And set some radius. All right, let's create some labels. 1, 2, 3, and move these labels into the panel. Now, if you move this panel, all its children will move with it as well. Okay, let's select the first label, change its text. It should be temperature. And here, let's create a new style. Let's call it white text. And the only style property that we will add is the text color. So text color. Let's change it to white. And now our label is white. We will try the local style properties as well. As you can see, the label on the reference image is a little bit larger. So as a local style, we will add the text font. And here in the list, we can select the fonts that we have added here. We will use the subtitle font. Oh, sorry. We will use the title font here. Okay, let's continue with the second label. Now we have this white text style, so we select and add it, and now it's white. As a local style, we will add the font again. It will be the big number. This font only contains the numbers, so we need to use numbers here. This way you can save some memory by using only the required characters in the font. And finally, for the date, we are in the future, so the year is 2455. Okay. Let's add the white text again. And for the local styles, the font. It's a little bit overflowed. You can see the scroll bar here, so we can just arrange the labels a little bit. Okay. And now the great thing is that as we have used this white text style for each label, if you change the color of this white text style, all the labels are changing. Okay, let's put together this fancy button. We will get started with a button widget. Let's center it horizontally. Put it to the bottom. Okay. Let's add the label to it. Center this label. Change its text. And let's start styling this button. We will create a new style again. Let's call it button. Edit. And let's add some parameters here. We need to change the background color again, the background radius. We will add some shadow. You can see that this reference button is like glowing. We will add the shadow color, shadow width, and shadow spread. For the color, we will use a gradient. You can just click here to create a gradient. Let's make it vertical. Here you can adjust where the colors should start. Let's make them start from the end. And for the first color, let's pick this blue from here. And for the second color, this purple from here. Let's make it a little bit more saturated. All right, and make it a little bit transparent. Let's set some radius and add the shadow. Let's use this color, make it spread, and now it's glowing. We can also change the text style on the button because the labels will inherit the properties from here. So we can add some properties like these, the text color, let's make it white, and use the subtitle font. And here it is. Now if you create a new button, and add the style to it, like this button style, it will look like this. So it's easy to create similar looking widgets this way. And that's it very briefly about Squareline Studio version 2. Just a few words about our future plans. We are planning to release the second version of Squareline at the end of this year, but it will still support some great features like real-time collaboration. This way, multiple designers and developers can use and work on the same UI. It's the same concept that Figma is using. Figma is a very popular UI prototype development software. So you can just people can just open the same URL. Some people might have write access, they can edit the UI. Some others might have only read access. You can also invite people to show them your UI. We will also add an animation timeline. So it's an animation editor where you can put together complex animations easily. We will also add an image editor. It will be like a simple Photoshop where you can manage your image assets or create your image assets in a central place without leaving Squareline Studio. And finally, we are planning to add a visual script engine, so it will be easy to put together complex logic for your UI in a visual way. This way, even designers can do more and can add more logic into their user interface. And that's it. Thank you very much for your attention.
Welcome everyone to this live Q&A session. And to answer the questions we have here, Gabor. Hello, Gabor. How are you today?
Hi, it's a pleasure to be here. All good. Thank you very much.
Yeah, so I'm really happy to see you here at DevCon23. So welcome to Espressif DevCon, and I hope you are enjoying the whole content. We have some questions here, so we can go to the first one, which is there any table of hardware requirements, especially for ESP32XX, which stands for like the whole ESP32 family, depending on, for example, like screen resolution and number of colors?
I believe all ESP32 chips are powerful enough for LVGL and Squareline Studio, so you don't have to worry about it. If you pick any of those chips, they will be good enough for a decent UI.
I see. And I'm pretty sure that if you go to the LVGL website, you can check if the development board is compatible. Is that right?
Almost. On our website, you can see, of course, the certified boards. But if you go to Squareline Studio and open Squareline Studio version 1, you can see some ESP development boards which are already supported out of the box. So you can export a ready-to-use project for those development boards with one click.
Okay, I see. Okay, thank you. So for the second question, is, so is it possible to make an ESP smartwatch using LVGL?
I think it's absolutely possible, as the ESP chips already supports a lot of radio-related features like Wi-Fi and Bluetooth, and they are powerful enough to drive even a higher resolution display. I think, yeah, the ESP32 chips with any subfamily are a very good choice to do a smartwatch.
Okay, yeah, thank you. We have here one more question, which is, what about the compatibility between Squareline Studio V1 with the version 2? Can I move my projects easily?
Normally, we have rewritten how the project file is structured, how it stores the data. So by default, the Squareline Studio version 1 projects are not compatible with version 2. However, we will provide a tool to make this conversion, so you will be able to import or convert the version 1 projects to Squareline version 2.
And just in addition to this question, it is easy if I want to move, like, for example, like from ESP32 to ESP32 S3, like if I'm using already the ESP32, if I want to go for the S3.
Actually, it's super easy, because the UI which is exported from Squareline Studio is completely platform independent. So the exported code contains only LVGL code, which could be written by yourself as well. It just saves you the manual programming work. So there are no hardware-specific code in the exported code at all, and they can be just copy-pasted into another project without any issues.
Okay, cool. So I think we have no more questions from the audience. Okay, so will Squareline? Sorry, we have one more question here.
Okay.
Will Squareline V2 replace the app version, or will you still continue to provide a standalone app on V1?
Sorry, how do you mean it? I don't really get it.
So yeah, I will read it
I see
again.
the question
So
in YouTube. Yes, just a
yeah,
second.
sorry.
I believe the question is related to the online version of Squareline Studio version 2 and whether we will have a desktop standalone application for version 2 as well.
I believe so. Maybe Marius could give some more details.
Yeah, normally our main target for Squareline Studio version 2 is to have it as a web application running in your browser. And the reason for this is on web, the collaboration in your team is much more simpler. As I mentioned in the presentation, anyone from your team just can open the same project in a web browser, and you can see the other people doing things, editing the UI. So everything is always in sync. However, if you are using a desktop application, you will have your local copy on your desktop, and merging the project with the changes of your team member, it's super complicated and not really feasible. So therefore, our main focus is on the online version running Squareline in the web browser. However, for larger companies, as an enterprise solution, we will provide this whole web part, so they will be able to install it on their servers and running it locally inside the company network.
Okay, thanks. Yeah, so we will continue answering the questions in the chat, like after this live Q&A and during the whole DevCon. So Gabor, thank you so much for answering the question and for being part of Espressif DevCon23.
Thank you very much too. Have a nice day. Enjoy the conference. Bye-bye.
Thank you. So, and now we can go back to the studio.
Now it's time to pop back in our office in Shanghai. By the way, Radim, have you ever been to Shanghai?
Unfortunately, I have not, but exciting news, I'm going there this October.
Stop it, seriously?
Yep, I'm very excited.
I bet you are. I'm going there in November. You should have said something so we could plan this together.
Really? Well, you know what they say about introverted engineers. When an introverted engineer like me talks to you, he looks at his own shoes. Well, when an extroverted engineer is talking to you, he looks at your shoes.
I see.
Well, so when it comes to traveling, I prefer to do this on my own or with my girlfriend.
Fair enough. In any case, exciting times anyway, because our Shanghai Director of Product Engineering, Wu Jianggang, and Application Engineer Liu Zhongwei will talk us through Espressif's HMI Smart Display solution. Espressif's HMI Smart Displays based on ESP32S3 and ESP32C3 SoCs are designed to support RGB and SPI interfaces. These solutions have an innovative user interface which enables data visualization, touch or knob control, voice wake-up and recognition, as well as a multi-mode gateway.
So at the beginning, the guys will contextualize their presentation by exploring how widespread the use of liquid crystal displays in IoT gadget is nowadays. Then they will present various Espressif-based solutions and the performance they can achieve in smart home scenarios. At the end, they will give us a practical development guide, including everything from driver porting and application development to performance optimization. This should enable developers to quickly start their HMI projects based on Espressif chips.
Hi everyone. We gladly welcome you to the 2023 Espressif Development Conference. I am Jian Gang, the Director of Application Engineering at Espressif. The topic of today's session is Espressif HMI Smart Display Solution. In the following presentation, my colleague and I will introduce practical chip selection guides and development experience for Espressif Smart Display Solution. This presentation is divided into 4 main sections. First one, brief overview of market trend. Second, expressive LCD solutions and chip recommendations. Third, application development guide based on ESP-IDF. Fourth, anti-tearing strategies for LCD displays. Yeah, we are from Espressif Application Engineering team. Our team plays a vital role in providing comprehensive technical support and assistance to customers and partners using Espressif products and solutions. We are committed to providing innovative and reliable wireless intelligent solutions for a connected world. Now that we have a clear understanding of the agenda we will cover today, let's move on to the first section, where I will provide a concise overview of the market trends in the field of display applications. Additionally, I will share the opportunities and advantages of Espressif Wi-Fi MCU in this evolving landscape. In the current era of 5G and IoT, the application of LCD screens has expanded beyond traditional areas, such as smartphones, tablets, and automotive displays. In smartphone scenarios, appliances like refrigerators, washing machines, air conditioners, microwaves, induction cookers, and robotic vacuum cleaners are increasingly incorporating LCD screens. The interaction in screen applications has also witnessed diverse developments. First, from resistive touchscreens to capacitive touchscreen, from single touch to multi-touch capabilities. Touchscreen has become an indispensable part of modern embedded systems, with an increasing number of LCD screens integrating touch functionality, enhancing the user experience through direct finger input. Secondly, as voice recognition technology rapidly advances, there is a growing demand for voice interaction in modern smartphone products. Users can remotely control devices through voice commands, simplifying the operation process. In addition to online voice recognition, the need for seamless wake-up and offline voice recognition is also increasing. Moreover, in daily life, many simple yet precise interactive operations, such as adjusting the brightness and color temperature of light or opening and closing curtains, can be achieved more quickly, accurately, and conveniently by combining LCD frames with knobs. We can already see that in appliances such as microwaves, washing machines, and water heaters. This development in LCD screen applications and interaction methods showcase the continuous evolution and increasing versatility in the HMI environment. Now, what are the advantages of LCD products driven by a Wi-Fi MCU chip? Firstly, the key advantage is its high integration. With a single Wi-Fi MCU chip, the LCD product can deliver UI display, screen control, voice interaction, Wi-Fi, and BLE functionalities. This not only reduces hardware costs, power consumption, and size, but also simplifies software development and maintenance. Secondly, the lightweight operating system is a major benefit. By utilizing a lightweight real-time embedded OS like FreeRTOS, the system requires fewer hardware resources, lower power consumption, and provides faster response speed. It's a perfect fit for efficient IoT product development. Lastly, LCD solutions offer versatility. They can integrate smart home control, health monitoring, entertainment, and security features. Users can customize smart control scenarios based on their specific needs, enhancing the visual appeal of smart central control products while providing a delightful user experience. Now that we have gained insight into the market trends and the evolving landscape of LCD applications, let's move on to exploring Espressif LCD solution and the recommended chips that empower these smart displays. To begin, let's take a comprehensive look at how Espressif chip series support specific LCD screen interfaces. The ESP-32S series and ESP-32P series chips now offer support for interfaces with higher transmission bandwidth, such as RGB and BPDSI. These chips can drive higher resolution screens. To facilitate chip selection, we have considered the performance, power consumption, and cost requirements in both IoT and LCD application scenarios. Currently, our focus is on three main chips: ESP32C3, ESP32C6, and ESP32S3. We have categorized them based on several common LCD resolutions, and you can find more details in the provided table. Now, let's move on to the solutions. First, I will introduce the knob screen solution. Knob screens are known for their simplicity and user-friendly interface. Instead of searching for and tabbing specific buttons on the screen, users can control devices by simply rotating the knob. This provides better user experience, especially in scenarios like controlling lights in a dark environment. Espressif offers a complete knob screen solution for 1.28-inch SPI and 1.6-inch QSPI interface round screen. It includes logic for UI interaction and design guidance for product structures. Knob interaction has become a cost-effective upgrade solution for widely recognized and adopted by home appliance manufacturers. With the small chip package, Espressif solution seamlessly integrates with various well-designed knob structures. Next, let's talk about the central control panel market. Central control screens serve as a core control center for smart home systems, enabling control and monitoring of various smart devices within the home, such as lighting, temperature, security, music, and appliances. Users can conveniently control all the devices in their smart home system from one central control screen, providing a seamless and efficient experience. For 3.95-inch 480 plus 480 resolution and 4.3-inch 800 plus 480 resolution RGB interface screen, Espressif offers a smart central control solution based on the ESP32S3 chip. This single chip solution integrates wireless connectivity, UR display, offline voice recognition, and screen control functionalities. Additionally, the central control screen can serve as a gateway for smart homes, utilizing the powerful Wi-Fi mesh and VoE-mesh networking capabilities to centralize the control of various devices within the home. If you are interested in the development boards and solutions discussed in this presentation, we encourage you to get in touch with us through our business contacts. Lastly, let's discuss the Visio doorbell market. This doorbell utilizes cameras to provide users with real-time video of visitors on the screen. They also feature a microphone and a speaker for two-way communication with visitors, as well as remote monitoring capabilities through cloud connectivity. Visio doorbells have become popular smart home devices in the market. Espressif recommends a Visio doorbell solution based on the ESP32S3 chip. This solution incorporates a 720p USB camera and an RGB interface display screen with an 800 plus 480 resolution. It supports local video decoding and screen refresh rates of up to 15 FPS. The ESP32S3 chip natively supports USB 2.0 and offers a rate set of peripheral resources, eliminating the need for additional USB chips or DSP chips. With this single chip solution, you can achieve front-end audio processing, voice interaction, HMI interaction, and real-time network calls, all at a highly cost-effective value. Next, we will move on to the most crucial and informative section of this presentation. In this section, my colleague will give you a through of software development process for LCD solutions and share our experience in dealing with the tearing effect. Yes, welcome, Liu Zhongwei.
Hi everyone, I'm an FID software engineer from Espressif Application Engineering team. In the following chapter, I will dive into the development guide and cover topics such as framework, driver porting, and application development. First, let's take a look at the hardware frameworks of the LCD solution. These frameworks help us understand how LCDs are driven. For most SPI and IAT LCDs, ESP can use the same interface to transmit commands and the area size color date to the LCD IC. And the LCD IC stores these states in its internal frame-sized graphics drive, which is usually called GRAM. Then it displays the color dates from the GRAM on the panel at a fixed refresh rate. It's important to know that these two processes are asynchronized. For most RGB LCDs, ESP uses a three-way SPI interface to transmit commands and uses an RGB interface to send frame-sized color dates. Since the LCD IC lacks an internal drive, it directly displays the frame-sized color dates onto the panel. These two processes are synchronous. When comparing these two hardware frameworks, we can see that RGB LCDs, unlike other LCDs, require ESP to use two different interfaces for transmitting commands and color dates. It also demands ESP to provide a frame-sized drive. Since the space of drive is limited, we often place the drive in piece drive. In addition to that, for QSPI LCD, different ICs may require different driving methods. For example, SPD2010 has a GRAM, and its driving method is similar to the live framework. However, SPD77903 doesn't have a GRAM,
and its driving method is similar to the RIDE framework. However, both of them use a single interface for transmitting commands and data color. Since the QSPI driver is not universal, I want to introduce it further. For screens with a touch IC, ESP can read the coordinates of touch points through either I12C or SPI. Now, let's explore the software framework, which is primarily composed of three layers: the SDK layer, the driver layer, and the app layer. Firstly, in the SDK layer, we use ESP-IDF as the foundational part. It not only includes the necessary peripheral drivers for LCD solutions, such as I2C, SPI, IAT, and RGB, but also provides users with the unified APIs through the ESP LCD components to interact with the screen, enabling operations like refreshing, inverting, and mirroring. Like with the driver layer, we need to port the drivers for the display device and input device, such as different models of LCD IC and Touch IC. Additionally, we use these device drivers to implement the porting of LVGL. Lastly, in app layer, we can directly develop GUI applications based on LVGL. Based on proceeding framework, we have summarized the following 5 development steps. Firstly, initialize the required peripherals, then create the display device and the input device, like port LVGL. Finally, design the GUI. I will explain them using existing code examples. For devices with I2C, SPI, or IAT interfaces, the first step is to initialize the related path. Then we can use the ESP LCD component to install the panel IO instance. Taking the SPI device as an example, the code is shown in the figures. For devices with an RGB interface, most of them use a three-way SPI interface for transmitting commands, where the RGB interface is used to transmitting color data. Since ESP's SPI hardware doesn't support long-byte aligned state transmission, we have developed the ESP LCD panel IO addition component, which debunking the three-way SPI interface. We can use this component to create the panel IO instance. This step can be skipped for LCDs that don't require initialization. Based on the panel IO instance, we can use these APIs to implement functions like transmitting color, dates, or commands. Next step is to create a display device. Currently, ESP-IDF and the component registry support various LCD drivers. For example, we can create an ISP7789 device based on the panel IO instance. The code snippet for this is shown in the figure. It's important to note that vendor-specific initialization can be different between manufacturers. We should consult the LCD supplier for initialization sequence code and make necessary modifications to the driver, as shown in the figure. If the required device is not supported, you can refer to existing similar drivers for porting. We can also create the required input device based on the panel IO instance. The component registry also supports various touch drivers such as GT911, FT506. What's more, it also supports node and button drivers, which is also served as input devices. The next step is to port LVGL. The detailed introduction of this part can be seen in the LVGL functional documents. And other LCD examples in IDF have implemented LVGL porting. For SPI and IAT LCDs, we can also use the ESP-LVGL port component. However, this component currently doesn't support RGB LCD, but we can refer to the ESP32S3 LCD port ESP for implementation guidance. Finally, we can design UI by coding. Here is a simple demo. Create a button, set its position and size, then register a callback function for events. Of course, LVGL provides us a lot of examples. However, we can also use the Squareline Studio software, which is the visual UI editor alongside LVGL, allowing users to design beautiful UI through a graphical interface and directly generate code. Currently, it supports various ESP development ports, including ESP-Box, ESP-SAR, ESP32S3 LCD port. Regarding the introduction to the LCD development guide mentioned above, due to time constraints, I welcome everyone to reach out and discuss more interesting topics with us. In the upcoming section, I will delve into the topic of screen tearing. Screen tearing is a commonly encountered issue in LCD applications, which can negatively impact the viewing experience and the overall visual quality of the display. I will discuss its causes and share our experience in dealing with this problem. First, what is screen tearing? It's also known as tearing effect and often appears when there are GUI pins, resulting in a frame that includes two different parts, causing a noticeable discontinuity on the screen. These two pictures were taken while running LVGL demo, and you can see the screen tearing is evident. So, how does tearing appear? I will demonstrate it later with an animation showing the process of screen refreshing. But first, let's take a look at this static diagram. It consists of two parts, GRAM and panel. GRAM represents the storage area, where ESP can directly read color data, and panel represents the visual area, where the LCD reads from GRAM and display on the screen. As you can see, screen refreshing primarily involves the process of GRAM's writing and reading. Here, let's assume that the speed ratio between writing and reading is 1:3. Start the animation. We can see that when the read position overlaps the write position in the middle area, the second frame on the panel pierce tearing, which lasts for one frame duration and is noticeable to the human eye. SLD. Now let's try to increase the write speed to achieve a ratio of 1:2. Start the animation. We can see that the read position aligns with the write position at the end of a frame. No tearing appears. Therefore, when the write speed is less than half of read speed, tearing will appear. In fact, tearing can also appear when the write speed is more than twice the read speed, but this situation is unlikely to happen. Additionally, in previous demonstration, we assumed that the initial states of writing and reading were synchronous. Obviously, when this condition is not met, even if the write speed meets the requirement, tearing is likely to appear, as shown in the animation. We can summarize the causes of screen tearing as follows. The first one is single DRAM, and another one is improper coordination of reading and writing. If the write speed is less than half of read speed, or if their initial states are not synchronous, it can cause screen tearing. Here we adopt different strategies for different types of LCDs. For SPI or IAT LCDs, we use T signal. While for the RGB LCDs, we use multiple DRAMs. First, let me explain the strategy of using the T signal. Since LCD ICs with SPI or IAT interfaces have a single built-in DRAM, and its write-read operation cannot be controlled by the ESP. So we can only prevent tearing by controlling the write operation. And it also required for LCD to provide the T signal internally. The timing diagram showing the figure represents the T signal output by a specific LCD IC. It indicates the end of a frame and the beginning of next frame. So we can use the T signal to synchronize the read and the write operations. As shown in the animation, we start the read-write operation when the T signal is detected. Of course, we also need to ensure that the write speed is equal or greater than half of the read speed. This way, we can avoid screen tearing. Since LCD ICs with RGB interface don't have a built-in DRAM and rely on the ESP to provide it, its read operation can be controlled by the ESP. Therefore, we can prevent tearing by using multiple DRAMs and synchronizing the write and the read operations. Let's take a look at this animation. The write and the read operations are performed on two separate DRAMs. Before starting to write to DRAM 1, it has to wait for the reading of DRAM 1 to finish. Then we can swipe the DRAMs and begin a new cycle of read and write operations. Actually, by adding one more DRAM, we can get rid of waiting time for reading, because there will always be a DRAM available for writing. The trick here is how we handle this DRAM. For all the details, You can check out the implementation in the ESP32S3 LCD code ESP. That's all. Thank you for watching.
What a fantastic presentation. But hang on, Radim, what time is it now?
Would you look at the time? It's already time for a lunch break.
Blimey, well, we've seen 5 presentations and Q&As already, so yes, you're right, it's time for a break. Because, you know, I don't know about you lovely viewers out there, but I need to go to the loo. So let's have a break now, please. We'll start again at 1:30 Central European Summer Time.
Yes, but make sure you're back on time again at 1:30 p.m. local time, because we have an afternoon packed with brilliant talks from Espressif's engineers in Europe and Brazil.
Absolutely. I'll just tell you one thing right now. We'll be starting with a presentation by Ivan Grochotkov, Espressif's Vice President of Software Platforms.
So make sure you're back in 1 hour.
We'll take attendance. No, okay, where's the bloody toilet? And we're back after a much needed toilet break, coffee break, lunch break, call it whatever you like. DevCon23 is back online, live from Brno in the Czech Republic. I'm Yanis from Espressif's Digital Marketing Department.
And I'm Radim, a software engineer based in Espressif's office in Brno, Czech Republic.
We're here with our afternoon session and 4 really hot presentations. We'll start our broadcast with Espressif's Vice President of Software Platforms, Ivan Grochotov, who will deliver a talk you will find very useful. In fact, many of you asked for it, so we're giving it to you.
Ivan's presentation offers a comprehensive step-by-step guide to creating new components, or libraries if you want, for ESP-IDF or porting existing ones. The talk will delve into the build system, repository layout, and integration with the IDF component registry. Additionally, he will explore strategies to streamline collaboration and reduce maintenance efforts, including the use of contribution guidelines, issue and pull request templates, pre-commit hooks, static analysis, automated testing, and other essential tools. Join us to learn how you can efficiently develop, share, and maintain high-quality ESP-IDF components. Over to Ivan's presentation now.
Hi everyone, my name is Ivan Grochotov. I am VP of Software Platforms at Espressif. My talk is about developing, publishing and maintaining components for ESP-IDF. In ESP-IDF, applications are built from components. Some components are part of IDF itself, some are developed as part of the application, and many additional components can be found online, published by Espressif and by the community. Last year, we have introduced IDF Component Manager, which is a tool that simplifies downloading and installing components, as well as sharing components with other developers. In this talk, I will explain the best practices that we at Espressif recommend to component developers. And after watching this talk, you will get familiar with the process of creating a component, adding examples, tests, and documentation, publishing it to the component registry, and setting up the workflow to simplify maintenance and contributions. I have many links to documentation and reference pages inside the slides, so if you would like to follow along, there is a link to the slides over here. You can also scan the QR code to open the link. The plan is first to take a look at developing the component, go over the structure, adding source code, examples, tests, and other basics. Then look at publishing the component and publishing the documentation. And finally, go over some maintenance topics related to CI and also managing contributions. For illustration purposes in this talk, I'm going to use a very simple component that I have developed. It's a driver for a PA1010D GPS module. The GPS module does have a UART interface for which you don't need any driver, but it can also be used over I2C, and this component provides a driver for that. The repository of this component is on GitHub. Again, you can scan the QR code if you like to follow along during the presentation. And the second link is the page of this component in the component registry. To start with, let's create the component. For this, I'm going to use IDF PyCLI tool, which has a create component convenience commands. This component creates a simple boilerplate with a project CMake list file, one source file, and one header file. And we will just have to put the component code in. The source code of the driver is not really the point of this talk, so I will not spend much time here. We have a header file where the API of the driver is defined, just 3 simple functions, and the source file where those functions are implemented. Essentially, we're just reading 1 byte at a time from a specific I2C register and wrapping it all in a simple API. While writing the code, how do we actually compile and test it? In ESP-IDF, the build process always starts with the application. So to test this component, we will have to create an application. Typically, this is either an example or a test application. And we'll use one of those for our compile run debug cycle. In the case of examples, I recommend placing them into the example subdirectory of the project. The component manager actually looks for example projects in this subdirectory and makes those examples available for installation in addition to your component. You can also use some other directory, in which case you will have to customize this, the name or the location of the examples. We will take a look at how to do this later. And for the test apps, they can be under the test apps subdirectory. This name is just a convention used in ESP-IDF. You can also pick something different if you like. I'll explain more about the test apps in a later slide. For now, let's start with the example project. Again, I'm going to use IDF Pi CLI, this time the create project command. And once the project is created, I'm going to go inside the project and build it just to make sure that the project itself is okay. The structure is very straightforward. Inside the component, we now have this example subdirectory, and there is a single example with the source file and CMake. So here is the example boilerplate. We see that there is just an empty app main function. Again, we will have to put some code inside. One thing to note here is that actually when we have compiled this example, it didn't compile the PA1010D component, which this example is part of. To do this, to compile this PA1010D component, we will have to add a dependency. To add the dependency, we're going to create an IDF component YAML file. And the IDF component YAML file is going to be here inside the main component of the example. IDF component YAML file is the manifest file for IDF component manager. It can be used for two purposes. One is to describe the component, and we will do this later when we will be adding the manifest file for our component. Another case is for adding dependencies. In this case, we are specifying that there is a dependency on the component. IGRR is the prefix in my namespace in IDF Component Manager. This is the component name. In this case, I'm not. It doesn't really matter which version of the component we are installing. So this actually adds the dependency on this component. And one other thing we have to do here is that for local development, we have to specify the override path. What override path does is that if IDF Component Manager can find the component, in this case 3 directory levels up from IDF Component YAML file, then it will use the local copy of the component and not download the copy from the IDF Component registry. This is something we do want when working on the component itself, because we want to be able to make changes to the component source code and see them being reflected in the example immediately without having to upload everything to the component registry and then download it again. And this is achieved by specifying this override path. After we have added dependency on the component, we can actually modify the example code. So in this case, in the source file, I'm adding the include for the header file of the driver. Then there is just a simple app main, which initializes the I2C driver. And then I'm initializing the PA1010D driver. And finally, there is a loop where we're just going to be reading the NME message from the driver and printing the message to the console. So now that we have everything put together, let's try to build and run the example. We were going to run IDF Pi Flash Monitor, so the example should be built pretty quickly and then flashed to the device. And as we see, the example runs and it's printing some GPS messages that are obtained from the GPS unit, so everything seems to be good. All right, we have added the example. The example works. Now we can take a look at the test application. There are several things that we are commonly doing in test applications in ESP-IDF. First, we can run Unity unit test framework and run tests on real hardware. The next thing is we can use Linux target in ESP-IDF and run tests on the host. In this case, when you have some hardware dependencies, typically you're going to use mocks to simulate those dependencies. In the case of our component, we could mock the I2C driver to emulate the data that GPS sends over I2C, or maybe test scenarios when I2C operation may time out. Another thing we can do in test apps is to run some more complex integration tests. Depending on what your component does, this might involve, for instance, some form of network communication between the host and the device. And of course, you can have multiple test apps. For example, you can have a unit test app which runs on the host, and another app which is an integration test and it runs on a real device. Later in the talk, we'll take a look at the tools that are available to execute those tests in CI. Let's look at what else can be part of the component. We have already added CMake lists, source files, and header files. We've added an example application, and we could add a test application. Documentation is something we definitely will add, and we're going to take a look at this at the end of the talk. We will have to add IDF component YAML file to the component itself to describe what the component is and optionally declare dependencies on other components. If the component has some compile time configuration, then we can add a kconfig file, and then if we are going to rename any kconfig options for backward compatibility, we can add sdkconfig.rename file. Linker fragments can be added to customize placement of functions or data into RAM. And last, we can add software bill of material manifest. Software bills of material is a relatively new feature that has been introduced in ESP-IDF. And you can add the manifest for SBOM into the component as well. So overall, these are the typical things which can be part of the component. Now let's take a look at adding the component manifest. The manifest should be in the component directory next to the CMake list file. Here we can take a look at the component manifest that I've already written. We are specifying the version of the component. This is not mandatory. We have other ways to set the version, which we will take a look at a bit later. We're specifying the description of the component, which will be mentioned prominently in the IDF component registry next to the component name. Some links to show the users where they can find more information about this component. The maintainers, the dependencies. In this case, this driver doesn't have dependency on any other component outside of ESP-IDF, so we are only specifying the constraint that IDF has to be above 4.4 because I'm using a certain API which was added in that version. A bit later I will show how we can handle compatibility with more IDF versions in the component. After we have added the component manifest, it's now a good time to also make sure that we have the component repository set up. So the minimal things we have to do here is to add the README MD file with the information about the component. It will serve as a homepage of the component. We can explain what the component is, how to use it, and any other important information. Then we have to add a license file. It's mandatory if you're uploading the component to the component registry. If you're maintaining private component, for example, within your company, you don't have to add a license file, but keeping it there might be a good idea anyway, even if to specify that this is proprietary code and not to be shared. And finally, we have to make sure that everything is in some version control system. In this case, I'm using Git, so I have added all the files in the repository into Git. And now that all those things are in place, we can actually upload the component to the component registry. First, we're going to do this manually, and then we're going to set it up in CI. So the steps are going to be fairly simple. We're going to sign into components.espressif.com, then log into the registry in the CLI. Then we can use compot component upload with the dry run flag to try to perform the upload without actually creating the version in the registry. So this is just a validation step. And then we're going to use compot component upload to actually create the version. Once the component is uploaded, we can go to the component registry and see the result. Let's take a look at how this works. So first I'm using compot component registry login. That gives me a token which I input in the CLI. In this case, this is a token with a short expiry time, so it's already invalid, but you should keep your tokens secret. And now that I have the token, I can run comport component upload with dry run argument. As we see, the process succeeds, no issues. So next step, I can run comport component upload without dry run to actually create the release in the component registry. And I've done this in the meantime, and we can take a look at the result. So on the left is the manifest that we used, and on the right is the page in the component registry. We see that all the fields that we have specified in the manifest, they are reflected in the registry. The version, the description, the links, the maintainers, the license has been extracted from the license file. We only have a dependency on ESP-IDF, which is listed here. As you see, the example that we have added has been detected, and the information about this example is available. And the rest of the page is the README file of the component, the root README, and if we were to add a README file in the example, there would be an example as well. All right, so we now have the component successfully uploaded. Let's take a look at another example of the manifest for some more fields that we can specify. This is IDF component YAML file from ESP-DSP project. And in this case, one additional thing we see is that if the example application is not under the examples subdirectory, as I showed before, we can actually tell the component manager where to look for examples. In this case, in ESP-DSP, they have additional apps under the application subdirectory, so we can specify the path over here. Also, we can exclude some files from uploading. For example, if you have large files, or if you have some files which are just not necessary for using the component, then such as maybe tests or some CI related files, you can exclude them, and then they will not be uploaded to the component registry. For more fields that can be specified in the component manifest, such as target, version, and so on, you can check the reference link over here. One thing that we looked at before was that I have added the version constraint for ESP-IDF to the component. So I have specified that the component only works with IDF 4.4 and later. If I wanted to make the component compatible with more IDF versions to make it easier to use, I could use one of those methods to achieve compatibility. So in IDF component YAML file, we can use rules if we need to make a dependency on certain other components configurable depending on the version. In the build system, I could add different source files or different compile definitions depending on the IDF version. I could use those IDF version major or IDF version minor macros. In this case, if I wanted to make the component compatible with IDF 4.3, I could add a file that would be compiled only for that revision, and that file could provide maybe the missing functions that have been defined in IDF 4.3. And in source code, I can use ESP-IDF version or ESP-IDF version val macros to guard some pieces of code. For example, if there is a structure member that was added in a subsequent release. So using these tools, you can make your component compatible with more versions of ESP-IDF, and therefore it will be easier to combine it with other components. One thing I want to mention here is that the repository layout that I have described so far is not the only one possible. It is a recommended layout, but if you already have a project and you have a certain repository layout, you don't have to change it just to publish the component in the component registry. I will show two examples here. The first one is similar to the layout of LVGL project. In this case, you may already have source files and include files in specific locations in the repository. And if you need to add support for ESP-IDF and publish into IDF component manager, then you can keep all the IDF related files in a subdirectory. In this case, you may have some maybe IDF specific port layer, the IDF component YAML file, and a CMake file. And if you wanted to add support for Zephyr, for example, for your project, then you could add a Zephyr directory here, also add Zephyr module YAML file and Zephyr port file. And in the root CMake lists file, depending on the environment, you would include either idf.cmake or zephyr.cmake. So this way your repository layout stays the same, and you can add the IDF functionality in a subdirectory. In this case, when you're uploading the component to the component registry, you just need to copy this YAML file to the root of the repository. The other approach we can take a look at is similar to that used in ESP Wolf SSL component. In this case, there is the upstream project, in that case Wolf SSL, that is added as a submodule. So we have an upstream repository that is not modified for IDF support, and then there is a wrapper repository where we actually add the CMake list file, IDF component YAML file, and if necessary some port-specific source files. When the upstream project makes a new release, you update the submodule commit in the wrapper repository, increase the version in IDF component YAML file, and make a release as well. So with these two approaches, you can keep the repository layout, and you can still add support for ESP-IDF and publishing to IDF Component Manager. All right, let's recap what we've done so far. We have created the component, we've added an example, a test application, we created the manifest, and the first version has been uploaded manually. Now, remaining part of the presentation, we will take a look at versioning the component, how to handle private components that we are not publishing to a component registry, and we're going to take a look at CI related things such as uploading releases automatically, running some testing in CI, and finally we will cover documentation and contribution management. So first, let's talk about versioning. IDF Component Manager uses a versioning scheme that is an extension to semantic versioning. Just like semantic versioning, there are three version components, major, minor, and patch. There is an optional pre-release part, and the extension that we have in the IDF Component Manager is this revision component. Let's take a look at some of the examples. 1.0.0 is a valid semantic version. It's also a valid version for an IDF component. In this case, it would be a release version. 1.1.0 RC1 would be a pre-release version. And the last two examples show that revision field. This is mainly used in the case when we have an upstream library. The upstream library might have some semantic version, in this case 5.2.3. And we might be publishing this upstream library in IDF component registry. If we want to distinguish some changes that we have done, for example, in the port layer or in CMake file or in kconfig file, we may want to do multiple releases, and to distinguish between those releases, we can use the tilde character and the revision number. So this syntax can be used if you have some upstream library that you need to publish. So now that we know what the version is, let's take a look at where to store the version. There are two cases here that I want to cover. The first scenario is the simplest one. If we have a repository with just a single component, like we have in our example with the PA1010 GPS driver, in this case I would recommend using git tags to identify releases. This is the most straightforward option for developers, and it's always easy to find where exactly the git tag is pointing to. If you store the version in git tags, it's not necessary to add it in the IDF component YAML file. You can keep it there, but in this case you will just have to make sure that whenever you make a git tag, you also update the version in IDF component YAML to match the tag, and this is just extra work you have to do. So the simplest solution is to not specify the version in IDF component YAML file, and instead tell the component manager to get the version directly from Git. The second scenario is when you have a repository with multiple components, like a monorepo. In this case, most likely these components will not share the same version, and you will have to keep track of the version of each component somewhere, and that place will probably be IDF component YAML file. In this case, the recommended approach is to try to upload a new version of the component on every commit. The compot component upload command has an allow existing flag, which tells the component manager that if the component version has already been uploaded, it will not do anything. So it will not override the existing version. And it will only upload the new version if that version doesn't exist yet. So this way, when you make a commit which changes the version number in some component, CI job will automatically upload the version to the registry. For these two use cases, we have a couple of examples. The first approach is illustrated in ESP32 camera repository, where there is no version field in IDF component YAML file, and versioning is done using git tags. And the monorepo approach is illustrated in IDF Extra Components repository, where there are multiple components and each component has its own version specified in IDF component YAML file. One more note, you can actually fully customize how you store component version. If the component version comes from some other place, let's say from some header file, you don't actually have to duplicate the version in IDF component YAML file. You can extract it from the header file and then pass it to to compot component upload command. In that case, version management is completely up to you. One side note here is about private components. Not every component that will be developed for ESP-IDF would be publicly available. You may be developing components that will be used just within your company. In this case, you can keep the component in a private Git repository, and you can specify where the component, where to download the component from using this Git reference in IDF component YAML file. This allows you to add dependencies on components that are only available, for example, within your company. And this way you can build a library of shared components within your team without publishing them to anyone else outside. Note that even though some components in your project would be private, you can still combine them with other components from the component registry. So let's take a look at the example. In this case, we have 3 dependencies. The first one is the libpng library from IDF component registry. The second one is a dependency on a Git repository. In this case, it actually is a public repository, but this component just hasn't yet been published to the component registry. And I'm adding it as a Git dependency, and the component actually is located in a subdirectory of this repository. And the third case here is local dependency. In this case, I'm adding the dependency on protocol examples common component that is located within ESP-IDF project. The behavior here would be exactly the same as if I were to add this component using extra component dirs variable in CMake. So as you see this way, you can add dependencies from different sources, and they can all be combined within the same application using the IDF component manager. Now let's get back to our main topic. Previously we have uploaded the version manually using compot component upload command. So now let's do the same thing automatically in CI. For projects which are using GitHub to host their repositories, we provide a GitHub action called upload components CI action. And you can add this action to your repository by creating a workflow file similar to the one we have here. The logic is very simple. We check out the component using the checkout action, and then we use this upload component CI action specifying the namespace, the component name, the version. In this case, the workflow will run only for Git tags, and we are taking the component version from the tag name, and the component API token is the same token that we used when we were uploading the component locally using the CLI. If you are not using GitHub to host your repositories, for example, you might be using GitLab, then you can use the IDF component manager Python package directly. So you just need to have some environment where Python is installed and install the IDF component manager package, and then use compot component upload command, same way as we did this in the CLI. In this case, again, I'm specifying that this workflow should only run for tags, and then I'm passing the tag name to compot component upload command so that I don't have to keep track of the versions in IDF component YAML file. If you're using a different CI/CD system than GitLab, then it should be very similar. You can use the same command there as well. Now let's move on to testing the component in CI. It's an important part of development and maintenance process, and we can take a look at the things that we can do in CI to test the component. Compilation checks are the simplest type of testing. We essentially just verify that the component builds. This can be used if you, for example, have some kconfig options and you want to verify that the code can be successfully compiled with different values of those kconfig options. You may also want to run compilation checks to verify compatibility with different IDF releases. The other thing you can do is you can run static analysis, for example, using a tool such as CLang Tidy. And you can run unit tests either on the host or on the real hardware, like a development board, or on the emulator. And you can run integration tests again in an emulator or on a real hardware. Let's look at those one by one. So for compilation checks, for projects that are maintained on GitHub, again, we have a CI action called ESP-IDF CI action. In this case, we define the build matrix. We can build the component for all combinations of those releases and the chip targets, and we can specify some additional releases and chip targets this way. We are using the checkout action again to get the source code, and then ESP-IDF CI action specifying the version and the target, the chip target to build for. Those come from the build matrix, and if we have multiple examples, we can invoke this action multiple times, specifying the different example path that needs to be built. So this is very easy to set up. There are just a few lines of code that you need to add to your repository. The downside is that this approach doesn't scale well if you have to build multiple applications or multiple configurations of the same app. So you will have to repeat this several times for different apps in your repository. In this case, there is a more comprehensive solution called IDF Build Apps. IDF Build Apps is a tool which can recursively find and build IDF applications inside a repository. It can build for multiple chip targets, it can build for multiple app configurations, and there is a configuration file that you can use to customize very flexibly the build matrix that is going to be generated. IDF Build Apps also knows about parallel builds. In this case, in this workflow, I am defining a matrix with multiple IDF releases and multiple parallel builds, and using the IDF Build Apps package to find all the apps in the repository and then build them. And IDF Build Apps will automatically split all the work that needs to be done between multiple CI jobs. If your project has high enough complexity, so if you have a larger number of test apps, then this is definitely an approach to go for. The downside is that in this case the workflow is slightly more complex. You have to maintain some configuration file and so on. So now looking at unit and integration tests. For running unit and integration tests, we recommend using PyTest with PyTest Embedded plugin. PyTest is a testing framework for Python code, and PyTest Embedded is a plugin for this framework that allows using Python to write tests for embedded applications. PyTest Embedded runs on the host PC, and it controls the test application that runs on the embedded device or inside the emulator. PyTest Embedded can find the applications that have been built, for example, manually or using IDF Build Apps. It can flash the application to the device or a serial port or JTAG. It can send input to the application. For example, if your app needs certain console command to start the test cases, and then it checks the serial output for specific conditions. For example, if your application is printing the number of passed and failed cases, you can expect that in this case you actually get 0 failed test cases. And you can also specify regular expressions and other things. And the nice thing about PyTest Embedded is that with the same test case, you can use the same test case to run on real hardware or on the emulator, and both locally and in CI. For more details about PyTest Embedded and using it in CI, please take a look at the talk called Streamlining Development with CI/CD, which we have here at the DevCon. The next step, running static analysis. Aside from compilation checks, we can use CLang Tidy static analyzer, which can reveal more potential problems with the code. And CLang static analyzer integration is achieved using this IDF-PY CLang check command. In CI, we can run IDF-PY CLang check. It's going to produce a list of warnings, and then we can convert those warnings into one of the report formats depending on the service we use. And then that report format can be uploaded to the repository hosting. You can take a look at this example we have here in IDF Extra Components. The workflow for adding IDF CLang tidy check is fairly simple, and it integrates very nicely with GitHub code scanning. In the beginning, I mentioned that we will talk about documentation. Depending on the component you're developing, you can decide what documentation you need to provide to the users. There are typical types of documentation you can consider creating. Reference, basically documenting each function and each data structure your component provides separately. Explanation, so in-depth, detailed explanation of how those functions have to be used together. And you can also write tutorials and how-to guides. For IDF components, we recommend the following approach for minimal documentation that you will provide. For the reference part, we recommend documenting the APIs in a header file using Doxygen comments. We can use Doxygen together with a tool called Doxybook to generate the markdown file, API-MD, and in this file there will be a nicely formatted API reference. Then you can write explanation part either in README-MD or inside a top-level file comment in your header file. Once you have README-MD and API-MD in your component repository, the component registry will automatically render the documentation in the README and in the API-MD in the page of your component. So let's take a look at what this looks like for our example component. I have documented the component API in the header file using Doxygen comments, added a Doxy file, which is a configuration file for Doxygen, and generated API-MD using Doxygen and Doxybook. In README-MD, I have the basic description about the component. So on the right, we can see the page of the component in the component registry. And over here, after the README file, you see that we actually have the API reference part. This comes from API.md, and this part is generated from the Doxygen comments we have added in the header file. So if you want to add some more detailed documentation of one of the functions, then you just need to update the header file and then regenerate API-MD. One nice way to do this is using pre-commit hooks, and I will mention about pre-commit hooks in the next section. So finally, let's take a look at things we can do to streamline contributions and help contributors bring useful changes to your repository. I would recommend adding contributing.md file to the repository where you specify your expectations for other contributors, and you can also use this file to keep some notes about how the development of the component should be happening. So is there anything specific that needs to be paid attention to when opening the pull request? How do we run test cases? Are there any code formatting or commit message guidelines? What's going to be the release process, and so on? Adding GitHub pull request and issue templates, or GitLab issue and merge request templates is a nice touch as well. Enabling builds and tests and PRs can help you spend less effort when someone opens a pull request. You can rely on CI to automatically validate the changes. And one additional thing that I recommend adding is pre-commit hooks. So pre-commit is a script that Git runs when making the commit, and pre-commit is also a framework that simplifies adding Git pre-commit hooks. To use pre-commit in your repository, you can add a pre-commit config YAML file, and in that file you specify the types of checks that you want to perform with this commit. During the development, developers need to install pre-commit one time, and then when they run the commit, the checks will be performed automatically. If some checks fail, usually the code will be fixed automatically as well. For instance, maybe the code will be reformatted or line endings will be fixed. The developer can then review the changes that were done by the pre-commit hook and stage them, and then run the commit again. It is also nice to add a CI job that will actually verify that developers have installed and run pre-commit. Here is an example of pre-commit from one of our repositories. In this case, we have some standard checks for line endings and other simple checks, and also code formatting, C code formatting using A style. So with this pre-commit configuration, you can very easily make sure that all contributions to your project will be uniformly formatted. All right, we are at the end of the presentation. Here is the checklist of things that you can consider doing when you're publishing a component to IDF component registry. For the final result, please take a look at the repository over here and at the page in the component registry, which is the final version that we have achieved by following all those steps. I hope that this talk was helpful to you, and it will simplify the process when you need to publish a component in the component registry. Thank you for your attention, and I will be taking your questions.
Hello, everyone, and welcome back to the Q&A session live here from Brno. And here in the studio, we have Ivan. How are you, Ivan?
Yeah, doing great. I think yesterday's yesterday's sessions were really nice. So today I'm taking a break from moderation, and it's obviously easier.
Yeah, it's definitely easier. Okay, so we have a couple of questions here. The first one is, are proprietary components a good solution for closed commercial products? Are they more suitable for public libraries?
Right. So I think it was mentioned later in the presentation that you can use the component manager as part of your project, even if your project is proprietary closed source project and you don't intend to publish all the components. If some of the components you think are not, do not have significant business value, you can publish them and let other people use them. If you think they have something proprietary, you can keep them in a Git repository and then install those components from a Git repository. So this way, only people who have access to the Git repository will be able to download those components. And this can work based on either HTTPS or SSH, so you can have some authentication mechanism.
Okay, thank you so much for your answer. The second question now is there any way to force a component to use the latest version of a dependency component?
Yes. Well, yes and no. So what happens is that the component manager tries to make sure that the builds are reproducible. Basically, if you have built your project once, then what should happen is every time you build it again, the behavior should ideally be the same. So things in the project should not just randomly change without your influence on them. And this is the common behavior in other package management systems. For example, in NPM, there is a file called package log, I think, JSON, and same for other package management systems. So in IDF, what happens is that when you download the dependencies the first time, the component manager will create the log file that's going to be, I think, dependencies.log file in your project directory. So as long as the dependencies.log is there, then component manager will only download the versions that are specified in dependencies log. So if you have created the file, then as long as the file is there, the versions will not change. However, if you can decide what you want to do when you're committing your project into Git. You can either put dependencies log into Git. In this case, all the users will always use the same versions. This is, I think, best option for product development. In this case, you know that your colleagues are using exactly the same versions of the libraries as you are. The other option is to not commit dependencies log into Git. And in this case, you can actually force specific versions in the IDF component YAML file. But in this case, you know that if you change the version, then everyone should delete dependencies log. So the exact way to choose depends somewhat on what you're building. So for example, or some demos, maybe you don't actually want to commit the dependencies log, but for some products, maybe you do want to commit dependencies log. So if your IDF component YAML file has a dependency on any version of the component, so basically you have asterisk, like you're not specifying concrete version, and the dependencies log doesn't exist, then the component manager will just download the latest version. So essentially, to force the latest version to be downloaded, you have to not specify any specific version, just have an asterisk there, and then the person who's building the project or CI should make sure there is no dependencies log file.
I see. I'm pretty sure that we have this already in the documentation. If you don't,
yeah. I think the dependencies log is documented in the component manager documentation. I had a link to that in the presentation.
Okay, that's awesome. Okay, so now the third question. If we use a component from component registry in a project, can we do any modification to this component?
So this is, again, somewhat related to reproducible builds. So what we want to do is, if you have a project locally and you're using some components from component registry, your colleagues who work on the same project should ideally get the same behavior as you will get. And that means that we try not to have the case where the component has been accidentally modified locally, and then you're going to spend time troubleshooting why is my component not working the same way as someone else's. So in short, the component manager will look at the files in the managed components subdirectory of your project and make sure they are the same as the published version of the component. If you do want to modify it, then you just copy the component from the managed components into components directory of your project, and then the component manager basically takes his hands off this component. So now you are in control of this component. You just commit it into Git, and you essentially have a copy of that component. This is what's known as vendoring. So you are adding a third-party library directly into your project. So if you want to modify the managed component, you vendor it by copying it into the components directory, and then you can do any modifications.
Okay, I see. Thank you. We have one more question here. So the question is, can I select which components to download using menu config?
Yeah, this ends up being a common question, especially for folks who build some demos or applications that need to work maybe for different development boards or different chips. There is no way to specify dependency using menu config. So menu config and generally project configuration is determined at a later stage than the component dependencies are. So it's too late to influence the set of components at that point in time when configuration options are known. There are some alternatives. So we can use environment variables in IDF component YAML file. So for example, you can alter which dependencies will be included or not using some environment variables. You can also, the other option that we actually recommend is to always download all the dependencies you need, but select which ones will be linked into the project in CMake. And there you actually can use configuration options. This is something that we don't yet have an example for in our component manager examples, but we will be adding such example because this question is coming up pretty often.
Okay, so I think we have time for one last question. So we have one question from the audience here. So any plans for something like to npm audit to check for known issues in the dependency tree?
Yeah, this is something that we have recently introduced. It's called software bills of materials. So we have a tool, ESP-IDF SBOM, that can generate a software bill of material file in SPDX format. And this software bill of material file can be then consumed by many tools, both open source and commercial tools that can scan for vulnerabilities. ESP-IDF SBOM also has its own built-in command to scan the NVD database for vulnerabilities. We are in the process of adding software bills of materials to components that are part of ESP-IDF and to the components we publish from our IDF Extra Components repository. And I think the presentation actually, I skipped a slide where I was showing how to add SBOM, but I will put a link to this documentation of ESP-IDF SBOM in the chat, so you can take a look at that later.
Yeah, that would be great. Okay, so thank you so much for your talk, for being here to answer questions from the audience. Yeah, it was a really pleasure to see your talk, like very, I would say like masterclass for components. And
thanks, Peter.
Yeah, so now we can go back to the studio.
After Ivan's significant presentation, we will continue with David Cermak, Espressif Software Manager here in Brno. He will tell us how to talk to cellular modems, which of course are inseparable parts of most IoT products. But how can you talk to them? Can you just start telling them your innermost secrets and concerns so they can give you advice, a helping hand, maybe a shoulder to cry on?
Whoa. Take it easy, mate. Let's keep things simple, okay? The obvious thing to do if you want to talk to cellular modems is to use UART with AT commands, okay?
Okay.
But David Cermak will tell us if there's more to it, especially when it comes to frequent issues about maintaining an active network connection while keeping the command interface up or switching to low power modes. David's contribution will provide an overview of different methods, modes, and protocols used when communicating with cellular modems, focusing specifically on solutions for ESP-IDF users.
So David will show you how to multiplex commands and network data, how to use multiple terminals, and how AT commands could be used for networking, even with standard protocol libraries. Over to David then.
Hello and welcome to my talk about cellular modems and especially about the way how we talk to them using microcontrollers. My name is David Cermak. Here is a brief introduction of myself. I am an embedded software developer, also a contributor to ESP-IDF and an Espressif employee where I'm currently leading a team of network developers. So that was about me. And now about the talk. We'll be talking about cellular modems. So here is a motivational picture of an old style analog modem with an acoustic coupler. Because in the past, we used to have telephone lines with real actual wires. And if computer A wanted to talk to computer B remotely over the telephone line, they needed some device in the middle, some translator from the computer A to from the ones and zeros to that analog signal. Nowadays, we no longer need those wires, but the idea is still the same. So if we wanted to make a phone call, we use cellular phones and connect over cellular networks. And the same applies to modems. So, but the computers still need some middleman, some device in the middle that would translate those signals from them to the signals that are applicable, that could be sent over a cellular network. And this is actually the topic of my presentation, but we will not be speaking about cellular modems, but especially about the way how we talk to them. So about the interface between the microcontroller, because in this case, computer A is a microcontroller and computer B is something like a gateway, internet gateway of your internet service provider. And the other device is the cellular modem. And we usually talk to them using UART and with AT commands, but it's not that simple. And let's see what are the agenda for us and for today. So first of all, a brief introduction about protocols and interfaces that could be used when we are talking to modems. Second chapter will be about two basic modes which we can basically work with modems. So we can either use command mode, sending commands, request response type of communication, or open and establish a network. The third part of the presentation will be just about tips and tricks, how to use commands at network at the same time, and some other ideas how we can improve reliability. Also in the section number 4, OTA, because if we want to perform over-the-air updates on an interface which is by nature really slow, there might be some issue with reliability and so on. And the last section will be about ESP-IDF solutions, so about the components, examples, and demonstrations that we could provide if you are using Espressif chips. So let's start with protocols and interfaces. As you can see, here are some of them, but basically we can take a look at the most popular modems that we can buy and look at data sheets and look at all features and interfaces that they provide. So here are some screenshots from the data sheets, and you can see a recurring pattern. So if I actually summarize this, we can actually list all or the most popular interfaces as these, and protocols as those mentioned here. In this presentation, we're only to focus on the UART and USB interfaces and only on these protocols. I've deliberately shaded out all those interfaces here, I2C, SPI, PCI, and MBIM for protocols, because first, we don't have really a solution for Espressif chips, and second, these protocols and interfaces are rarely used when we communicate with modems. All right, let's go to the second chapter about commands and network. So I've already mentioned that we have two modes, basically. One is the command mode, when it's a request response type of command, so perfect for sending commands, setting properties, getting properties, or for example, sending a text message, getting GPS information. But it's not that great for serving a network communication because of the nature of the network, which is basically asynchronous. So for network, we usually need to establish the connection and maintain the connection. And that's by nature not really a request response type of communication. Now let's look at the commands. So I think we all know that basically we communicate with those AT commands. So AT supposedly means attention. So we say, attention please. An important command is about to happen, and the other party just responds with OK. So it's a very simple textual style of protocol. We send some information with some parameters, and we usually get OK or some response with OK. So like a very simple protocol. Nothing really to talk about. And now, what about the network? So with network, it's a little bit complicated. I already said that response or request response type of commands are not that great. But as you can see, I'm actually trying to serve network with AT commands here. So I'm actually trying to ping www.espressif.com using AT commands, so sending this ping messages, and I'm also trying to send HTTP requests to this espressif.com web page, and so it's not very, and as you can see, I'm getting a buffer overflow, so it's not really a convenient API, but it is possible. As for the PPP protocols, this is something different. It's actually a full-featured network protocol. It's a collection of point-to-point protocols, and here we may basically go back to the very first picture on this presentation, where two computers are making a phone call. So for that, it's probably really nice to think about it as 2 points talking to each other. So PPP actually means point-to-point protocols. So it's not a single protocol, it's a collection of multiple protocols, but the idea is that it basically creates a tunnel between, IP tunnel between computer A and computer B. And as you can see, it's no longer a textual type of protocol. It's a binary protocol. You can probably see some ASCII data here, but these are basically ICMP payload. So this is basically a ping request which is sending this payload, and ping reply is basically repeating it back. So one important thing to note about those PPP protocols is that those protocols are usually part of our TCP/IP stack. So when we establish this kind of connection and we maintain it by our TCP/IP stack, then we basically create another network interface which could be used in a standard way, so that we can basically use this connection to the modem as another network interface, the same way as we use Wi-Fi, Ethernet, or something else. All right, so that was basically the brief introduction about the possibilities and now the two modes, and now what we can do if we want to use these modes together at the same time. We have basically four options. We can switch between the modes, so whenever we need PPP or network, we switch. When we need to send a command, we switch back, and so on. Number two is using CMAX, so basically multiplexing these two protocols onto one channel. Solution number three, and I've already shown that when I was trying to basically ping espressif.com using AT commands. So we can basically serve the network simply just using AT commands. There are some issues with that, and I will talk about them later. Number four, we can basically use two physical channels. So looking at I'm sorry for that. Looking at the point number one, switching between modes. Switching between modes, it's possible, but the switching sequence is kind of slow. So let me try to run this screenshot that was basically taken while I was basically repeatedly switching between PPP and command modes. So you can basically see that it takes about a second to switch from command mode to PPP. Now we are in PPP, and now it takes something more than a second to switch back. So it is slow because there is a mandatory pause between sending an escape command in the PPP mode. So it's not really useful for simultaneous request, but the big benefit here is that for that we don't really need a library or any specific implementation, because sending AT commands or implementing this sequence is really very simple. And assuming that your TCP/IP stack supports PPP protocols, then everything is just ready and ready to be used. So yeah, this is basically very useful for applications that just need send commands and occasionally connect to network, or some applications that basically sleep most of the time, and from time to time they wake up, establish a connection, send something over a network, and go to sleep again. Now the CMAX mode. This is the most traditional approach for basically multiplexing two channels or creating two virtual channels over one physical channel. It's basically very useful for situations where we need to access both network and commands at the same time. And the idea here is that first of all, as you can see in this screenshot, first of all, we need to establish this this CMAX mode, so create two virtual channels, and then I'm actually sending an AT command, and as you can see, the AT appears also here. So this is basically the payload of the protocol, but the CMAX add some header and some footer to the protocol. So it's just a transparent protocol which basically wraps this payload and sends it without any kind of modification. And as you can see, I basically switched the protocol and sent the AT command again, but to a different terminal. But the response is still the same. So this is the idea of CMAX protocol. So we basically create two virtual terminals. One we use for commands and another one for network. And it works pretty well, but for that we actually need a library, we need some implementation because it's not so easy to implement it in a user space. And also the protocol itself might differ. So there are some limitations, or I would say little violations for some devices, and I will also talk about them later. So that was about the CMAX mode, which is, as I said, it's perfect for applications that need both command and network at the same time. And also, if you can basically choose the device, because not all devices supports that. All right, networking with AT. So that's also one of the options. We don't need to switch modes, we just stay in one mode. We already know that it's not perfect to maintain or serve the network operations with AT commands, but it's available everywhere, and it's there, and it might save us some trouble. Unfortunately, these network commands are different device per device. I already mentioned that there are some standards for AT commands, but those network commands, they are very specific and they basically don't fall into any kind of category of standards. So every manufacturer defines their own network commands. Now we have these two drawbacks. One is security and one is protocol libraries. So what do I mean by that? So security, if your modem actually supports HTTPS or MQTT over TLS, that's great, that's secure, but it's secure from the frontier, from the modem side upwards, up to up to that cellular network or to the internet. But we basically expose the insecure part, or the plain text communication between the chip and the modem, which is or could be available if someone gets the physical access to the device. What I mean by protocol libraries. Basically, if we use one protocol library for communicating over Wi-Fi or over Ethernet, we cannot use it for communicating using modems. We need to implement our own library or our own commands that would basically work with AT commands. And why question marks? I will talk about that later when I will speak about Espressif solutions. So we do have some solutions for that, and I will just also show some examples how this can be managed. Yeah, and where it is useful, of course, for applications that need just command interface with occasional networking. The last option, using 2 physical channels, that's usually best choice if your device supports it. The only potential drawback is portability. If, for example, we need to use another device that might not need to support it. And this is also great for devices with USB interface, because these 2 physical channels, they don't have to be real physical channels or almost physical channels inside one USB interface. Let's say 2 endpoints in one USB interface. All right, that was about the simultaneous modes or using command and network mode simultaneously. Now, other tips and tricks about connectivity, OTA, and other stuff that we can improve. I already mentioned that OTA might not be very reliable if we are basically using UART and very slow baud rates, very slow throughput. So in some cases, we could get buffer overflows or something like that. So especially for UART, we can use flow control. So if it is available, if it is possible, not all devices support it, but if it's available, just use it. Another point, LCP echo. LCP is a sub-protocol of PPP protocols. Use it if possible, because this is the protocol that basically checks connectivity, checks local link if it's up and running. So it periodically sends, it actually implements some sort of a keep alive mechanism. So periodically sends requests and check for replies. And if a reply doesn't come, it basically treats the channel as disconnected. Some other issues that we might face, so during the OTA operations, some of the flash operations might take too long, and we might not be able to serve network during that operation. So we can basically perform OTA into phases. So we can basically download the image metadata, check the image sizes and versions and stuff like that, and decide if we want to update or not. And if we do, we just basically pause the network, perform bulk erase. During this operation, the network would be inactive. And then after that, we just resume network operations and continue with OTA. Some other ideas or options that we can do, we can adjust some lower layers of libraries, put handlers into IRAM, extend buffer sizes, or adjust baud rates. And this is probably all from the generic part of my presentation. And now let's go to Espressif solutions. Yeah, so I already mentioned that it is possible to perform some basic modem connection without any kind of library. So here is a solution for IDF only, and from IDF we will use LWIP's PPP layers, implementing the the PPP protocol. So here is a link to a very simple example which just establishes a connection, sends just few AT commands to set the modem to the PPP mode, and start and maintain the network connectivity. It's very short, and it's basically part of this multiple NetIF example, which uses Ethernet, Wi-Fi, and LTE, or connection over a modem at the same time. Here is a link to that. So if we want to use a library, Espressif offers a library that's called ESP Modem. It's basically deployable using standard way, using ESP registry, and it contains features and examples that are listed here. So for example, for CMAX support, you can check this example. If you want to play with power saving modes, we also have an example for that. Here is a link. Known issues, it's a very interesting and important section of our documentation, because it basically lists all the possible violations of the protocols of some devices that we came across. And I was talking about that during the CMAX part of my talk that some devices might deviate from the protocol a little bit. Some of them might not support it at all. So please check this link if you want to use CMAX and you are basically deciding on which modem, which device you wanna use. TCP client with AT commands. Here is a link to that example, but I will also talk to it a little bit in more detail because I wanted to basically highlight two solutions that we use. The ESP modem also has a Linux port. Here is a link to an example. So you can basically run the same source code on ESP32 and on Linux or on Raspberry Pi and use the same modem. Also, one important link, modem console. So all these screenshots and little videos that I've been showing today were actually taken or captured while running this modem console example. And it's basically a very simple ESP console that implements very few AT commands or allows you to send any kind of AT command that you would like. And it also implements, the basic mode switching. So you can basically, just running this example, you can basically play with all the modes and AT commands for your specific device and experiment with that. Now, just a few notes about this TCP client with AT. I've already mentioned that there was the solution of using commands and network simultaneously, but only using AT commands. And I mentioned that there are two drawbacks basically, that for that we need to basically implement our own protocol library, here are some workarounds how we can basically how we can address this drawback. So if you already use the ESP-IDF, some ESP-IDF protocol libraries, for example MQTT, you know that we use this component called TCP transport, which is kind of a nice component because it allows us to basically layer different transports on top of each other. And in this case, or it is the usual case that we run TLS on top of TCP, and then we basically connect to our TCP IP stack and to Ethernet or Wi-Fi or something like that. But in this example, we can basically create a custom TCP transport using those AT commands. So basically use the TLS layer from ESP32, from ESP-IDF SDK, and just replace the TCP layer and use ESP modem to communicate with modems. So this will basically address both the security issues, because the security is handled here within the chip boundary, and protocol library issue, because we still use the same library. So that was the solution for our IDF protocol libraries. But what if we have some other protocol library that doesn't use the TCP transport? Well, here is a trick that we can basically use, and we also have an example of that. So instead of connecting to your endpoint, we basically could connect to a local host and use LWIPs or any kind of TCP/IP stack loopback interface. So your user application would basically connect to a local host interface, and ESP modem would inject here a very simple local host listener and would just translate all what comes here to the ESP modem layers and implement the AT protocol that would send it to the network. And again, in this case, this is a little trick because it consumes probably more sockets, 2 more sockets from the TCP/IP stack. But this is a trick that also could be used, and it solves both the security problem and protocol library problem. And this is basically all from me. And on my last slide, I would like to sum up the entire presentation in these 3 sentences. So if you need to use commands and network at the same time, you can use CMAX protocol. If you experience buffer overflows with UART, just use flow control. And if you want to check something, experiment with something, or test something with the real actual modem connected to your device, just run this modem console example and play with that. And this is basically all from me. Thank you for watching.
Hello, everyone, and welcome back to the Q&A studio here in Brno. And now we have David here to answer your questions. How are you today?
Hello, I'm fine, thanks.
Nice. Okay, so we already have here one question. So I suggested a paid premium support option for ESP modem customers. Is this something imaginable for Espressif?
Yeah, that's a difficult question for a technical person like me. So I think, Franz, you've already got the answer from Espressif that you should contact sales at espressif.com. But from the technical perspective, I can only say that we try to keep ESP modem as generic as possible because it basically serves as an extensible library. And if somebody needs to support their own device, they could basically extend it or implement a subcomponent that would support the features that people need, but keep basically the core functionality, the base of the ESP modem library generic, public, and available for everyone.
I see. Thank you. We have another question here from the audience. Sometimes I have difficulties to find answer in Espressif documentation. How do you overpass this challenge and create these amazing applications?
That's a very difficult question again for me to answer in a generic way. So we try to focus on documentation. Sometimes it's not perfect. We know that. We will try to work on that more in future. Maybe what we actually miss is some kind of a global pointer that would point to each of those documentation. So, for example, if we are now talking about this solution for modems, it's probably hard to find the documentation for the actual library that would communicate, that would talk to the modem. So maybe something like that would be good. So hopefully this presentation will help. It will probably serve as a link to different ideas and solutions provided by Espressif, how users can use this library and other libraries at Espressif.
Yeah, but I do have one suggestion for that. So we have like if you go to our documentation, you'll see a feedback link. In most of our documents, you can like give your feedback and we'll try to reply as soon as possible. And we shared a link a while ago in the chat that points to a form, and you can give your comments to your documentation, because we are really trying to improve our documentation, because it's like essential for developers. And I really ask you guys to go there and fill the form for us. It would be really, really nice to have answers and to have like comments there, and how can we improve the documentation. Do you have anything else to add to your presentation? Something that it's like sometimes it's quite hard to, like in 30 minutes to talk about a subject. So do you have anything else to share?
Yeah, actually I do, because while I was watching this presentation, I have just realized that I was basically just talking about the principles and ideas, and I completely forgot about the target audience. That this is for developers and engineers like numbers. So I can basically give you some numbers about the ESP modem library. So as for the footprint of the library, it takes about 30K of program memory, and it consumes about 20K of RAM. That's for the library. If you use it for communication with modems, but also, as I shown in the presentation, it is not necessary to use any kind of library. I actually showed a snippet of code. There is definitely a link in the presentation where you can basically implement a very simple support only using IDF and IDF's LWIP implementation of PPP protocol, and with that, the footprint would be really, really minimal. Would basically mean just allocating the buffers for the UART and or the communication driver, and that would be it. And also few other numbers that was about the footprint, and now about performance. So I know that people don't expect too much about communicating with modems. The speeds are really slow, but we can basically increase the baud rate to 960 kilovolts, and with that speed, running iPerf, we could get to about 0.7 throughput in both TCP, UDP, up and downlink. So this is basically something that can be achieved very easily.
Okay, thank you. So again, thank you so much for your talk, for giving your answer and sharing your knowledge with our audience. I'm pretty happy to see here at DevCon23. So thank you.
Thank you too.
And now we can go back to the studio.
Moving on, we have another guest speaker taken to the virtual stage shortly. His name is Pedro Bertolecci. He's from Brazil, and he is absolutely crazy about electronics, embedded software design, and technology in general. That's why he became a technology consultant, and as such, he will speak today at DevCon23 about making a robust firmware update over the air on ESP32 using rollback.
An FeOTA is a must-have feature in all embedded solutions nowadays. In fact, an FeOTA is the only possible and affordable solution for fixing bugs, security flaws, and other software malfunctions in devices already operating in the field.
Hang on a minute though, how do we ensure that a firmware update over the air is as robust as necessary?
Well, a good way to do this is by using the so-called rollback, especially in case of a bad firmware update caused by some predictable or unpredictable reason. By using rollback in a case like this, the embedded device will automatically get back to the last firmware version. This way, the embedded device can recover without any human intervention. Pedro's presentation will show us exactly how to use rollback with an ESP32 microcontroller. So, let's see what he has to say.
Hi, my name is Pedro Bertoletti, and today I'll talk to you about making a robust FU OTA process in ESP32 microcontrollers. This presentation is made on behalf of Instituto de Pesquisas Eldorado. After this presentation, you will understand the importance of FU OTA process in embedded solutions development and how to make it when adding more the rollback feature to it. Before starting this presentation itself, I will give you some information about my working experience. I work as a technology consultant in Instituto de Pesquisas Eldorado here in Brazil. I have more than 15 years of experience in embedded software development and IoT solutions development for several areas using ESP32 in great part of these solutions. Also, I'm the author of 2 books about embedded systems and IoT, and I often publish in these areas in blogs and magazines in Brazil and overseas. Also, I would like to talk briefly about a company I work for, Instituto de Pesquisas Eldorado, or IPE for short. IPE is one of the greatest research institutes here in Latin America, based in 4 strategic cities, which are Brasilia, Porto Alegre, Campinas, and Manaus. IPE works in the state-of-the-art research and development solutions for the most of the major companies around the world, including the segments of embedded systems, IT, oil and gas, and so on. Here's the agenda for today. I'll start by talking about the importance of the remote firmware update process, or FU OTA for short. Then I will explain what FU OTA and rollback are. Also, I will show why rollback is a must-have feature for an embedded systems development. Getting deeper into the FU OTA with rollback together, I'll show how this can be done in ESP32 microcontrollers. And in order to put everything together, I'll give you a demonstration using FU OTA and rollback in the ESP32 microcontrollers. At the end of this presentation, I will also show you the references used for composing this presentation. First thing first, let's check why FU OTA is so important for embedded devices development. Let's imagine a classic usage of embedded systems for a company, where devices are placed in the field, and they are responsible for collecting very important data for a specific operation. This collected data will reach high-level systems and will be processed too, in order to be able to extract valuable information from them, which will base important decision-taking and management decision-taking in this particular company. Therefore, the embedded systems in this scenario plays a major role in the whole company operation. However, nothing's perfect. These embedded devices are using embedded softwares. And as we know, any kind of software can present bugs and malfunctions at some time. Software issues are sometimes not previsible, and so they are inevitable. And this can get a little worse. The embedded device can present security flaws too. These security flaws can cause a lot of damage from devices getting overtaken by hackers or something like that, causing data leak or intentional malfunctions, or even false or intentionally false data inserted or injected into the system, affecting everything here in this operation. The impacts of these problems, of these issues will be felt all over the data chain. For example, as a consequence of false or missing data in this whole data chain, all information extracted from this data won't be valid anymore, won't be reliable, and directly impacting the management decisions, the operation themselves, and last but not least, the incomes from this company. In this scenario, multiple losses are expected. Clients will be unsatisfied with the service provided by this company. Then the company reputation will get worse and will put clients off. Then some clients will give up this company and will get similar service from their concurrents. To sum up, this company will be very negatively affected as a whole. Well, truth be told, this can turn into a nightmare. The solution here for this case is called Firmware Updates Over the Air, or FUOTA for short. Once this company identifies the issues and problems and manages to fix them, and having the possibility to update these embedded devices in the field over local networks or even internet, it could resolve all these problems in all device add-ons, reducing the impacts and of these issues, of these problems, into the whole company operation. Let's have a look now how FUOTA can solve to help these issues. First, FUOTA allows microcontrollers to upload their own firmware over local network or even internet, as said before. This can happen periodically, under demand, or when microcontrollers face critical issues. Second item, no human intervention is necessary during the FUOTA process. It means it results in an affordable process for uploading several devices at the same time. And finally, in general terms, FUOTA doesn't take much time to occur, what means less than downtime of this device in the field. Now let's move on, checking what rollback means and why rollback is a must-have feature for FUOTA process. In this section, I will show you what a rollback process is, how the ESP-32 partitions are used for FUOTA and rollback process in this microcontroller, and also show you how rollback works in FUOTA process in ESP-32 microcontrollers specifically. Rollback is a feature to ensure microcontroller will always work with the last stable firmware version flashed in it. Okay. If the most recent updated firmware presents critical problems and get unable to boot properly, for example, the rollback firmware will automatically force microcontroller firmware back to the last stable firmware version flashed in it. This prevents device from getting bricked or for getting unusable at the field after a bad firmware update. Furthermore, rollback process doesn't require any human intervention too. Now, let's time to check how ESP-32 flash memory partitions are organized to make a FUOTA process and rollback work. Here's the typical ESP-32 flash partition scheme used for ESP-32 microcontrollers, which count on FUOTA process and rollback features. Please observe these three highlighted partitions in red here at the left side of the image: factory, OTA 1, and OTA 0. The factory partitions contain firmware factory, which is the very first firmware flashed to the ESP-32. This firmware flashing, or this firmware factory flashing, is usually flashed when the device is under manufacturing process in the manufacturing line, assembly line. Then, two partitions dedicated to store firmware received during the FUOTA processes are shown, which are OTA 0 and OTA 1. Both are required in order to make possible for a rollback to have enough firmware versions to work for, and to be able to force the less stable firmware version when the ESP-32 faces critical issues. Also, please pay attention to the highlight partition sides in red in the right side of the image. As all highlighted partitions will be used to store firmwares, they must be able to support firmwares with the same maximum size. This is why there are three partitions here with the same size, in this case 4 megabytes. It means that this ESP-32 is ready to handle firmwares with size up to 4 megabytes. Now it's time to check on how FUOTA with rollback feature works on ESP-32 microcontrollers. First, let's assume the device is having microcontroller firmware flashed for the first time, which means firmware is flashed in factory partition. It's important to mention that the firmware partition can only be flashed over serial interface, and FU OTA process cannot overwrite this factory partition content. Okay, so from now on, all FU OTA process will overwrite or will use only OTA 1 and OTA 2 partitions. Then, after flashing firmware to the factory partition, S32 boots for the first time. The firmware flashed in factory partition will be loaded. Bootloader will point to it, and as bootloader point to it, and in no new firmware flashed, every time factory partition firmware will be loaded. But after the first FU OTA process, things will change. The firmware received in FU OTA process will be flashed in OTA 1 partition. And if this firmware presents no critical problems, the OTA 1 partition will be marked as valid partition, as you can see here in the image. Then, bootloader will now point to the OTA 1 partition when S32 boots, and making this firmware flashed in OTA 1 partition to be executed to run in S32 from these boots to the next boots if nothing more happens. But let's check what happens after the second FU OTA process when new things change too. The firmware received in FU OTA process now, and the second time, will now flash to the OTA 2 partition. And if this firmware presents no critical issues, the OTA 2 partition will mark it as valid, as you can see in the image. Then, as happened before, the bootloader will point now to the OTA 2 partition when S32 boots, and the firmware flashed in this partition will be executed by S32. After the third FU OTA process, this cycle starts to repeat itself. The firmware received in the FU OTA process will be flashed in the OTA 1 partition this time. And if the firmware presents no critical issues, the OTA 1 partition will be marked as a valid partition, as you can see in the image. Then, bootloader will now point to OTA 1 partition when S32 boots, and the firmware flashed in this partition will be used now on. To sum up, FU OTA process works as shown in figure in the center of the screen. After the FU OTA process, the received firmware will be stored in OTA 1 partition, and the bootloader will point to this OTA 1 partition. Then OTA 1 and OTA 2 partitions alternate themselves as partitions containing the firmware received in FU OTA process. And the bootloader alternates between them to point to which partition will be used to load the firmware S32 will run. Now, let's check some error cases when something wrong happens. What happened after uploading a bad firmware to S32 in its first FU OTA process? Well, in this case, rollback kicks in. OTA 1 partition will now be marked as invalid partition, as you can see in the image on the right side of the screen. And rollback will take action and force the less stable firmware version to be run in S32, which means the firmware flashed in factory partition in this case. Let's move on and suppose a bad firmware is uploaded in the second FU OTA process of this microcontroller, this particular microcontroller. Again, rollback kicks in. Now, firmware will be flashed in OTA 2 partition. This partition will be marked as invalid, as you can see in the image, and rollback mechanism will force the less stable firmware version to be executed in S32, which means the firmware flashed in OTA 1 partition. And finally, to complete the rollback cycle, let's suppose a bad firmware is received or is uploaded in the third FU OTA process. It works the same way as we've seen before. A rollback kicks in, OTA1 partition will be marked as invalid partition, and for a rollback will force the less stable firmware version, which is the firmware stored in OTA2 partition, and rollback completes its work. Then it's possible to observe rollback always will keep microcontroller running a stable firmware, preventing microcontroller from getting bricked or unusable at the field. Now, let's check how rollback are used in FU OTA process for ESP32 microcontrollers particularly. Well, for this, the first thing to do is enable the rollback feature in ESP32. This can be done in menu config of the ESP32 project you are working on at the moment. In order to enable the rollback feature in ESP32, please tick the option called Enable App Rollback Support, as you can see in the image on the right side of the screen, and in the bootloader config menu. Then ESP32 will be ready or be prepared to use rollback feature. The next step to do is to mark partitions OTA1 or OTA2 as valid partitions. Every firmware received in FU OTA process in ESP32 microcontroller must mark its current partition as valid. It can be done by calling this function highlighted in blue, which is ESP OTA mark app valid cancel rollback. This action must be taken in a place in the firmware source code that indicates all critical operations have been successfully done. It's very important to mention that OTA1 and OTA2 partitions are marked as invalid per default after FU OTA process. It's a default behavior. Then, if these partitions OTA1 and or OTA2 aren't marked as valid by the firmware which they are hosting, and if ESP32 reboots for any reason before marking these partitions are as valid, rollback will force the less stable firmware version to the ESP32, which means the recent uploaded firmware won't execute in ESP32. Therefore, you always need to ensure to call this function highlighted in blue here when everything worked fine in firmware. Now let's check how FU OTA and rollback can work together in a demonstration. I will show you here. For this demonstration, I'm using the dev kit from TTGo called T7S3, which contains ESP32 S3 microcontrollers with 16 megabytes flash. Also, from hardware perspective, I use a USB-C cable to program the ESP32 and source to deliver power source for them. And from software perspective, this demonstration was developed to use ESP-IDF version 4.4 and the official Espressif plugin for VS Code. Well, let's start the demo. Here's the source code for this demo. Okay, let's start this by demonstrating the main points of the source here in the main.c and app main function, which is the first function executed in this firmware and makes all initializations and so on. Okay, as an initialization, you can see here, one of the first things it does is to print the current firmware version, as you can see here in the debug messages. So it's possible to see that this version is 1.0. And checking to partitions scheme, you can see that as this firmware has been written, it has been flashed over serial interface, it is stored in factory partition, which offset is this number. And getting this message, we can see that offset for the current versions is the same. It has the same offset. So we have a confirmation that this firmware is also stored in factored partition. Okay, so moving on to the code, the first thing it does is to init NVS and briefing light routines. Briefing light, it's a LED here in the dev kit that blinks, demonstrating the ESP-32 is running successfully. Okay, so it's just a light that indicates everything's running okay. Then from this point on, the OTA related stuff, related code starts to run. This particular function here, init ESP-32 OTA, is responsible for initializing the ESP-32 OTA routines. Then, after this, Wi-Fi is initiated. Wi-Fi is initiated here in this function called Wi-Fi init STA, which initializes Wi-Fi in station mode, connecting the ESP-32 here in a router I have here near my ESP-32. And it's impossible to mention that my computer is also connected to the same router and the same network as ESP-32 is. Then this means my computer can reach ESP-32, as we will see a few steps further. Well, still here in this main.c file, we can see that the next step to do is as the current partition is marked as valid. Okay, as we are working here in this particular case with a factory partition, firmware flashed with factory partition, this mark won't be possible to do. But in the next case, when OTA process or FU OTA process will be done, we can see that this can be done successfully. Okay, so after marking the partition as valid, everything works from the tasks created in these functions here, which is the briefing light, the OTA, and STA. It's important to mention that when Wi-Fi starts, as you can see here, sorry, I'm getting the events. Okay, when Wi-Fi starts and the handler events are called, I'll get to it right now. Oh, here. When Wi-Fi successfully connects, a TCP server socket is initialized in ESP-32, which means ESP-32 will behave as a TCP server socket to receive the firmwares. Okay. Now, let's take a deep look. Let's take a look on how the server TCP server works and interacts with FU OTA process. Everything starts in the initialization function, which is here. This function starts the task dedicated to handle this socket server TCP, which is called socket TCP server task. And this task does everything regarding sockets, which means initialization, then setting the port, setting the IPv4 parameters, and everything. And also, this function, this task, sorry, will listen or waiting for a client connection. And in this case, the client is my computer here, which will send firmware to ESP-32. It's important to mention that for this project particularly, every data chunk sent to ESP-32 through this socket connection will consider it a firmware chunk. This is okay for this demonstration. This is okay for here, but in a real-world project, it's highly recommended to implement some sort of communication protocol or communication rule to manage preventing no firmware chunks to be considered as firmware chunks. Okay, so here it's a demonstration only, but you'll know what to do when doing this in a real-world project. Well, once socket client is sends some data to this server side, which is our S32, the OTA process starts, okay, which is done here. If there's some firmware chunk and receiver bytes are higher than 0, then OTA processes starts. It's important to mention that these firmware chunks sizes are up to 1,023 bytes, okay? And these firmware chunks are temporarily stored in this buffer right here. I get it for you. It's a buffer here. So every data chunk with 123 bytes will temporarily stored in this buffer and then will be passed to OTA routines. It's important to mention too that if a client stops sending any data and remains in this state for 5 seconds, this time is set. Here, it's the timeout for firmware chunk. The S32 will consider all firmware chunks have been received and will end the OTA process. And we'll start to validate the firmware received so far. And if everything goes well, OTA is finally done. Well, as we can get the overview of this code, now it's time to see this demonstration running. Here, as you can see, I have a VS Code with debug message from the device on the bottom side of the screen. And S32 is using the firmware, as I shown you before, version 1.0, okay? So it's the very first firmware flashed to the S32, simulating the firmware flashed in the manufacturing process, okay? And here I have a Hercules software. I'll clean the window for you. This software is a TCP or ODP and serial terminal, very useful for testing this sort of things. As my S32 here and my computer are already connected to the same router and same network, the next thing to do is to connect Hercules, this client, TCP client from Hercules, to the SP32, which contains the server side of the socket connection. Now I'll send to SP32 from my computer some firmware. First, I'll connect Hercules to the SP32. I will send firstly the good firmware, which means the firmware that contains no critical issues. Okay, so this firmware version is 1.2. The firmware is start to being sent. This takes some time to complete. Let's wait for some seconds. Okay. OTA processes has been finished. S32 has rebooted, as you can see here in the message. I will get a little deeper. And as you can see, the current firmware version is 1.2, meaning that OTA process worked fine, okay? And we can also verify this by checking the offset. The offset now is this number, which means checking the partition scheme, this number here, which means the firmware, we were at the factory partition as we've seen before, and now we are running from OTA 1 partition, okay? Meaning that OTA occurred successfully. Okay, now let's check the bad side or the not so good firmware to update to the S32. Well, as we can see, we are now currently running 1.2 version. Now I update the 1.3 firmware version to the S32, which means a bad firmware. This bad firmware simulates a critical issues to this S32 and will force it to reboot before flashing the marking the partition as valid. Okay, so it rollback will force the firmware back to 1.2, as we'll see further later. I'm sending it. It takes some time to complete. Okay, as you can see, a lot of messages rolled over here, and let's check what happened. First, after the OTA process, we can see the S32 version is 1.3, okay? So it started, and suddenly something happened, something bad happened, and S32 restarted before marking the partition as valid, okay? So rollback feature kicks in and force the 1.2 version back, which was the last stable firmware version flat to S32. So rollback feature is successfully working in this demo. And after updating a bad firmware, it restored the S32 was restored to the last stable firmware version, flattening it. Let's now check the websites and books used as references for this presentation. First, as website references for this presentation, I use the ESP-IDF repository, okay, which URL you can see there, and S32 official documentation. So these two references are used as website references. And from the book perspective side, the book ESP-32 com IDF ou Guia Profissional from Brazilian author José Moraes was also used as references for this presentation. This presentation is now ending. I would like to thank everyone who watched it. Please feel free to ask questions in the Q&A session. See ya.
Hello, everyone, and welcome back to another Q&A session here live from the DevCon23. And now we have not only one Pedro, but we have two Pedros. How are you today, Pedro?
Fine, thanks. And you, Pedro?
Yeah, I'm good. Thank you. Like, we are on the second day, like we are close to finish the block, and we are pretty happy that we have like a lot of questions. And talking about questions, we can start by the first one. So, Pedro, first question is, what is the advantage of using an additional factory partition and two OTA partitions instead of just two OTA partitions? The first one uploaded and tested at the factory.
Okay. First of all, nice question. It's a very, very nice question, in fact. And there are two main advantages on this. The first one is when you use factory partition, you have a partition to rely on if everything goes wrong with OTA 1 and OTA 2. Let's suppose you have uploaded two or more fail or defected or wrong firmwares to the S32. Even in this case, everything goes fine. The firmware flashed on factory partition will kicks in. And also the advantage number two is that the factory partition cannot be overwritten or rewritten by OTA process or FU OTA process. So if everything goes wrong, you still have a working firmware in your S32, what will decrease the downtime and the chances of the device get bricked on the field.
Okay, I see. And we have a question which is similar to the previous one, which is like in case of OTA 1 and OTA 2 be invalid, it can roll back. Can it roll back to factory firmware?
Yes, sure. This is what this is the how can I say, this is the common flux or common way that rollback features work on. if everything's failed and OTA 1 and OTA 2 have invalid firmware or some critical issues happen there, rollback feature will automatically roll back to the factory firmware written in the factory partition. So you'll be safe, you'll be fine in the field.
Okay, I see. Thank you, Pedro. So the third question here is any advice on where to put ESP OTA mark app valid cancel rollback, which is like the function name. I'm currently like marking the partition as valid after initialization of the initialization. After initializing the libraries and establish connectivity plus about 30 seconds.
Yes, I have some advice for this. First one is to ensure that every imported or every must-have part of your software has successfully initialized. For example, if you have I2C communication, UART, and SPI communication, and all these three must work to your firmware works properly, you can attribute some flag or some control variable to these resources, and if everything goes fine with these initializations, you can then mark the partition as valid by using this function, this ASP2 mark valid. Okay, it's a big name.
A long
yeah,
function name.
And the second approach that can be used in addition or plus the first one is by the time the firmware is executing without crashing or without having a critical issue. So you are marking flags or using flags to ensure everything needed in your software is working properly, and additionally, you can monitor the time firmware is working on. So if the firmware works for, let's say, 10 minutes and everything goes fine with the must-have features, then you can mark as valid. So it's a good approach, a good practice for marking a partition as valid.
Yeah, like in summary, like just keep this function call by like a safe part of your firmware, like it's a part that you are like pretty sure that everything is running properly.
Yeah, if you call this too early or in a wrong place, and critical issues happen, rollback feature simply won't work as desired.
Yeah, I see. So like we have one more question here, which is ESP32 can send something information to a server when invalid partition are detected to let me know if OTA has some problem, of course, like after rollback.
Sure. There are some strategies to achieve this. And one of the most simple ones is to store the FU OTA process status, or if it goes well or not, in a variable stored in an RTC area, which you can decorate this with the RTC _ data _ ATTR attribute or access modificator. So if you store the status of the FU OTA process in this variable, after the next boot, it will be safe to be read, and you in your firmware, in your Espressif firmware, you can read this variable and check if everything goes fine or not, and take the action you need. So you'll be, how can I say, you can rely on this variable value to know if the previous FUOTA process was working or not.
I see. I think we have time for one more question here, like right directly from the audience. So it probably is from Brazil. It's boa tarde. So how do you cover the security aspects of OTA?
Well, S32 has plenty of secure resources like secure boot and everything. This topic is a very different topic from what we did here. Okay, so I think these topics are not a good way to approach them. It would be a mess. But just for saying what we have secure boot, and we have the opportunity or have the possibility to encrypt flash as well. So the firmware flashed or sent via MQ2T or TCP socket or whatever can be an encrypted firmware, not a plain firmware. So it increases significantly the security of the FWOTA process.
I see. In addition to your answer, like we had like talk about this yesterday. So specifically talking about secure boot and secure flash encryption. So nice. Pedro, thank you so much for being part of Espressif DevCon23. I'm pretty happy to see you here. Not only like because I know you in person, but I like to see like I follow your work, so I'm pretty happy to see you here with us today. Yeah, that's it.
Okay, thanks for the opportunity. Thanks for letting me do a presentation here. I also it's always a pleasure to see and talk to you, and I would like to ask the watchers to follow me at social media, LinkedIn, and everything. And please feel free to ask me questions, to chat me, to talk about firmware, IoT, and so on. I love it, and surely it will be a nice discussion.
Thank you, Pedro. And now we can go back to the studio.
We'll stay in the field of embedded software for the time being with one more presentation from Brazil. Espressif's embedded software engineer, Rodrigo Garcia, will tell us how to use the ESP-IDF FreeRTOS functionality within an ESP32 Arduino project.
This talk is meant for people who already have some familiarity with Arduino, but want to go a little deeper and learn how to use FreeRTOS along with Arduino in a certain project. Rodrigo will first talk about why a developer should take an interest in using an RTOS. Then he will present a particular project in a single code example with an architecture that involves specific RTOS features such as multitasking, mutexes, queues, and ring buffers. Let's take a listen.
Hello, my name is Rodrigo Garcia. I work with Espressif in the software platform department with Arduino core development. Today we're going to talk about ESP32 Arduino and how to integrate FreeRTOS on it with some examples. So we'll talk about this presentation real quick in a second. Then I will talk about what is ESP32 Arduino and also some details about FreeRTOS. So it's not very deep. It's just to give you a general idea. It's a quick talk, so we will not go that deep. And we will have two practical cases to demonstrate how it works and also show you the code, which I think it's important so you can see what is that. And also there will be some links to the code, so you will be able to see this code and maybe play with that and try it. So let's start. Expectations about this presentation. As I said, we'll talk about FreeRTOS, and I will show you what FreeRTOS does and what are the problems that usually we find when we are using FreeRTOS with Arduino. I suppose that you know something about Arduino. At least you're able to create some sketch that blinks LEDs or print something in the serial output and the serial monitor in general when we think about the IDE. So if you don't have any knowledge about Arduino, well, maybe this will not be so easy to follow, but Arduino is pretty easy, so don't worry about it. And then we're going to have these practical hands-on examples, which is, I think, most of the time we're going to spend in this talk. And I will use the Walkway emulator, which is pretty nice because that's a tool. It's a web tool, by the way. You just open a web URL in the browser. You can create your code. You can see that running in an ESP32. And also you see the output of the serial monitor there as well. You can see everything attached hardware to that board, and be able to run all the examples I'm going to provide you. So it's a lot easier in terms that you don't need to download the IDE. You don't need to download any tools or anything. It's fast, it's easy, and you don't even need the hardware because it's an emulator. So the board is there in software, let's say, emulation. Then you don't need to have the hardware, and you can experiment with that as you wish. So let's go in the Arduino view. It's basically created maybe 10 or more years ago. Part of that is hardware. Usually people say Arduino to the board, but actually there are many boards, different boards. In our case, we have boards with the ESP32 SoCs. And also it's software part, which is an API. And then you can just use this API to do whatever you need. And why Arduino is interesting? Because it's very easy. You don't need to know a lot about how the board works, and it's universal. Just one code Arduino should run in every single board that we have out there. It doesn't matter who makes the board. And we provide exactly this API that's universal and allows anyone to run the code in any place. There is some structure around it, and the definition of the API is in the Arduino CC website. And this is the link to the reference, and where you can see all the different classes for the different peripherals and how to use it. There are some examples there as well. So you go to the Arduino CC, you'll see everything about Arduino, and just you can use it in our boards with our implementation of the ESP32 Arduino core. It's, as I said, it's pretty easy, it's simple. Instead of maybe poking a lot of the registers in the MCU, all you need to do is just call one API, one function, and it does a lot of things behind the scenes and makes it a lot easier for any user who knows nothing maybe, or knows very little about software development or embedded software development. Very, let's say, use it among makers and also some professional people for prototyping as well, because it's fast. It has all the necessary APIs for communication, including hardware communication with SPI, I2C, I2S, and also, for instance, the serial, which is an abstraction layer in Arduino that allows you to plug, let's say, any streaming of data into any other thing. So it's a way of connecting maybe different peripherals. Of course, you have also ways to deal with the GPIO, analog, read and write, timers, and you have libraries as well out there, which are maintained mostly by the community. So you can use displays and some other external hardware in your project. And the code is there. It's pretty easy, again, to use it. Documentation usually is in the GitHub of that library. Loading the library is pretty easy as well, because all you need to do is download the library to your environment and use it. Thinking again about how we deal with the Arduino and Espressif, we have two versions currently, 20X, which is based on the IDF4 version, and it supports the SoCs ESP32, the S2, the S3, and the C3. And we have also the Core 30X, which is the latest one, based on IDF51. It adds two new chips, H2 and C6, which are capable of doing Zigbee and Thread. And also, in the case of C6, there are some features around power management that makes it less power hungry. As a consequence, you are able to run it in a battery if necessary. So we have those two flavors, let's say. You can pick the 30X, of course, also supports the previous chips, and everything is there, so you can just use it as you want. As you can see here, we have the sketches, which we call Sketch an Arduino software program application. It can use libraries or not. It's not mandatory, but it can use. And this sketch will call the Arduino API which we implement here as Arduino API layer. Then this Arduino API will call a hall layer, which we call Arduino layer, let's say hall. And this is how the middle software, let's say middleware between APIs from Arduino and IDF itself. So as I said, IDF is part of Arduino today. And the hall calls the IDF, and the IDF calls, of course, everything necessary on the low level to the MCU itself and the peripherals and set up everything. So we have these layers, and this is how it's structured in the project, the Arduino core. And along all those layers, we have FreeRTOS. So FreeRTOS is part of IDF. And FreeRTOS is our RTOS. In particular, this is IDF, ESP-IDF FreeRTOS version, which is a little bit different from the, let's say, original FreeRTOS. We're going to talk about it later on. It supports all the layers, including Arduino. So Arduino has FreeRTOS natively. Why should I care about RTOS? So most of the users, they don't care about RTOS. They use bare metal, monolithic, one event loop, big loop, by the way, software. So in this loop, which is, Arduino has this setup function, which setups everything around GPIOs and so on. And then you have the loop, which does or executes, let's say, the application itself. So you have your logic inside this loop. This is the usual Arduino software, how it is done. So why should I use RTOS and not use this monolithic block of code in a bare metal model, which is the usual stuff with Arduino? And the reason is that because, first of all, it's sequential. So you just do one thing at a time, step by step. And then if you, for instance, delay, you're delaying, doing nothing there. Your MCU is doing nothing. It's waiting, time to pass, and then going to the next step. If you need to do something in different time frame, or let's say I want to blink one LED every second and then read a sensor every half second, you need to use timestamps. You need to know how time is passing, looking at the time in milliseconds, for instance, from the beginning of the execution of this sketch, and trying to figure out when half second has passed and do something, when a whole second has passed and do something else. So you need some sort of a state machine in order to make it work. So most of the programs are around that. And it's good, but maybe sometimes a bit complicated if you have a big program and a big loop, and it's doing a lot of different stuff. So maintaining that might be complicated. So that's why you go with RTOS, not just because of that, but because it's a real-time operating system, which means basically that it's preemptive, it can schedule tasks, and task is the unit of execution, let's say. So task is like something you're doing. Let's say I'm blinking one LED. I need to read a sensor, and as soon as that sensor presents some data, I need to react. So I have different tasks for different functions, and I can break my program into those tasks and structure my program better than doing just one block of code. And I can give those tasks priorities, meaning that some events are more important and need answer or response faster than others. So some maybe tasks or some functions of my program might run whenever possible. And some other functions and tasks must answer or react really quick in real time. That's why the name for real-time operating system. And the real-time operating systems give you the resources to do that. So we'll see how to do that, good stuff about it, and maybe some problems around it as well. So you have, as I said, optimization of code. In the one block model, when you delay, you're just waiting time to pass. With RTOS, when you delay, you're allowing other tasks to run in parallel, let's say, or at the same time. So if you have just one core, well, yes, the core will give time slices to each one of the tasks. So each task will have certain time to execute, and they will be stopped, and then you will switch to another task, and so on. And it will also take into consideration all the priorities of the tasks as well. So this is a better way of using your chip, and you can do more with FreeRTOS than just with a big block of code. As I said, the code is better structured. I can break it into tasks and know exactly how to debug it, how to test it. I can separate part of it and make sure that one part will not maybe interfere in the other one, so they're all independent somehow. It's a better way of doing code. But some users, especially the Arduino ones, and maybe people with not too much experience, might say that, well, I tried and some strange things happen when I try to do this parallel stuff. And parallel in the case of ESP32 means really parallel because we have in the ESP SoC 2 cores, meaning that you can really run parallel tasks. So, well, you need to manage that. And we will see that in our presentation here very soon. For those problems, we have synchronization and mutual exclusions of code as well. So we'll see how to use it, and as well as how to communicate tasks among them so they can synchronize itself and maybe work better. As you know, I said that Arduino runs on top of FreeRTOS and IDF. And by the way, setup and loop is a task that's running in the FreeRTOS. FreeRTOS. A little bit about FreeRTOS very quick. Here, FreeRTOS is an open software code, was created a long time ago, and it was designed just for one single core. As I said, Espressif has chips, the ESP32, the first one, has 2 cores. So Espressif decided to create the version ESP-IDF FreeRTOS, which implements SMP, which supports more than 1 core, in our case, 2 cores. So it's possible to use both cores. It's used in our Arduino core, and you can get more information directly from the web page from FreeRTOS. You can get information about the modifications done for the SMP, and also what is the version that we have directly from our documentation in our website in this URL. And also you can see some add-ons that we have there, especially ring buffer, for instance, in this URL as well. So feel free to go to those URLs and read about the documentation and get more information about it. We will not go deep on that at this time. So about the tasks, usually tasks are C code, meaning C functions, and they're like void functions returning nothing and receive an argument pointer to something, whatever you want. Each task has its own stack space. So the task has its stack space and it's separated among different tasks. In the stack, you use your local variables in your task, also the information necessary to switch context. Because, of course, you have, let's say, your CPU has some registers, and they need to stop it, save those registers, move to another task, retrieve the state that it has when it stopped running, then I run that time slice, stop again, save everything, all the context, switch to another task, and so on. It's done in the stack. So it's necessary that every task has its own stack in order to FreeRTOS to run, and not just FreeRTOS, InRTOS. What about global variables? And then the heap memory space. And in the heap, all the tasks will have access to the heap. Not just all the tasks, but also all the cores as well. So if I have 2 cores, both cores will access the same heap. If I have many tasks running different cores, all of them will access the same heap. So if I create some array or variable, which is global, will be global to all the tasks. All of them will access that. It's a shared memory space, let's say. Usually, our tasks will have some initialization code and some looping code, meaning that we'll run all the time waiting for events to happen and react to those events, or process some data, for instance, as well, and return some information and some memory space, for instance. So this is how usually those tasks are set up. We'll see that very soon in the practical side. It's very similar to how Arduino does. Again, it has setup to set up maybe GPIOs and some initialization data. And then you have the loop that runs forever and runs your code, your application itself. So it's the same concept. So you see that a task actually is like Arduino setup and loop, and that's why Arduino setup and loop is a task in our core today. Each task has a priority and a task state. So we'll see that pretty soon, how it works. Those are the states. When you create a task, it goes to the ready state. Then it's doing nothing in the ready state. It's not being executed. It's just staying there. The code is there. And the scheduler knows that the task is in the queue, let's say, to be executed. When the scheduler gives that task on time, it goes to the running state, meaning it's executing. Then when that time slice is passed, we go back to the ready state. So most of the tasks will be between ready and running state all the time. But when this task needs to wait for some data that comes from another task, or even if this task needs to delay or whatever like that, it goes to the blocked state, which means that task will be blocked waiting for that event to finish, and the RTOS will control that event or will control that delay or whatever. And as soon as that passes, that task will return to the ready state, and when time comes, it will receive a time slot and will then run again. Any task can be put into, let's say, sleep mode, which is called suspended state. And this is when you don't want to run the task anymore. And when you go to the suspended state, of course, you're not running and you never go to the running state, meaning that another task must unsuspend you, meaning that needs to resume you and get you back to the ready state to be able to be run by the scheduler, by the RTOS in the case. So if you go to the suspended state, you'll be there frozen, let's say, forever. And then somebody needs to resume that task. Some other task from outside needs to resume that. And then the task will have some handles, and you use those handles, which are pointers basically, to identify the different tasks and move them along those states, especially from suspended to running and maybe running to block. The running ready is done by the RTOS. It's not something you can control. So the priorities. The priority goes up here. So this is a high priority task. And this is the lowest one, which is called idle task in FreeRTOS in general, meaning that if no other task is put in the run state or ready state, you will run idle forever. In the case of Arduino, there is always one task running, which is the setup and loop. And that task receives time slots, and this is the only one task running. The RTOS will basically switch all the time from task 1 to task 1 to task 1, and this one would run forever as one single block, let's say, all the time. But if I add a second task, which is higher priority, this task will run until it goes to the block state, meaning that it will wait for something to happen. Might be waiting for some data to come up, or some delay, or something, or maybe some ISR will put some data in the queue, and then this task is waiting for that data to come from the ISR and process the data. So basically, when this data is put in the queue, the FreeRTOS will switch to that task because it has a higher priority, and will make sure that that task will execute immediately, exactly doing the real-time stuff that we need. So this priority is very important. But at the same time, if this priority never enters in the block state, meaning it will never wait for anything, it also will run forever. And the RTOS will say that because this is a higher priority task, it will run always and not run our low priority task, which is maybe the Arduino sketch. So you need to take care about it. It's not just running a loop and processing data all the time, non-stop, because it will not run correctly. And this is one of the problems that some users used to find when they use RTOS, because they don't understand this concept, and maybe they will think that, oh yeah, they will switch, but will not switch if you have a higher priority here. And you might have even higher priorities, and then will have their time slices and run first and interrupt. Maybe test 2 will be interrupted by test 3, and will run it peace, and will go back to test 2, not to test 1, because test 2 has not finished. Then when it finishes, it goes to task 1, run a little bit, and then a higher comes up here and so on. This is the general situation. And there's some maybe critical situation that might happen with that, but we will not discuss that here in this presentation. So about communication, in general, what we have here is this IPC, and we have not pipes and not signals, but all the other ways of communicating tasks are here in FreeRTOS, and we can use all of them. You go to the documentation and see that, you can see how to use that. So let's go into different examples, and I will run those here in the loop. So as I said, I will blink two LEDs, and I will show you how it works. And here you have the URL for each one of the examples. If you want to go there and see it, you can play with that. Feel free. It's there for you. Let's see the first example. So this is the first example. This is very basic. This is a walkie environment. I just play here and it will execute. And you see both LEDs are blinking together because this is one single block of code that just sets it high, delay 1 second, set it low, delay 1 second, and does it in loop. So this is plain sketch Arduino, nothing to talk about it. This is the second example, and this example basically does almost the same. The only point is that it blinks in a different frequency. As you can see, this one is slower and this one is faster. And this is because we use the timestamp. Basically, we get how many milliseconds has passed from the beginning of the execution, and we compare to some timestamp and change the state of the LED here. 500 milliseconds, 200 milliseconds in this case. So if I run it, I see it runs in different frequency for each one of the LEDs. The problem with that is, as I said, if I have, for instance, 10 LEDs, I'm going to have 10 of that. And that might be a little bit messy, including if I start reading some sensors and some other stuff. It becomes a big program. Maybe it's a big difficult, or maybe more difficult to deal with that. So we should move to task, and I will show you how to do that right now. So here we have the tasks. If I run it, you will see that LEDs blinking in different speeds and frequencies. And here is the task. This is a task. As I said, it's a C function that returns void, nothing. In the case, receive an argument, a pointer to an argument. I have here kind of the setup, which is setting up the GPIO, and then the loop, which is a while one, which is a loop forever. That basically does exactly that. Sets high, delay, sets low, delay again. So you see, this is exactly the same usual blink LED example, but just for the red LED. I have the code for the green LED with a different time, 200 seconds, milliseconds, and here 300 milliseconds. So what I need to do just is use xTaskCreate to create the task, and we will use that in all the examples. So I just give it the code, which is the C function here, the name of the C function, you can see, the same name. Just a string with the name that can read and understand. The stack size, 2K. No parameters, so this void pointer will be null, not used at all. And priority 2, meaning that's a little bit higher than the priority from the Arduino sketch, which is 1, by the way. So I create two tasks, one for the green code, other for the red code, and they will start running right away as soon as I execute this code. And here in the loop, I can run something else, like every 5 seconds printing something, like exactly is being done here in the output. You see the loop being executed. So I have 3 tasks running actually here at the same time. So let's see, for instance, if I just want to have one single function to deal with these LEDs. If I had 10 LEDs, I will have 10 functions. No, I can have just one. I will show you how to do that now. So this is just one single C function. And to do that, what I basically do, I create a structure that has the fields, which is the GPIO and the time that that GPIO will be blinked. This is like a structural information. I create 2 variables of this kind, of this structure, which will contain the GPIO itself and 1 second is blink time. The other GPIO, the green LED, half-second blink time. If I run it, it will run exactly that. 1 second for this one, half-second for this one, and I have just one single function. And the whole trick is here. I just take this argument, which is a pointer, and cast it to the structure pointer, to the structure, and then I use it here, and I just reference the fields, the GPIO or the delay. And then I can make it run with any number of LEDs, just one single function. And I start this function here, which is the same, as you can see, in both tasks. But what is different? Here I pass as argument the address of the structure of the red LED, and in this one, the green LED address. So that will be casted here as pointer for anything to the structure, and I use that structure here. Pretty simple, pretty basic, done in C. Let's see it in C++, how it works. So in C++ it's almost the same, but instead of a structure, I have a class that defines the same data, the same members, the pin and the delay. I have a constructor for the class, which basically sets the information for the pin and the time. And I have a static function, which is the same for all the objects that will be created. And this static function takes, again, a pointer to an argument, which is casted to the class. And then I can use the same way as the structure, the pointer with the different members of this class, delay and pin. It's exactly the same structure, but in C++ now. Remember that Arduino C++. I create now here the objects passing the different initialization parameters for the constructor, and I just use the same function, static function from this class, and give different pointers to different objects. And again, I run here the loop, so everything runs perfectly fine. You can see this is a very practical way of structuring your code and using C++ with tasks. This is example now prints. Let's say they have different sensors and need to print the information of these sensors. This code basically has uses the millis structure with a single loop, and it prints basically this information, which is message 1 and message 2 here. And it runs and prints that. You see that in the output here. It's a printer. Let's say you have the sensors, and the sensors are printing something. I just printing stuff here in my example. So it will start running real soon. Get us the output for that in a second. So if I just increase here, you'll see message 1 to message 2, because one message is every half second, and the other one half of this time. So you have one message 1, 2 message 2s, and I can pause it, and then you can see 1 to 2, 1 to 2, and wow, that's not exactly 1 to 2. Why is that? Well, the reason is that because in my printing function, I delay a random time of up to 25 milliseconds. And because of that, the scheduler is not exactly 2, 2, 1, 1, 2, and 1 and 2, 2, 1 to 2, 1 to 2, but it runs in this way. So if I, for instance, I just comment out this line, you'll see exactly that, as I said, 1 to 2, 1 to 2, and we'll see that here, 1 to 2, 1 to 2, and if I let that run for a while, you'll see that exactly what happens. So this delay adds some factor of random execution time, and that affects the way how it works, because it takes longer, and when this function is executed, this time is not the same, and it might happen in your code as well. So some stuff might take longer, and you don't know that. Where did it take longer? Why didn't it happen in this sequence, exactly in this sequence? And this line here is simulating exactly that, and you see the effect of that. So we'll see how to do that with tasks now. So here is exactly the same stuff with a task. In our case, our tasks, we have 2 tasks, as I said. Here is for one message, which is task 1, in the other for this message, task 2. And let's see here the output here. We have both tasks being executed. Wow, now I see a mess. Why? It's all a whole mess. I cannot see the messages now anymore. It's a whole confusion of data. Why is that? Because I have now this loop task as a task, let's say, two different tasks printing stuff, all of them printing to the same serial port, and this time confusion, let's say, I add some entropy, let's say, in the process. And because of that, everyone is preempted. Each task will take its time and will output some data one by one of the characters. And then you see all of them mixed all together here. So how do I fix it? To fix it, basically, what I need to do is a mutual exclusion, meaning that this code here must print the whole message at once and not be interrupted. That's how you fix it. So if I have many tasks interrupting the other ones, you need to make sure that certain part of the code will run as unique, as an atomic, let's say, block of code. And that's what we're going to see in the next sketch. So here we have the code for the exclusion, which is done with the semaphore. And I call this semaphore as lock. And what I do, basically, I take this semaphore, meaning I take the exclusive access to that code and block any other that will wait that to be given back. So I take and give this, let's say, lock. And then the other tasks, when they try to run this code, they will be waiting here in this while. And this while will make any other one to wait until I unlock it. So just one task will run this piece of code from the serial lock to the serial unlock. And just to make it easier, I created this define that or we use lock with semaphore or we just don't use the lock. So if I run it with 0, will be exactly the previous one. If I change it, so just to show you, if I change it, you see here everything running in a mess. Then I stop it. I change it to 1, which means that now we'll start using the locker, the mutex, and you will see that everything will run perfectly fine, meaning that it will give me the messages in the right time. So here's running, as you can see, that's running perfectly fine, and I see the whole message now. So I used the mutex with setting this to 1, using this code here to block, and this is a unique code per task, and you see it's running perfectly fine. I have another example, which will create another different problem, which now I will print not just the message, but also a number, which is a counter that is incremented once a time every task calls to print something. So I just changed the print message to this print counted function, which will have this counter incremented and call the print one by one that uses the lock. And we'll see how it goes here right now. So as you can see, it is running. And what is the problem with that? Well, if you look at the numbers 0, 2, 1, wow, they're not in sequence. Why is that not in sequence? Again, because one task preempts the other. Even though I have printing the message as a whole, make sure that just one task prints the whole message at once, I don't make sure that they are executing in the order that it was supposed to be printed out. So I have this sequence which is wrong, 0, 2, 1, 3, 5, 4. It's all out of order here. So how do we fix that too? It's another problem. So not just we need to lock the sequence of the printing out, but also we need to make sure that the messages are printed in the right order. So the way we do that, we use queue, basically. So each task will send the whole message to the queue, and we will have a model which is called producer and consumer. Then we have tasks producing messages, and we have one single consumer, which is a task, separate task, that will consume from this queue and print one by one in the order there in the queue. So when we send the message to the queue, we send it in the right order, and they will be stored in this queue in the right order. And this consumer will print them in the right order as well. And we'll make sure that everything is done correctly, including, by the way, the printing of the whole message. Remembering that these functions of queue and mutex and etc., they're atomic, so they're not preempted, they're not interrupted. So I make sure that the whole message is printed at once and deposited, let's say, and load and put in the queue, and then the queue will be consumed in the right order with the full message there. It's a resource of the RTOS. That's how you fix that. And we'll see that the code now. So here is exactly the same stuff with the lockers and everything else. I have here what I call mailbox, because it's kind of like a mailbox. I send messages to the mailbox, and I have many producers sending messages to the mailbox, and just one single consumer, which is this task here, that waits for a message to be put in the queue, and in the case in the buffer and the ring buffer, and I just print that message and release the memory here from the queue with this code. I say print it at once, and when I run it, it will print in the right order everything. You'll see that as I will show you here running. So if I pause it and see it, you'll see 0, 1, 2, 3, 4, 5. Oh, it's not in the right order. Why? Why is it not in the right order? Well, maybe because I'm still printing the counted one. The code is not doing the mailbox. So I will use the mailbox to print. And if I run it, now that will be using the mailbox, the queue. And if we look at here, we'll see that printing one by one in the perfect right order. It's a little bit slower because it goes one by one, takes into consideration that timing stuff. And we see that it goes one by one. And there is a problem with that too. What is the problem? The size of this queue. In the case, this ring buffer. And if this ring buffer is not big enough and you have too much production of messages, it will get full. And then you will not be able to put the message there. And that's done here when I set up in the setup function. I set up the ring buffer. I set that as a big one, which is 8K. But if I put just half K and run it, you will see that it very quickly will run out of space and will issue some message saying there is no space for all the messages I'm producing in this queue. You'll see that pretty soon. Here, failed to send item, which means no space anymore for more messages. And that's something that might happen. So the size of this queue or this ring buffer is important. In our case, to solve that, it's not that difficult because all we need to do is just maybe remove the random time here, so everything will be done faster. Some producers and maybe producers and consumers will run better. And also, I don't need the locker anymore when I have the mailbox model, which is the ring buffer. You'll see that everything will run smoothly, faster, and in order, and no messages will be put out saying that, well, we just run out of space there, because we have everything being done faster, and it's all in the right order. As you can see here, there is no messing with the order. All the messages are there, and the test messages and the loop messages are all together here. So this is what I wanted to demonstrate. All the code is there for you. You can see that in the page. Let me show you the links for this last one here. So here we have all the links for the examples with the blink LEDs. And here you have the examples in the walk with the code for this printer that we just done a few seconds ago. You can look at the code, play with that, change it as you want, make a copy, create whatever you want. You can also test that directly with the IDE and the SoC, running that in the hardware if you want to, no problem. Well, it's done. This is what I wanted to talk. Let's go to the question and answers session now. Feel free to make any questions. I'm here to answer whatever you need.
Hello, everyone, and welcome back to another Q&A session. And now, directly from Brazil, Rodrigo will answer all your questions. How are you today, Rodrigo?
Very good, thank you. How are you doing too?
Yeah, I'm doing great, thank you. And it's nice to see you here at DevCon23. So the first question from audience we have now is, are the SMP specific X task create pin to core API also exposed in Arduino?
Yes, it is exposed because all the FreeRTOS functions are exposed to Arduino. So when you run Arduino, it already has all the header files from FreeRTOS. It's included automatically actually in the arduino.h file, and you can use all the different functions, including the pinning specific task to one of the cores and any other of the resources of FreeRTOS as well. So everything is there. The precompiled libraries are able to do everything fine. And so all the functions are available to Arduino sketches.
Okay, thank you. So I think we can mention that like we have ESP-IDF under the hood. So, and actually this is the main topic for about like the main topic of your question. Sorry, question not your talk last year here at DevCon.
Exactly.
Yeah. So we have one more question here. So which core does Arduino run on? Can I change it?
Yes, well, you can change it for sure. Usually Arduino will run the core 1 or when there are 2, because it depends on the SoC. Some SoCs will have just one core, of course, so there is no option. But when you have the option, then yes, you can run both. You can just pick, and it's possible to be done through some predefined symbols. Or you can go to the IDE, to the Arduino IDE, and choose that from the menu as well, which is also possible.
Okay, thank you. So next question. Sometimes I get watchdog panic errors. What can I do to avoid it?
Yeah, watchdog problems are usually when some of the tasks are running and they are not, let's say, allowing other tasks to run. So there are many ways to do that. One of the main tasks is if you're running something very, let's say, heavy, you should maybe sleep or delay, in the case of Arduino, your task for a little bit time. So the watchdog actually will run, because watchdog is basically kind of a task, very low priority. So you just like feed the dog, saying that, okay, you run a little bit, then the timer will not just say, well, you didn't run, or I didn't run, so there is a problem here. So there's other way, which is basically just feeding, forced feeding that watchdog, which is also possible, not doing through maybe a delay or any other way of changing the schedule and allowing the schedule to move to the watchdog task. So it's about more maybe thinking about the tasks, how it's being run, how is your architecture, feeding the dog explicitly, or maybe just delaying or suspending your, not suspending, but blocking your task for a little bit of time, so allowing others to run, including the watchdog itself.
Okay, I see. I do prefer like when you say like feed the dog, because I know like some people say kick the dog, and this is like not that polite.
Yeah, no, we love dogs.
Yeah. Okay, so we have one more question here. And can I run Arduino sketches with absolutely like no FreeRTOS running together?
Well, in the case of Espressif, and with the framework we have here with the ESP32 Arduino core, it's not possible. You need to run FreeRTOS somehow, mainly because, as I said in my presentation, loop and setup is a task already. Yeah. So you always run at least one task. You can maybe not run other tasks, but it's not maybe even possible, depending on what are the resources you're running in your sketch, For instance, if you're using Wi-Fi, there might be some Wi-Fi specific tasks running, Bluetooth the same. If you're, for instance, receiving messages somehow from some other system, you will have some other tasks running that even if you didn't started those tasks. Sometimes they're just automatically started by the Arduino core itself. So the Arduino core relies on having FreeRTOS and being able to run many tasks and for different functions and needs with different also priorities as well. So especially for the communication, wireless and other communication means that you might use in your sketch. So the answer is no, it's not possible to run without any FreeRTOS. FreeRTOS is there and it will be always be there, at least for the core we have here.
Absolutely. So thank you for all your answers and also like being here to present your very informative talk with a lot of different demos. And I hope you are enjoying DevCon.
Yeah, sure. Thank you very much. And I hope that everybody has enjoyed that talk as well. Thank you.
Thank you. So now we can go back to the studio.
Okay, with Rodrigo's really interesting talk and the following Q&A session, the second part of today's conference has come to an end. But don't go away, because we have more.
Yes, in fact, we've saved the best for last. We have 4 guest speakers in the next 3 presentations from GXB Ventures, AWS and NovelBits. And of course, the final live 30-minute Q&A session of the conference, where Ivan will be answering any questions from the audience which have remained unanswered during our 2-day event.
We'll be back in 15 minutes, and so should you, because I'm telling you, you don't want to miss this.
Welcome back, dear viewers, for the last session of DevCon23. We'll start with a presentation I've been really looking forward to. It's entitled From Rockets to Cellos, Real-World Applications of ESP32 Series Microcontrollers and Development Board Variants. Taken to the virtual stage is Surya Jayawira, CEO of GXB Ventures, and Sorin Jayawira, his son, an electronics engineer at GXB Ventures as well. GXB Ventures is an international technology incubator developing collaborative, educational and family-oriented services.
Today, Surya and Sorin will share with our viewers their journey of switching projects from various Arduino-compatible platforms to the ESP32, unraveling the compelling reasons behind this strategic shift. Through practical experiences, they will shed a light on the seamless integration of ESP32, and they will showcase real-world examples from diverse projects, including computerized electronic cellos with custom audio processing, high-powered rocket telemetry, high-altitude weather and space balloon research, semi-autonomous rovers, and weather stations. It sounds fascinating. Let's listen to what they have to say.
Hey everybody, welcome to our talk. It's From Rockets to Cellos. It's about practical applications and considerations when considering wirelessly enabled solutions using the Espressif solutions. By day, I am an entrepreneur and technologist. And Soren?
Just a hobbyist and a nerd who likes fooling around.
And we just like creating cool things. And we'd like to share some of the things that we've learned and how we've hit our head into the wall many times, day after day. But in the end, it turns out to be worthwhile. And hopefully some of our tips and insights can help you understand how to accelerate your development from idea to creation.
Alrighty.
So first of all, I want to start off with, we know everything there is to know about Espressif. No, not at all. Basically, when you start off, doing the research, watching all the YouTube videos, reading the forums, when we started thinking about microcontrollers in general, we thought, okay, we got this. I'm an engineer by, training. Soren's an engineer as well. We can figure this out. And so you start off with a certain amount of confidence that comes up. And the more you learn, the more you're like, yeah, I got this. I can do it. Until you get to a point where you realize life is complicated. And you realize there's a lot more to know about everything, not just the type of hardware you choose, but what sensors, how you integrate with it, what kinds of programming languages.
You change power consumption. What wireless protocols are you going to use? How are you going to design your antenna? What network topography are you going to use?
So you'll find over time our confidence level, as inventors, tends to go down simply because you realize the world is a lot bigger. Just like the world of Minecraft here in the background, where you can see your nearby surroundings and you think you mastered your area, and then as soon as you start exploring the world, you realize the world is huge. And so we're going to give you a little bit of a taste of what we've encountered and hopefully share you some time as you develop your own products. So we first started off with the end in mind, right? As they say, begin with the end in mind. And so our goal was to figure out, can we start off with just a wireless button that could be a data node that could easily just measure some information, or be a call button and send it to other ESP nodes or other microcontrollers throughout our house or throughout a restaurant or throughout a hospital, what have you. So that's our wireless button. And so in order to do the wireless button, after checking out many different microcontrollers, we have really started to appreciate the beauty of the ESP-C3 series, which is right here. But I'll give you a show about that later. And we combine that with the ESP Now technology and Wi-Fi and ESP Mesh, and it works out really well. But Soren, what happens when you combine a wireless button along with a environmental sensor?
Then you get a home weather and monitoring station. You're able to have these just around your house and just measure any data that you want to have. Now, what happens when you have all this data and it's just a regular monitoring station, and you make it slightly longer range, maybe slightly faster, and you put it onto a rocket?
Well, there you go.
Rocket.
So you get a model rocket telemetry and tracking system that utilizes basically what we built for the home weather station. And we're going from measuring the temperature in the backyard, in the attic, in the back house, in the garage, wherever, in the attic. And now you add in GPS tracking, LoRa for long-range communication, and an IMU, which is an inertial measurement unit. That's like an accelerometer and gyro and magnometer, which is a compass. And now all of a sudden you have a very, very tiny package that can be used to track, that basically it'll be about this size, and it can be used to track all this information, which is far smaller than standard commercial off-the-shelf telemetry packages that are sold for model rocketry. But Soren,
what happens if you make that really long range? Really long range.
Okay, so if you add about 30,000 kilometers between nodes, well, all of a sudden you have now a high altitude weather balloon system. So basically, we want to get a big balloon, fill it up with helium, let it go up in the sky, take some pretty pictures of our little space astronaut in space. And the thing is, how do you recover the payload afterwards? So that's where you have your rocketry tracking system. You add in the long-range antennas and access to public gateways through LoRa. And now, wherever it lands, 200 kilometers away from here, we'll be able to track it and find it. But what happens when you now put this on the moon or on Mars, or simulate doing so in the desert here?
So you can actually start working on an autonomous retrieval or a tracking system. So you could just have a relay drone and send out a rover to maybe pick up your rocket or whatever payload has fallen.
So basically the concept here is Soren's like, I want to work for JPL, but I want to actually work on simulating what it's like to create the rovers and create integrity and ingenuity, the Ingenuity drone and Perseverance. And so we thought, well, why not just do it here? And so make a robotic rover and make a drone that can communicate to each other and have the drone be able to help guide the rover to picking up the payload package from the balloon. Now, what happens when you combine everything that we've learned, which is about robotics and microcontrollers, and add in a little bit of music?
Then you get what we called Robello, just robot cello, where we have digital signal processing on the chip, and you can have recording, playback, a bunch of cool audio effects, distortion, everything you want. So this is a early version we have. I've got it in my background right here. It's just a cello for doing wacky things, and it's doing all of the processing ourselves.
So what you can see at the bottom, can you see my mouse here? I'm not sure you can.
No, it's hidden by.
Okay, so, oops.
You can't see the mouse, but
you can? Okay, so when you see at the bottom, there is a foot controller, and it's this guy. All right, so basically, we just took a little doorstop, pushed in a button. At the bottom, you have a C3 and a battery, and that's communicating via ESP now to an onboard Espressif C3 that picks up those signals and feeds it as input to a Teensy. So this is another microcontroller by another manufacturer called Teensy. And basically this has an audio shield, which we've been experimenting with before we discovered Espressif systems. In addition, this microcontroller system, we custom designed this board and had it manufactured and are playing with it. This is version 3 now. This can send the audio signals back to the subwoofer that's inside the cajon drum. So all of a sudden, instead of having cables everywhere, we're using wireless communications, being able to play the audio from the electronic cello and being able to pick up on input as well from when the drum is hit to record it into an SD card that's on the microcontroller. And all this is being enabled through the Espressif wireless communication systems. Right. So after understanding the projects that we've been working on, just for fun in the evenings, it leads us to what are our actual requirements. And so when thinking about how to proceed, our requirements were they have to be small, they have to be light, it has to be wireless, integrated, ideally, so that things won't come apart, whether it's from vibrations going up in a rocket or from a cello being carried around. And it needs to be battery powered, because who wants to be plugged in and limited by that? And also, we need to have really good power management. so that it could last a long time. And we'll go through this. So basically, we're looking for something as small and as light as a feather. And there you go. So let's go through what our experience was in thinking about dev boards. When we started using Arduino. I think it's how most hobbyists got in this. And we started with this about a decade ago. It's really great. It's a great place to start. You do rapid prototyping, but it's a basic platform right now. And so from that, we quickly moved on to the teensy line of microcontrollers. We don't have any complaints there for what they are. They are very powerful, very small, very active community, and a very helpful community. But they don't have integrated communication. And compared to others, because they're so powerful, they do have a high energy requirement. So then you go on to the Raspberry Pi. We experiment with that a little bit. And, the thing to remember with the Raspberry Pi versus our needs is it is a true computer. So that means that it has the advantages of a true computer. It has multi-threading. It's actually running the operating system. You're actually connecting to it to do the programming. And it has integrated wireless. But on the other side, commercially, even though it's supposed to be $5 or $10, on Amazon, it's not. And it tends to be very expensive. It cannot tolerate hard shutdowns because it's a computer. You might corrupt it if you do. It has much higher energy requirements than the others. As you can see, it's 1.2 watts. It's larger in general. The feather is still small, right? But it's just not really comparable to what we're trying to do with others in terms of making a custom PCB board. So then we started exploring, and we came across other integrated microcontroller boards that incorporate the Espressif chips. And that's what led us down this route of we thought, what if we could use the Espressif chip, put it into our own custom PCB? And the best way to play around with learning how to do that is to use an existing dev board. And these turn out to be really inexpensive. They're like $15 for 3 of them or something like that. So it's a great way to get started. It has integrated wireless. It's inexpensive. And most importantly, it's optimized for low energy. You can see when it's in deep sleep mode, it's using like 6 milliwatts compared to 1.2 watts. Basically, it means that the same size battery would last 200 times longer with the Espressif system. So it's not that I need to last 200 times longer, but it could be a smaller battery. And also, you can see that the things we're doing didn't really require a lot of processing. It's a lot of data management and wireless communication. So it turned out to be perfect for us. So getting started. How about the software development environment? What did you find, Soren?
So for our project specifically, there are major differences if your microcontroller is running on precompiled C versus interpreted MicroPython or CircuitPython, because it takes more energy to be able to process that, and we wanted to maximize power savings. In addition, we just found Arduino to be very easy. VS Code and Platform IO worked. You can use anything, but just Arduino had really nice integrated examples, and code was efficient power-wise, so we decided to just stick with it.
Yes, so our lesson here is we thought, okay, now you've been playing in the playground of Arduino, let's grow up and go to a more professional development environment, like what my team members use for my company. But the reality is we really like the integrated examples in Arduino, and when you look at comparison tests on YouTube by other professionals, it turns out that the code developed is just as efficient as using any other IDE. So of course, we'd love to learn how to use Espressif IDE more efficiently, but as we're hobbyists and we're learning ourselves, we decided to stick with Arduino, and we're pretty happy with that. So that leads us to the dev boards. And you'll find when you start getting into this, they're like an addiction, and you start buying them like candy, trying to solve different solutions. And it's really interesting. So let me take you on our path. Are you able to see my mouse?
Mm-hmm.
Okay. So we started off with Arduino, and then we went to the Mega because we wanted to control a big kind of robot initially. And then from there, we thought, okay, let's make the jump and go to the teensies. So we started off with the smaller teensies, and we went to the 4.1s like you see here. That's actually what we ended up using in the PCB that we developed for Rebello. And in doing so, we're looking for a wireless solution. And we're looking for a solution for the rocket and for the balloon. And that's what led us to these. This is a cube cell, and then the HealthTech LoRa Wi-Fi boards. What we really liked, we thought this would be great. They're all in one. They have GPS and they have LoRa. It's like, that's almost everything that we need. But we encountered a lot of problems with doing the actual integration. And we weren't able to solve these through the communities and through the direct communications with tech support that we needed. And we thought, okay, let's jump on to the one that has Wi-Fi plus LoRa together, and we could add in our own GPS. But there themselves, there's some non-standard issues that we encountered in trying to use these boards and integrate them with other sensors. And the main, most frustrating thing is that the example code generally didn't actually work. So from that, we thought, well, let's look at the chip that's powering them. It was Espressif, and we worked with Espressif directly. We're not paid or anything by Espressif, but we went to their website and we understood what they did. And so we discovered the C3 chip, which is right here, and these dev boards, which are, and this dev board, which is a Teleton Robotics dev board. Highly recommend it. It's actually turned out to be really, really good. And I'll go through the rest of what we have displayed here in a moment. But the main lesson that we learned is
not all boards are created equal.
Yeah, and what do we mean by that?
So we were doing some range tests while we were developing our button platform. And at first we started off using the ESP Room32 dev board, and we were getting maybe 2.23 meters of range. And that definitely was not going to cut it for our applications. And so we started to give up a little bit, but just on a whim, we uploaded the exact same code onto the C3 by Teleton Robotics. And the main thing to note is that the antenna is extended beyond the PCB. And there, we extended from 2 to 3-ish meters up to like 60, 70 meters through multiple walls, through our entire house, multiple metal cabinets. So not all boards are created equally. Sometimes something just won't work and you'll have to keep trying with another board and it will work. So
feed the addiction.
Yeah.
You basically experiment and just try different boards, right? Don't give up. Honestly, at this point, when we were using this board, we're like, wow, this is impressive. Like, the marketing does not at all line up with what our experience is. Because, you'll see videos of where they're controlling, lights from 500 meters away using their ESP Now technology. And again, we were getting like 3-meter distance.
Through a single wall. But
through a single wall, yes. But then it turns out it's actually real. You just have to experiment and try them. And then also remember, our goal is ultimately to make our own little custom PCB that can fit these scenarios. So that's why we love that we could actually see the chip that's being used, and then we know that we'll be able to integrate it ourselves when the time came into our own board. Something else that's really interesting is that not some antennas marketed for LoRa 915 megahertz, which is the long distance communications, low energy, long range, low energy protocol, is that they're not actually optimized for that. And this includes the antennas that are shipped with the boards, right? So you'll see as an example here, this shows, this is an antenna signal analyzer, and it shows the sensitivity at 915 megahertz. And you'll see, for example, when you just look at the stub antenna directly connected, it has almost no sensitivity at the frequency that's supposed to be working at for LoRa. However, if you include the pigtail with it, and then all of a sudden it is perfectly tuned. So that's a lesson. We thought that we'd attach this directly to the PCB. It turns out you really shouldn't do that unless you have other optimization for impedance on the board itself. And you need to keep the pigtail on. Secondly, when we look at this antenna, which is shipped with some of the boards, there is absolutely no sensitivity around 915 either. So it turns out that this is another reason why maybe the boards had bad range. Now, before we get into selecting antenna types, I wanted to share a little bit about what we have learned about decibels, power, and sensitivity. When you get a GPS module or when you get different antennas, they'll say, oh, it's a +2 dB, or it's a +12 or +6, or a GPS module might say it's 140 dB sensitivity. What does that mean? Well, basically, every time you increase a dB by 3, you're getting twice the power output. And when you double the power, which is 6 times the dB, you get twice the distance, theoretically. And for audio.
For audio, every time you increase 10 dB, that accounts to about 2 times increase in perceived volume.
Great. All right, so now let's go on to the actual antenna types. First, there's the lowly monopole, aka the cut wire, that's cut to some fraction of the wavelength of the
I wouldn't
signal.
say lowly, it works pretty well.
Yes, that's true. And now if you take the same wire and you put it on the opposite side to act as a ground, that's called a dipole. Then you have the trace wires that are built in as part of the PCBs, like that, and as you see on the C3s and other platforms. Or you have a coil, which is basically the wire that's wrapped with a certain coil spacing and a certain diameter to generate a certain amount of impedance through induction that generally has to be about 50 ohms. But it's a little bit harder than it seems to coil the wire exactly as it needs to be to make a good coil antenna. Then you have a stub antenna, which we already reviewed in the previous slide. And then you have a patch antenna, which you can basically stick on as a sticker, or they can be as big as a plate. And it's just a solid copper side on one side, and the other side you have the ground. And that ratio of dimensions is what creates your antenna. And then I wanted to point out that with GPS antennas, you'll see this little back. At first we thought it was a sticker or something. This is actually your antenna. And you'll see the little marks there. Those marks are actually there to tune it. They are not like manufacturing mistakes. It's fine tuning for the antenna. Now, the other type of antenna you could always use is what's called a Yagi antenna. And the Yagi antenna is very sensitive. You can get a plus 12 dB, all right, improvement. But the challenge is it's big and it's highly directional. So these are all tiny on the order of centimeters. This is, 80 centimeters, almost a meter long, and highly directional. So if you're working with two objects that aren't precisely aligned with each other, we quickly find that actually the lowly wire antenna works quite well.
Better.
Quite well. But what's something else that we learned? Well, when we see people doing comparisons on YouTube of range tests, they'll usually lay their PCB on the table and check the range that way. And that's absolutely wrong. The reason why is you have to have minimum spacing from the ground to where the antenna is. That's why most antennas point up. But the reality is you just need to elevate it off of the ground, roughly about at least a quarter of a wavelength as we found through just experimentation. I don't know the physics. I'd love you to tell me what the physics is for that effect. But here's what we can share with you while you're getting started. How to cut the exact right length for an antenna. You simply figure out the speed of light divided by the frequency. So example for us, the 915 times 10 to the 6, because it's megahertz. And then you end up with the exact length that you need to have for your wire antenna. And you'll see through research done by others that actually the wire antenna turns out to be almost as sensitive as the coil antenna and much less directional. So when you don't know the orientations between nodes, it's a great way to go. With a dipole, we suspect in our own testing, we're getting much better results. Now, when you talk about line of sight, like Espressif will say, you might get 200 meters line of sight range or something like that. You have to keep in mind for the Fresnel radius. Tell us about the Fresnel radius.
So the Fresnel radius essentially says how far off the ground or how much clear area you have to have in order to actually get a high quality signal. So for our use cases, say you have a rocket payload lands, you want to communicate with that payload. If it's on the ground and it's suitably far away, you're not going to be able to get any signal. 1 kilometer, the Fresnel zone is about 30 centimeters. 10 kilometers, it's about 1 meter off the ground. No way you're staying 1 meter off the ground. So you just have to keep in mind when you're able to get signal and when you're not. And then how do you get around that?
Great.
So in the real world, if due to either the Fresnel zone or maybe weird terrain around, you'll want to have some way to ensure that you get communication. So this is where we start talking about network topography. Here in this simple diagram, you can see we have a base station communicating via a relay. in order to get messages from the payload.
And that relay could be another rocket, it could be another balloon, it could be a drone, it could be a large, a highly mounted antenna. And again, this terrain doesn't necessarily need to be a mountain. It could be like just small little boulders in the way, small little rocks, unevenness in the terrain. The fact that your payload and your base station are not both the minimum distance above ground to be able to communicate with each other, considering the radius, the Fresnel radius.
Right. So now that we're talking about network topographies, we're going to get a little more technical. So there are three major ways that you can go about structuring your network. Either point-to-point, which is where you just have two nodes communicating directly with each other, or you can have hub and spoke. Hub and spoke is a really powerful model because it's great for power saving. In this model, you have a bunch of nodes around a router. All of these nodes can be asleep because they don't need to work on forwarding messages. But when they do need to send something, they just wake up, send a message to the router, and that router then takes it to the rest of your network. Maybe it goes to a gateway, and the gateway just connects your local network to the internet or the LoRaWAN network, the Things network, anything you want. You can also have a mesh network. This has a lot higher power consumption because every single node is active and listening for a message from any other node. But this is good because you have higher network security. You don't have as many points of failure because, say, one node drops out, you're able to reroute your message along a different route. So mesh networks can be very powerful if you need data safety and aren't as worried about power.
But let's take a look at the different types of communication protocols that we considered using and where they stand. So here's a little table we put together. I would say take this table with a big grain of salt, as we'd say, because it's based upon data from the interweb. And the reality is we haven't tested these directly ourselves, and that's the only data that we'd like to trust. But in general, you'll see that ESP now, as an example, is good for relatively small payload packages, things like 250 bytes per transaction, and you can do up to 60 or 70 per minute, up to Wi-Fi. And each of these have advantages and disadvantages. Keep in mind this is a logarithmic scale, so basically you're going much further distances with these different communication platforms. And so it gives you a little bit of an idea of what to use. You can take a look at this a little bit later. Mm-hmm. Tell us what we actually ended up using.
Okay, so for our specific examples, we mainly rely on ESP now. Because for our buttons, we didn't need to get a very long distance. And so we could just have peer-to-peer in a hub and spoke model, and we could save a lot of power. For the cello, we just have communication via ESP now in each of the pedals. For the buttons, it's ESP now to our relay, which then goes on to the rest of the network. Other people might use ESP Wi-Fi mesh, but it really depends on your scenario. We are also looking at using Bluetooth 5 A2DP profile for sending audio from the electronic cello to the subwoofer. Alrighty. So there are a lot of different ways, now that you know about network topology, that you can actually communicate on a network. The main ones that we were looking at were LoRa and ESP now. LoRa is a physical layer protocol that is used for point-to-point communication, and most of the boards that you're using are not able to handle full duplex. They're only half duplex over their time slices. But it doesn't really matter if you're able to connect from LoRa to a gateway. The cool thing about LoRa is that it's very, very long range and very low power consumption, although that does decrease your data rate. Now, using LoRa, you can have LoRaWAN. This is a network protocol that runs on top of LoRa. It has public satellites and public nodes that you're able to, or public relays that you're able to go to, and it's a very standardized protocol, so multiple devices can communicate with each other. On the other hand, if you want to implement a true mesh instead of a hub and spoke, then you could use Radiohead, which is just a nice library for handling LoRa communications on the SPI Hope RF boards. And with the mesh, of course, you have greater power consumption, but it's a true mesh, and it's got pretty good implementation. On the other hand, if you know the structure of your network, so it's not needing to be adaptive, there's a nice hobbyist library called Farm Data Relay System. that gives you amazing modularity for being able to have data sent either via LoRa or ESP Now, and having devices able to translate between the two, and then just connect to a gateway and go to the rest of your network.
And you'll notice the last two actually require SPI LoRa boards. So tell us about SPI versus UART.
Okay, so the two main boards on the market are the Hope RF RFM95W and the REX RYLR series. The Hope RF is SPI. It works easily with Radiohead. It's got a small form factor, and it's used on most chips that are LoRa enabled. You also get to add whatever antenna you want. So if you've listened to our antenna research for dipole, full dipole, half, whatever, you can put whatever antenna fits your use case at whatever orientation you think will be best. Unfortunately, the pins don't match exactly breadboard spacing, but you can either put on individual wires, or there are a lot of adapters that people have made to fit breadboards. On the other hand, the REX series is great. It's user-friendly. You don't need anything to start with it. You just send an AT command of whatever you want, and it's nice for peer-to-peer. Unfortunately, it doesn't have much support for mesh networking or any other complicated network topology. And it is also slightly larger than the RFM Hope RF board, but it's still really good when you're getting started for peer-to-peer. One thing to note is that the two LoRa boards don't communicate with each other immediately if you're using Radiohead, and so you'll have to do a couple changes in the code. One, you'll have to enable promiscuous mode to change the way that Radiohead structures the messages for the Hope RF. And two, the REX RYLR boards always append the length of a message in the very beginning. So if you're trying to read that on the Hope RF through Radiohead, you'll get like a garbage byte in the beginning, but that you'll just have to know is the length of your data package, and then you can fix it relatively easily.
So the main lesson here is even LoRa boards, even by the same manufacturer, are frequently not actually compatible with sending LoRa messages to each other. So don't give up, don't be frustrated. So what's the purpose of this talk? That's the end of it. Basically, we just wanted to help inspire and help other people get started in this hobby and to invent and create new things. In general, after surveying many other microcontrollers, including many implementations of the Espressif dev boards, in general, it's definitely been an adventure, but it's been a good adventure. And we highly recommend the system and the platform, and don't give up. So look forward to seeing what you create. And hopefully by the time this comes out during the Q&A, we can show off what we've accomplished. That's it.
Yeah.
Hello, everyone, and welcome to another Q&A session. And for this session, we have Surya and Sorim. How are you guys?
Very good, thank you. How are you?
Yeah, I'm doing great. So I really hope you are enjoying DevCon23, and I'm pretty happy to see your talk, which is quite inspiring, to be honest. I think you are guys, you are like inspiring people, and specifically talking about like topics that are like scary for most of the people, like radios, like RF is quite like complex for understanding. So I'm pretty happy to see like you guys, like trying and seeing by yourselves.
Yeah, as we said, we stumbled a lot and we hit our heads into a lot of walls trying to figure things out, but we just wanted to encourage people to experiment with the Espressif ecosystem.
Yeah, and I think you guys are doing a great job. So we have here one question regarding like ESP now. So question is, how do you reconcile changing Wi-Fi channels with ESP now? I had to use two ESPs, one for Wi-Fi, the other connected via UART for ESP now, and now Ethernet, like no Wi-Fi, plus ESP now on one ESP32S3.
So that's a really good point. The router is actually for us 2 chips. So you have ESP now communicating, and then just a direct digital input into the other chip of what is happening, and then that is connected via Wi-Fi, or in the future we'll be also supporting like a SIM card.
Okay, I see. So you guys, you already sorry, you have
Well,
anything to
just you can use like a really simple like 12E or any other chip for your connection. But basically, what you have is our solution.
Okay, I see. So you guys are like you already share like a lot of different experience you have with some like really cool results. So is there anything else you could share with our audience? Like is there anything else you are working on right now, or some like news from like since we recorded the talk?
Well, so we're never really finished, as you know. As soon as you work on any sort of project, the more down in the details you get, the more complicated it gets, and the more problems you encounter. So we're still actually working on several of these projects right now. But I did want to just point out something just for the fresh hobbyists who are getting started, and that is that you know, frequently like on Amazon or wherever else, I'll read that hobbyists don't like using the Espressif chips with breadboards because they'll say it blocks, right? They'll say it like blocks all the pins, and so it's really hard to do any sort of wire routing. And the answer is super simple. You just simply take two breadboards, break off the power rail on one of them, put them together, and now you have a perfectly sized breadboard for development. So just want to show the hobbyists it's really easy to get started and get playing around with this. What do you think, Sarah?
Yeah. I mean, it's worked perfectly for us. It's definitely a lot better than trying to thread it underneath.
No, but any other tips, sir?
I honestly, I feel like we've gotten to most things in our talk.
Are there more questions in the Q&A?
Like there are people that think you guys you are like inspiring them. So like I think that's like really good feedback. And another thing that I think you should be really proud of your son. Like I do have son, and I really want him to like follow my steps. And this is probably like quite you know, like quite nice to
so
see.
I just want to point out, like, we are by no means experts in anything here. We're simply just hobbyists who just stumble around and continue to persist. So, but I'm happy to help. If anybody has any questions, they could contact Soren or I directly. Soren's a more technical developer, and I'm more the, I guess, random idea guy. But we'll help how we can.
Yeah, and we will like continue here on chat. Like if you have any other questions, you can just ask them in the chat. Like we can try to answer. And again, like it's a very inspiring talk. So I enjoyed like a lot. So I hope like our audience will get inspired by you guys.
Yeah, I love to see what projects everybody else develops. Anyway, thank you for inviting us.
Yeah, thank you, guys.
Yeah, and feel free to reach out and contact any of us for any questions. We'll be as helpful as we can.
Yeah, our email's on the front side. Okay, take
Perfect.
care.
Thank you so much. And now we can go back to the studio.
Next, we have another two valued guest speakers from AWS. Anton Shmagin, who is a cloud infrastructure and security architect, and software engineer Dhaval Gujar. Today, Anton and Dhaval will delve into the reasons why AWS offers the most comprehensive suite of services for building your next connected product, and why so many AWS IoT customers trust Espressif solutions.
Indeed, over the last several years, Espressif Systems has become a valued AWS technology partner. As a unique one-stop provider of various hardware and software AIoT solutions, Espressif has enhanced the advantages of its offerings even further based on the AWS expertise, global reach, and automatic scaling with serverless technologies.
Hello everyone, my name is Anton Shmagin. I'm Partner Solution Architect with AWS IoT Services. Welcome to ESP DevCon 2023. In this talk, me and my co-presenter, Deval, will go through certain templates, certain advices, how you can build connected smart devices faster using several reference architecture that we put together with Espressif. Deval, can you introduce yourself?
Sure. Thanks, Anton. Hi, everyone. Welcome to DevCon. I'm Dhaval. I'm an engineer at the application frameworks in Espressif, and I work on a lot of products with AWS and Espressif together.
Okay. So I will not be on screen because my camera and my presentation cannot coexist, but you pretty much have seen my face. So as I mentioned, the partnership between Espressif and AWS started pretty long ago. Literally from the moment that we announced AWS IoT service, which is in 2015. And since then, we have quite significant amount of customers. These are not all Espressif customers, but I will give it to you to identify which one actually using ESP chipsets. There are quite a few on this slide. As I mentioned, 8 years ago, this partnership started with a humble call with the CEO of Espressif. And since then, basically the ESP-8266 being overturned by the several families of ESP32. And at the moment, all the ESP32 chipset can be connected to AWS IoT Core. In AWS, we're looking into when we're looking at the new IoT projects, we typically categorizing it into two categories. Either our customer looking for some new ways to get the revenue, or they're doing and basically increasing operational efficiency through the predictive maintenance, analytics, the sensory field primarily in the industrial setting, but also logistic, automotive, and many other verticals. Revenue growth, this is typically in new startups, just like you, the developers that bringing a new idea and developing completely new classes of products. So I will not be going through all of the slides in detail, but in AWS, we're providing quite a number of IoT services. Again, it's all started with just the hyperscale broker, MQTT, HTTPS, and WebSocket broker. And through the years, additional services being announced from the device side, from the connectivity side, but also from the analytics and streaming services. For example, if you're building a doorbell, take a look at Amazon Kinesis video streams, right? If in this talk, we will primarily concentrate on the device software and a little bit of the connectivity control plane. So when you're building connected devices, to streamline your work, AWS offer a number of kind of templates or blueprints or reference architecture. If you're using FreeRTOS, we're providing a set of connectivity, device management, security, and or update libraries. AWS ExpressLink is complete package connectivity module that you can retrofit your non-connected design or create completely new offering using application MCU or application processor, and supplement it with ExpressLink module. If you're building the embedded Linux devices, you can use the Greengrass, and on both MCU and MPU, you can use the CSDK if you want to build, let's say, bare metal devices. At the foundation of our offerings, and also it's kind of like a match made in heaven with ESP-IDF. ESP-IDF adopted FreeRTOS pretty early, and FreeRTOS, it's one of the oldest and most robust real-time operating system. Started over 18 years ago. For more comprehensive talk on the internals of FreeRTOS, please listen to Richard Barry talk, who is the original author and also senior principal engineer at AWS right now, basically overlooking the development of the FreeRTOS kernel. In addition to the kernel, as I mentioned, we're offering the connectivity, security, and device management libraries. All these libraries are open source, licensed with MIT permissive license, so you don't need to worry about any royalty payment or anything like this. If you would like to use those core libraries, let's say with your MQTT broker, you're welcome to do that as well. Some of the libraries obviously tightly coupled with AWS services, for example, something like Device Defender. Over their update, I would say it's pretty tightly coupled with our cloud offering as well. But let's say HTTP MQTT library, you can use it with any MQTT compatible broker. What we've done also for the last 3 years, we created a reference, featured reference architecture, featured reference integration, we call them, that allow to utilize the best practices, pretty much to springboard your project even more, right? So, for example, that security becoming not the afterthought, but becoming an integral part of your design since very beginning. Dhaval, do you want to tell a little bit about the feature reference integration?
Sure. So I correctly said we already had this, but the CSDK was split up into individual examples. And for customers to build a production application, they had to start from those individual examples. So we thought, let's put everything together and give a better production-ready example or a starting point that people can build on top of. And it includes solutions for things like real-world use cases for MQTT or Wi-Fi disconnects, or the best security practices. So typically, as you said, security becomes an afterthought, and then you have to change your architecture. But if you start with this as your starting point, you need not have to refactor any of those aspects because it's built into the design itself. One thing I wanted to mention is, while the name currently includes the C3, the design and the repository itself is now applicable for all of the Espressif SoCs that have Wi-Fi. And it's in the process of being renamed, but this works out of the box with any Espressif SoC.
So I'm at the moment, I'm flashing a reference design code that I would be able to control LED on ESP32C3 board. And basically As you see, the code is flashed, acquiring the IP address. Okay, so if I will switch right now to, and let's say publish a message with to turn the LED off, turns LED off. I have a couple additional projects to show. If we will have a time, maybe at the end of the show, I will show let's say a project with a color sensor. So, but overall, it's a pretty great starting point, as you notice. And if you will go to the this link, you can and get the any ESP development kit. You can start pretty much very quickly, and as I said, with a pretty great level of confidence that your project utilizes best practices. Right, let's continue with the presentation. So for all the connectivity libraries, we have a long-term support. Obviously, we're developing the code much faster, but for the 2 years, you have a confidence that we're going to be backporting any security patches, any performance patches to the LTS branch of the libraries. And if you need even longer support, this is unfortunately the paid subscription. But if you need a long-term support over 2 years, you can subscribe to the extended maintenance plan, which will allow you to get those patches to your firmware for basically 10 years. Another possibility, another option to build product is to utilize what we announced a couple of years ago, and it's called AWS IoT Express Link. So AWS IoT Express Link is the pre-programmed modules from Espressif in this case, and I can show these are the modules as they coming in a tape, and you can basically you can retrofit your existing product with your existing host MCU with these modules, and the modules running a firmware that allowing them to be claimed into your AWS account pretty seamlessly, and also you controlling these modules using the using AT command set. So think about it as a cloud modem per se. Again, the all security, all device management over the air update is done for you. And I have a at the end of this section, I will also show the another demo using the Express Link. But going back to the presentation. So Express Link, as I mentioned, allows to utilize any type of microcontroller, including 8-bit microcontroller, if you're running such design at the moment, and make it into modern cloud connected product. So the development and also deployment is pretty quick, and I would say the level of security that that these modules offer is pretty great as well, because you can use any contract manufacturer, because the root of trust already burned on the Espressif production lines. There are nothing. I mean, contract manufacturer will not be able to extract these crypto materials from your design. If you want to run completely robust, completely bulletproof, you need to encrypt the UART encryption between the module and your host processor, or you can encrypt your payload and do the decryption at the cloud side. I would say that a dozen of AT commands becoming more and more as we're introducing more functionality to the ExpressLink. But again, it's pretty intuitive how you can develop your product using these modules. And this is basically a minimal example that allow you to send a very simple message to the cloud. As you can see, pretty it's very, I would say, easy to understand. As I mentioned before, underneath of under the hood, pretty robust implementation, and we're collaborating. Our service team and Espressif collaborating to make sure that any issues is addressed as quickly as possible. Typically for the devices that already in production, that already deployed in the field, you can do pretty non-intrusive over-the-air update. We guarantee that over-the-air update would be successful. And for the experimentation, you can run also over-the-wire updates and get the latest and greatest before you will deploy your design to the field. So currently we have very high level of interest. I would be honest, there are obviously not too many customers yet that build a product with ExpressLink, but it's basically the number of customers that building the production products with ExpressLink is increasing. As I mentioned, to get started, you can get the ExpressLink development kit available at pretty much major retailers, including Amazon, Moser, DigiKey, and so on. You can get it from AliExpress, Espressif store. A development kit as well is the board at the very top here. You can run the ExpressLink demo page hands-on workshop. The design of this page is also open source, so basically you can order it from the PCB manufacturers. And finally, I will show a demo with STM32 host MCU. ST created an entire cube package, so you can start even easier than basically coding every single command. So I will quickly show this on the overhead. So this is kind of a contraption that consists of host MCU, Espressif ExpressLink module, and the sensor shield on top. So what we can do, we can switch to So it's currently sending the temperature, humidity, and IMU values to the cloud, and I can basically show you in the Chrome. This is the basically these values going into the time stream database, which is our AWS time series database that you can utilize for your designs, and then basically visualized with Grafana. But you can build, I will touch it a little bit later, but you can utilize AWS Amplify. But even better, you can use the ESP Rainmaker product to basically build a complete solution with ExpressLink, Rainmaker backend, which subsequently utilizes the AWS services. And Rainmaker allows you to build very quickly mobile and web responsive application. So not only visualization, but you can build the entire control plane with that. Okay, back to the presentation. Yeah, so you see that the values is, I mean, I can probably put my vapor a little bit, and you can see that humidity level should increase. Yeah. Anyway, so let's talk a little bit about the services that AWS offer from the connectivity standpoint. The oldest and most comprehensive service is obviously AWS IoT Core. AWS IoT Core is kind of hyperscale MQTT and other protocol broker. It also has a very sophisticated rule engine that allows you to ingest and transform and redirect the messages that coming from your devices to virtually any backend, whether it's database or S3 object storage, or let's say Kinesis stream. And it also has a device shadow. This is concept that AWS pioneered. It allows you to communicate with device that, let's say, if your device going into the deep sleep mode and you would like to control that device, it's without shadow, it's pretty difficult task. But with the device shadow, you're interacting with the shadow representation of the device, and the moment device waking up from the deep sleep mode, it's actually reconcile the state, the device state, with my desired state that I'm sending from, let's say, my mobile device, or from my responsive web application, or from, let's say, automated API control plane. And also, AWS IoT Core is an identity service. We recommending, while we do have another options right now through the extended authorizers to connect to AWS IoT Core, but a typical recommendation that you're going to be connecting through TLS 1.2 with mutual certificate authentication. That's the most secure way, and it basically ensures that the server cryptographically authenticate your device, and the device cryptographically authenticate the identity of the service, of the broker, I would say. When we started AWS IoT service, we thought that, Well, hyperscaling MQTT broker gonna be enough, but we've been actually pretty far from the truth, because the moment you start deploying a fleet of devices of thousands, and we have several customers that have millions of devices, it's becoming impossible to manage those without device management services. So we offer a pretty comprehensive device management services that can partition your fleet of devices. You can do the rolling over the air update. You can do a partial over the air update. The registry of devices is pretty comprehensive, and the registry allows you to store a static and also dynamic attributes. So think about it. If you would like to control your robotic vacuum, or if you would like to do the over-the-air update to your robotic vacuum, probably want to do it in the middle of the night and making sure that the device is not in a working cycle. Let's say my dynamic attribute should be, let's say I'm at the charging base. This is probably the best way to do the over-the-air update for such device. Pretty comprehensive fleet indexing and search. And as I mentioned before, the beauty of AWS is that you can kind of try all these services using AWS console, but the most powerful way is to use it through API call. So you can create a completely automated backend and tailor it to your, I would say, your project specific needs. And let me emphasize one more time that in fact the ESP Rainmaker is a great starting point, because underneath it uses majority of AWS services, some from AWS set, and also some serverless like Lambda and S3, and it allows you to springboard your backend design if you are not familiar with AWS, but it's completely non-intrusive because you can route your messages to any of AWS services, even those that let's say ESP Rainmaker is not using. Well, do you want to tell a little bit more about Rainmaker and how the project started and evolved?
Sure. So we have been looking at IoT for a while, right? And one of the things that we constantly heard about was the pain points that our customers had with creating their own IoT cloud platforms. And a lot of the solutions that were out there were centralized, and the deployments were out of the control of the customers themselves. So we thought we can create something that is going to help hobbyists and professional users and large customers alike. And that's how Rainmaker came out to be. So let me talk a little bit about what it does and what it includes. So it's a complete cloud platform, which includes an open source device firmware, open source phone application, the cloud backend, and voice assistants, which are integrated into it. And the interesting thing about Rainmaker is that it gets deployed in your AWS account. It's not like you're using our deployment for it. Of course, there's a public deployment that's available for testing things out, but the final deployment would be in your own AWS accounts. And because of the way it's made, it remains extremely customizable. You can extend it the way you would like, and it does not touch the rest of the things, so you can route the data, as you rightly said, wherever you need. And because it's built on top of AWS serverless architecture, scalability, security, the cost effectiveness, and the extensibility are a part of the package.
Thank you. And I want to stress out that it's not only one thing that I really like about Rainmaker is that it's really cost effective, in a sense that, in fact, Espressif run numerous performance tests and also numerous. I mean, there was a numerous adjustment. We've been actually collaborating quite often during the development cycle to make sure that ESP Rainmaker appealing not only for very expensive devices that basically the cost of connectivity is, I mean, negligible comparing to the cost of device, but to the devices something like a light bulb, right, which you cannot get a tremendous revenue out of it. But through the years, ESP Rainmaker refined to the point that it uses a set of AWS services that is really, really cost effective for various customers, right? For example, we Espressif utilizes at the moment the over-the-air update that is not uses the AWS over-the-air update. We in negotiation, maybe it would be next service that ESP Rainmaker will adopt. But again, it was a discussion, and basically Espressif was very, very customer obsessed in this sense, saying that, you know what, I mean, the cost of AWS over-the-air update is prohibitive to a number of our customers. If some customers want to utilize this over-the-air update using MQTT control plane, great. But we're using basically the over-the-air update that we developed, and it's much cheaper, I would say, because the MQTT over-the-air update is metered by MQTT message, right? So last thing I want to touch is how you can identify the threats to the fleet, to your device fleet, and you can utilize AWS IoT Device Defender for that. For example, and Device Defender, it's kind of there are literally like two products to it. You can use it completely on a cloud side and derive your metrics that come into the cloud. But if you want to use a device metrics, it's also a possibility to publish those metrics, get it from the device and publish it to the cloud, and basically make a decision using this enhanced data set. But even utilizing the cloud side, what you can do with Device Defender, you can, for example, identify if my certificate been used by, let's say, multiple devices. Typically, a good threshold is you allow connectivity of two devices because, let's say, you would like to test your device, let's say some issue with particular device. But obviously, if somebody cloning, if somebody somehow get possession of the private key and cloning a device, you can basically block those devices very easily, or just raise the red flag and investigate. Your security team can investigate what's happening. The another interesting metrics is when your device sending, let's say, sensory data that doesn't make sense. So what you can do, you can train a simple machine learning model that will capture a typical sensory values through the, let's say, winter period, spring period, summer, and so on and so on. And if my sensor is deviating from the normal area or normal values, combined sensor fusion values, I can also red flag it to the security team and identify if somebody let's say, screwing with certain devices. It's probably less interesting for consumer products, but it's very, very critical for our industrial customer, automotive customers, where it's basically safety critical applications. So for that, take a look on the Device Defender. It's pretty comprehensive set of services, and I would say pretty well executed. So to summarize, if you would like to build a connected product, I think definitely take a look at AWS IoT. The most important reason is that all our regions allows you to scale almost from one device to the million device without doing any extra work. So basically, it's a managed service, and we're managing capacity. We literally servicing like billions of connections and trillions of messages at some of our regions. We're also looking and communicating with our customers. So basically, AWS always building the new services with the features that have been requested by our customers. We are not deviating. We are not building services just for the sake of like creating something new. It's pretty much the roadmap is 80% driven by the customers. Security is our number one, if not number zero priority. So it's very, very important aspect. And with the majority of government right now demanding a very tight security for end devices, basically you get covered with reference integration with ExpressLink, and on the back end we offering probably best-in-class security and device management. Also, some of our customers, when they starting this journey and they're getting very excited at the beginning, and then they looking that this cost is soaring, please talk to us, because if your bill is not reasonable, most likely you're doing something wrong. As I said, you can use ESP Rainmaker as a starting point. It's fantastic starting point, and the licensing is very straightforward, and it utilizes it's very cost-effective utilization of AWS services, allowing you to build very modern backend and control application for your smart devices. With that, I will let Dhaval to conclude this talk as well, and I would be happy. I mean, we would be happy to answer any question if you have those. Dhaval, any last remarks?
No, I think you did a great job introducing all of the AWS services which are available. And we talked about how the reference architecture gives you a great starting point if you want to build your own applications on Espressif devices. And for those of you who still have microcontrollers that aren't connected, there is the ExpressLink solution that makes it extremely simple to get started with making connected devices and using AWS IoT. And even for AWS IoT, the usage is simplified even further by using a managed product like Rainmaker, which is based on top of the AWS serverless architecture. And it still remains extensible, so you can continue to add things on top of that if you would like. So the product remains customizable. And you mentioned Device Defender and a few other AWS products that make it extremely cost-effective, secure, and a great way to connect your IoT devices. And yes, we are open to any questions.
Yeah, I wish we would have a little bit more time, because it's literally impossible to jam all of the information into the 40 minutes. But we want to be respectful for the DevCon agenda. So if you have any questions, we'll be happy to answer.
Hello, everyone, and welcome to this talk session Q&A. We are live here with Anton and Daval. Hello, guys. How are you today?
Pretty good. How are you doing?
Yeah, so far I'm doing great. How about you, Daval?
Good, I'm good.
Nice. So it's a pleasure to have you here, guys, for the DevCon23. So we have some questions here from the audience. I will just take the first one. And the first one is, can ExpressLink OTA host 8-bit microcontrollers, for example?
It can. So obviously, ExpressLink can work with 8-bit microcontroller. We don't have implementation for the host over there update, because obviously ExpressLink can do its own over there update, but for the 8-bit we don't have implementation. Please reach out if there are need for that. Definitely can be done. Mind that probably we will need to create a bootloader that would be able to get the bits from serial port and then reflash the MCU itself.
Yeah, and also like it will depend on which kind of like 8-bit MCU, like which architecture, like
Exactly.
Yeah. So we have another question here. So what is the current status of the Espressif/ESP AWS IoT project? Any updates coming from for this?
Yeah, I'll take this one. So the repository majorly consists of the AWS LTS libraries, which are periodically updated. And the typical release for the ESP-AWS IoT library happens when there is a new set of LTS libraries that comes out from the FreeRTOS LTS repository. And other than that, the current plan is to add support for IDF version 5.1, the C6, and that should be available in this week. Apart from that, whenever there is a new release for an LTS set of libraries from AWS, that is when we will update the repository as well.
Okay,
Absolutely.
thank you. And what's the best like way to developers to get like I know that the project is on GitHub, so I think it's just to like watch the project and like you get all the updates, right?
Yeah, it's probably gonna be renamed to something more generic because it's imply C3 right now. But as we mentioned in the talk, majority of ESP SoCs can be can utilize this reference architecture reference implementation. So yeah, just basically, and you can put in issues and you can put the PRs to the reference integration, and reference integration is also pointing on ESP IoT AWS repository. So
okay, yeah, thanks. So I see no any other questions from the audience, but like we still have time. So do you guys have anything to share, like or to add to your talk?
Well, I can share that if you happen to be at AWS biggest conference in Las Vegas this end of November, beginning of December at reInvent, there are gonna be quite a few Espressif technologies because I'm doing the workshop on Matter. So just come and participate. So that's something. There are also going to be. I cannot talk about specifics, but there are going to be a new version of the badge. It's another workshop that's going to be featuring ExpressLink. Other than that, if you have questions, don't hesitate to reach out. We actually really love the feedback. And as Richard Barry yesterday been pointing at his talk, the best way is literally just reach through the GitHub, because we monitoring those quite closely.
Yeah. So Anton, if you have the link for this conference, we can share here in the chat, so everyone will be aware of it. Yeah. So
yes, I think you can still register.
Yeah, so we can share the link, and then once you have all the talks uploaded to the YouTube, we can add to the video description. So if you are like watching this talk in the future, like you will see the link to the conference.
Yeah, absolutely. I mean, I can put it here. I probably can put it on the chat as well.
All right. So guys, anything else?
No? I just want to thank you for invitation. It was a pleasure. Again, I have to apologize for my voice, because I had a tremendous jet lag coming from Asia recording that talk. But other than that, thank you a lot, and again for up for the next, whatever is next, right?
No problem at all. Like we will like definitely do the DevCon 24, like for sure. So we will have like this event like as a traditional event. So
Absolutely.
guys, thank you so much, and thank you for being part of Espressif DevCon 23.
Thank you. Okay, bye.
Bye-bye.
And now we can go back to the studio.
After this fascinating AWS presentation and Q&A session, we are now reaching the final presentation of DevCon 23. So, coming up next is Mohamed Afane, a Bluetooth developer and the founder of NovelBits, which is a leading resource for those who want to learn about Bluetooth Low Energy development and work on real-life BLE applications.
Mohamed will provide a beginner's guide to Bluetooth Low Energy, explaining how to get started with BLE applications on embedded systems, how to tackle various challenges, and how to become a proficient BLE developer. His talk will touch on the different platforms used for BLE development, the different applications of BLE in the field of the Internet of Things, the recommended method for learning BLE development for embedded systems, and also the future of BLE in the field of IoT. Let's take a listen.
All right, my name is Mohamed Afani from NovelBits, and today we'll be talking about Bluetooth Low Energy technology. So first, we'll start off with just an introduction of myself and my company. We'll also talk about what is Bluetooth and cover the differences between Bluetooth Low Energy and the classic Bluetooth that we're familiar with from the years of using audio streaming. We'll take a look at the history of Bluetooth, how it progressed over the years. We'll cover just a high-level technical overview of Bluetooth. Then we'll get into the advantages and disadvantages of BLE, and then look at BLE development, how you would use BLE, some of the challenges that you would face with developing BLE applications and devices. Finally, we'll take a look at what Espressif offers in terms of BLE chipsets, and I'll leave you with some resources towards the end. So let's get started. So first, an introduction to me. My name is Mohamed Afani from NovelBits, and I started NovelBits in 2015 with a focus to help Bluetooth Low Energy developers and developers in general, embedded developers specifically, to learn about Bluetooth Low Energy development through blog posts, video courses, and a private online membership that I call the Bluetooth Developer Academy. And some of the projects I've worked on over the years included smart door locks, BLE gateways, walkie-talkies, Bluetooth beacons, and a lot more. And I've also consulted with the Bluetooth Special Interest Group, which is the standard organization behind Bluetooth. And recently, I also published a second edition of my book on Intro to Bluetooth Low Energy. So let's take a look at what is Bluetooth, what it is, how it began. So in the beginning, Bluetooth began in 1994, around that time, with Ericsson, and around 1999, the Bluetooth Special Interest Group was formed, which is a company, the standard organization behind the Bluetooth standard. So it's more about combining a number of members from companies, and they came together and created this Bluetooth standard. And the first version 1.0, was released in 1999. In the beginning, it was really just a cable replacement use case. So it was used for making keyboards and mice wireless instead of wired, and also connecting PCs with handheld PDA, if you're as old as me and you can remember those. Followed by that, the Bluetooth started to get used in audio streaming and headset devices. So this became a lot more popular when there were laws around using the handheld and the smartphone in your car, and you needed to be hands-free, and that's where Bluetooth started to get really popular in the car, and then also in audio streaming and wireless speakers. Now, all this up to now was originally the original Bluetooth, and this is referred to as Bluetooth Classic or BR-EDR, Basic Rate and Enhanced Data Rate. In Bluetooth Low Energy, that was introduced in Bluetooth version 4.0, and this is back in 2010, so almost 13 years ago. And Bluetooth Low Energy, just to keep in mind, is very different from Bluetooth Classic. They just share a few things, but overall, they're incompatible with each other. So Bluetooth Low Energy is more of a low power wireless technology. So it's focused on IoT applications, Internet of Things applications, and it's ideal for applications that just need to transfer small amounts of data and in very short periods of time. Also focused on lower speeds. A lot of these devices that would utilize Bluetooth Low Energy will actually not send a lot of data, and they'll be like more sensor oriented or sensor focused. They also need to run on batteries for long periods of time, so they require low power consumption, and hence the low energy part of the name Bluetooth Low Energy. And typically they've been short range, although that has changed over the years, and there are more options now for achieving much longer range than it was originally designed for. And finally, for a lot of the personal devices, especially with wearables and fitness trackers and such, you could use when you want to use a smartphone as more of an interface, Bluetooth Low Energy serves as a great interface and a great wireless technology because it's embedded in 100% of smartphones these days. So let's take a look at the differences and some of the similarities between BLE and classic Bluetooth. So I hope you can see this table. It's a lot of text, but I'll just read through a lot of the highlights from it. So the usage, again, classic Bluetooth was used in a lot of streaming application and still is in audio streaming and sometimes for file transfers. Bluetooth Low Energy was primarily for sensor data, controlling devices, and low bandwidth applications. However, it has changed over the years, and there is a new standard for streaming that was just released last year. It's called LE Audio, and it will soon replace Bluetooth Classic. I would say not very soon, but maybe in the next 5 to 10 years, it will be replacing Bluetooth Classic with a lot more features and a lot more innovative new use cases for it. The data rate for Classic, it's up to 3 megabits per second. For Bluetooth Low Energy, it's up to 2 megabits per second at the moment. Power consumption, again, Classic is much higher power consumption versus BLE is focused on low power consumption and increased prolonged battery life. The RF channel spectrum, there are 79 RF channels that are each 1 megahertz wide. For Bluetooth Classic, with BLE, it's 40 RF channels, and they're spaced out 2 megahertz apart. The device discovery occurs on 32 channels in the case of Classic, whereas it's on 3 primary channels in the case of BLE. So this makes it much quicker to discover a device and much quicker to connect. The audio streaming, currently most of, if not 99% of audio streaming applications use Classic Bluetooth. However, as I mentioned, there is a new standard called LE Audio that will eventually replace Classic Bluetooth. This allows you to do the same, achieve the same use cases and applications that you could use Bluetooth Classic for at the moment, but it also introduces a lot more new and flexible use cases, such as broadcasting audio, standardizing the hearing aid industry and the hearing aid devices, so you can use multiple hearing aids from different companies and different vendors, and they will interoperate together and without any issues. Let's get to the range. The range is up to around 100 meters for Classic, whereas with LE, there are a lot of options that are added in terms of being able to increase the range in terms of transmit power, and then using a long range mode that you can actually achieve up to over 1 kilometer of range and line of sight. And there have been a few videos on YouTube from different vendors that showcase this, so you can look that up as well. In terms of topology, Classic has been traditionally just a point-to-point, peer-to-peer, whereas with BLE, there's options for star topology and doing broadcast, and also mesh and doing many-to-many. So that's just an overview of the differences. There's a lot more differences that we can, we don't have the time to go through today. So let's take a look at the history of Bluetooth, how it progressed over the years, and what kind of changes were introduced over the years in the specification. So in 1999, again, this was when Classic, or BR-EDR, was first released. This was version 1.0, and low energy, or BLE, was introduced in version 4.0 in 2010. In 2011, Apple announced and released the iPhone 4S, which was the first smartphone in the market to support BLE. Now, that was in addition to Classic Bluetooth, because that was widely supported in smartphones, but this was the first dual mode smartphone that supported LE, and that really opened up the space for a lot of new use cases, where like fitness trackers and wearables and smartwatches, that all started when BLE was introduced, because it allowed devices to run on batteries for much longer periods of time. In 2013, Apple also announced the iBeacon standard, and iBeacon, or beacons in general, are just broadcasting BLE devices that allow you to discover them, and they are used a lot in retail marketing, asset tracking, and sometimes even in indoor navigation applications where GPS might not work that well. In 2016, there was a new version, probably the biggest update to BLE since 4.0 at that point, and it's Bluetooth 5.0, and that introduced two different modes. One is for achieving double the speed, so went from 1 megabit per second to 2 megabits per second, and this was at the radio rate, so it's not 100% going towards the application data rate, or what you can achieve at the application layer, but it introduced the PHY, the physical layer radio data, to be double the speed at 2 meg, and then also introduced a long range mode, which you can achieve up to 4 times the range of using the 1 meg PHY. In 2017, Bluetooth came into the space of many-to-many, or mesh topologies, in order to compete with Zigbee and Thread and all the other competitors in that space. And specifically, there's been a focus with Bluetooth mesh on commercial lighting. And then in 2019, Bluetooth announced 5.1, which included direction finding. This uses angle of arrival and angle of departure. In 2020, Bluetooth 5.2 was announced, and this introduced isochronous channels, which is basically the foundation for LE audio, the new Bluetooth audio standard. Now, this didn't coincide with the actual LE audio standards yet. Those were released a couple of years later. So in 2021, Bluetooth 5.3 was announced with very little feature updates. One of them was just called connection subrating, that helped also achieve the LE audio standard. So in 2022, that's when the complete specs of LE audio. So LE audio really builds on top of BLE, but it has its own specs. It has up to, I think, 22 specs on its own. So it's a big standard, but it's very ambitious and has a lot of potential for the future of Bluetooth Low Energy. In 2023, just earlier this year, Bluetooth 5.4 was released with a new update with some new features, highlighting periodic advertising with responses. These are just a new mechanism for doing advertising and broadcasting at scale, but also getting responses back. So it's now bi-directional. Think of it, really, the main use case for this has been in electronic shelf labels. So where you have grocery items or even items in a department store where they have labels that display the price and the name. You can update those from a central location within the department store and do it in real time. And looking at the future of Bluetooth Low Energy, there's a lot going on, a lot that is going to happen with Bluetooth. Some of the new features that are looking to be include high accuracy distance measurement, significant data rate increases, even above the 2 megabits per second, and also going into the higher frequency bands. So we know Wi-Fi is already in the 5 gigahertz band, and Bluetooth is actually exploring the path or the opportunity to go to the 5 or 6 gigahertz spectrum. So let's just take a very quick overview of the technical facts about BLE. So first, again, it operates in the 2.4 gigahertz. That's the unlicensed ISM band. So this is global, and it's available for any technology to use without any licensing. It has a mandatory 1 megabit PHY. This is at the physical layer, the radio. And this has been the standard since the very beginning of BLE, since version 4.0. Then it also has an optional 2 megabit PHY, and this is used for the high-speed data mode, and also has a coded PHY. This is used for the long-range mode, which can achieve up to 1 kilometer or even more line of sight. Finally, the RF spectrum is kind of split up into 2 different types of channels, and 3 of them are called the primary advertising channels. This is where the discovery happens. This is where device discovers another device and decides maybe to connect to it and establish more of a bidirectional communication between the 2 devices. And then we have what's called the general purpose channels, and these are used for either what's called secondary advertisement or for data exchange during a connection. And you'll notice the 37, 38, and 39, those are the primary advertising channels. They're spaced apart in a weird way, but it really comes to light when you understand that they are actually placed apart in a way to avoid the Wi-Fi channels 1, 6, and 11, the most popular Wi-Fi channels, in order to reduce any interference and make it more being able to coexist with Wi-Fi in that space, in that spectrum. So let's take a look at some of the advantages and disadvantages of using BLE as a technology. So the advantages, it has lower power consumption, and even compared to other low power wireless technologies, there's also no cost to access the official specification documents. With some other competitor wireless technologies, especially low power, you have to join some kind of organization and you have to pay fees in order to become a member and access the specification documents. With Bluetooth, it's all available online. You can download it at any time, and you can just go through the spec, the 3,000 plus pages of the spec by yourself without having to pay a single dollar. There's also low cost of modules and chipsets, and this is even going down even lower and lower. There's low cost of licensing and certification. You can become a member with a nominal, some fee for a year or so, and then you can get some discounts for certification as well. And there's also 100% support in smartphones, and there's no other really low power technology that can compete with this at the moment. In terms of disadvantages, again, data throughput is a little bit limited, especially when you want to achieve low power consumption. So the raw data transfer rates can range from 250 kilobits per second to 2 megabits per second. And again, this is at the radio level. So when you take into account headers and gaps and a lot of overhead, it comes down to maybe 1.3, 1.4 megabits per second at the application layer. And this is using the high-speed mode. In terms of range, again, it was designed for short-range communication. So if you want to achieve the low power consumption aspect of it, then you might want to stick to, you'll be restricted with the range that you can achieve with your application. However, if you do have a little bit more in terms of power consumption that you can sacrifice, then you can go longer range and achieve much better ranges. And the last one is finally just having, or the need to have a gateway or some kind of proxy device in order to send the data from a BLE device to the internet, because there's no IP connectivity. So again, why would you choose BLE as a developer, as a project manager for your project? I think Bluetooth has really proven that it has a track record and credibility. The name, the brand is known by almost every person. I mean, it's a consumer brand as well, so that helps the brand, even though it's getting going into different markets and even industrial and manufacturing. It's also truly globally interoperable, so you can run it and you can license that technology and employ it in your devices anywhere in the world, and they will work with each other as long as it's certified and with the Bluetooth SIG. The Bluetooth SIG also has full control over the technology stack. What this means is if you compare that to some other technologies that might rely on IEEE as the standard, then they have to go back to the IEEE standard and be able to, if they want to make changes, they have to go back to that standard body and propose these changes and wait for that to happen. With Bluetooth, they can just make changes at any stack, any level of the stack, without having to go back to any other standard body. There's also, again, ubiquitous support on smartphones, so it's 100% supported on all smartphones these days. There's also continuous improvement and innovation in the spec and updates. It allows you to introduce, it introduced a lot of flexibility for developers. So some of the features that were introduced are optional, but they allow a lot more flexibility for developers to tailor it towards their application use case. And again, as a developer, if you are learning Bluetooth Low Energy, this is a technology that can be applied across many industries. So your learning and your efforts do not go to waste. In terms of BLE development, just a few slides on that to look at the different development aspects as well as some of the challenges. So there are three main types of Bluetooth Low Energy platforms. We can think of microcontrollers, smartphones, and desktop apps. And sometimes the Linux devices such as gateways and routers might be grouped with microcontrollers, although they're kind of in between desktop apps and microcontrollers. Microcontroller and chipsets often give you the most flexibility that you can with they also give you usually the latest and greatest of the features, even the optional ones that are available with Bluetooth. Desktop applications can be challenging just because there are differences between the different APIs that are available on the major operating systems. In terms of smartphones, there are restrictions, a lot more restrictions than what you can do with microcontrollers. So on iOS and Android, and iOS even more than Android. So in terms of specification versions, just a few notes on that. So again, Bluetooth Classic or BR-EDR and Bluetooth Low Energy, they share the same specification. This is a specification that's over 3,000 pages, and it's all kind of mixed together in there. So it can be difficult sometimes to navigate through that and find what's relevant really for BLE versus Classic. Also, another note is that Bluetooth, the version of Bluetooth, does not really indicate whether LE or Classic is supported by a chipset. So if you see a chipset that says 5.0, it doesn't mean that that's Classic or that's LE. You have to go and look at the data sheet and find out whether LE or Classic are supported or whether it's actually dual mode. A lot of the features are optional. So again, we mentioned like the two new features that were added in 5.0, which is long range and the high speed mode. Both of these were optional. So it doesn't mean that if you find a chipset that supports 5.0, that means that these options are available. You just have to make sure that they are through looking at the data sheet or contacting the vendor. Mesh is also another spec, and this was added as a standalone spec, so it's actually not compatible with LE. It's it is compatible with LE, but it's not embedded built in with any LE device. So it has to be added. It is backwards compatible all the way up to Bluetooth version 4.0 with Bluetooth Low Energy. So it does require BLE, but it also requires an additional layer on top of that in order to support it at the firmware level. And it also has to be qualified if the device needs to be Bluetooth Mesh certified with the Bluetooth SIG. So again, on smartphones, some of the challenges, iOS and Android SDKs have restrictions. There's also a wide diversity of Android devices, so there's going to be a lot of testing that you need to do to make sure that your app may be running on an Android device is compatible with your device and it's operating and running and functioning properly. There's also changes in mobile OS releases that might affect the application, the BLE application, due to changes in stack or some changes in the APIs themselves. On microcontrollers, there can be a steep learning curve, especially when trying to learn the APIs, the SDK that's involved. So in addition to learning Bluetooth Low Energy itself, you have to learn how to use the SDK and the APIs. And a lot of vendors will provide good examples of using those. So it's not always the case, but it's just something to keep an eye out for. There's something called services and characteristics in Bluetooth Low Energy specifically, and it's basically just a way to structure the data that your BLE device exposes to another device. And the designing this can be a challenge sometimes, and specifically to satisfy the requirements. So that's one of the challenges that you might face. Debugging BLE can be difficult at times, and it can be made a lot easier with a Bluetooth sniffer. The problem is some of these Bluetooth sniffers, if you're really looking for one that's reliable and it can support a lot of features, it's going to run you at least $10,000, $15,000, all the way up to maybe $70,000 or $80,000. So it's not a cheap investment. Then optimizing for range, data throughput, power consumption, and optimizing for multiple connections. These are all things that usually come up with a BLE application or developing a BLE device. And in a lot of times, one or two of these will have to be sacrificed in favor of the other two. So let's take a look at what Espressif offers in terms of BLE chipsets. So we have a few options, actually. The ESP32 is probably the one that everybody's most familiar with. This is the original, and it included, for Bluetooth 4.2. So again, this doesn't mean that it's just BLE or Classic, and in fact, this is a dual mode chipset, so it supports both BLE and Bluetooth Classic. Also included Wi-Fi, which is very common across the ESP32 chipsets. ESP32C2, this one includes 2.4 gigahertz Wi-Fi as well, and it's Bluetooth 5.0, so it's qualified up to version 5.0 as of this recording, and its BLE is supported only. There is no Classic, but it does support the coded PHY and the 2 meg PHY. So those are the long-range mode and the high-speed mode, which are optional features in 5.0. We also have the C3 series, which is similar. It supports Wi-Fi, Bluetooth 5.0, and it's BLE only, so there's no Classic, but it does support Bluetooth Mesh, and it has the two optional features from Bluetooth 5.0, coded PHY and 2 meg PHY. Similar for C6, except this is Bluetooth 5.3 certified. And then finally, we have the new H2 series, which actually drops the Wi-Fi support, but supports the IEEE 802.15.4. So think of Thread and Matter technologies, but it also supports Bluetooth Low Energy. So it's BLE only, supports Bluetooth Mesh, and it's Bluetooth 5.3 certified, and also includes support for the coded PHY and 2 meg PHY. Again, the last one is S3. This is a Wi-Fi plus BLE chipset, and it's Bluetooth 5.0, has Bluetooth Low Energy only, and supports Bluetooth Mesh, but also has the coded PHY and the 2 meg PHY. In terms of resources, so just to let you know about a couple more resources if you want to learn more about BLE. So I have a new book, a second edition of my original book, which was originally in 2018, released in 2018. So I just have a new edition of that, Intro to Bluetooth Low Energy. And the title really for this is, the goal is to help you learn Bluetooth Low Energy in a single weekend. And if you want to learn more about it, just go to learnbluetooth.com. And finally, I have an online membership, and this is a private membership that you can gain access to via the website, novelbits.io/academy. It includes video courses as well as access to me personally and a few other experts in the Bluetooth space via a private forum. So that's where a lot of my content, the new content that I add, goes into. It goes into the Academy. So thank you all for watching. I appreciate it, and I'll be ready for any questions.
Hello, everyone, and welcome to the last session, Q&A live session with Mohammed
So now, hello, Mohammed. How are you today?
Hi, Joe. I'm very good. Thank you. I appreciate this opportunity and being here to speak at Espressif DevCon23.
Yeah, so this is the last talk for the second day. We'll still have the generic or the general Q&A session after this one. But for now, let's answer the questions we already have here from the audience. So the first question we have here is, so I see the ESP32C6 has a feature of BLE central and peripheral simultaneously. Is this device specific? Can I do that on ESP32 device? I have seen like Arduino projects that claim to do both roles.
Yeah, so I would refer to the data sheet for the device to figure out if it supports both roles. Most of the time, I think with chipsets like the ESP32, they're pretty powerful, so it'll be able to support both roles, pretty much all of them. Now, it comes down to whether you're asking a question about whether it can support both at the same time. And in many cases, they can act as a central device and as a peripheral device, both at the same time, simultaneously. And basically, it just does like time slotting and doing scheduling for the different roles. And yeah, I mean, I think it depends, but I would check the data sheet on a specific chipset that you're working with.
Yeah, I see. Yeah, and we have here another question from the same person. So, which is there a limitation on BLE device density, say 10 devices per square meter?
Yeah, so I mean,
cubic meter.
Cubic meter. Yeah, so I mean, it depends. So again, if we go back in advertising mode, the BLE devices operate primarily on 3 frequencies. So that in the advertising mode, that can be pretty congested. It can get congested very quickly. It just depends on how often these devices are advertising, how long they're advertising for. So there are specific, I mean, in the end, really, with a lot of the RF and wireless questions like this, it depends. But in general, if devices are connected though, after they go through the advertising and they connect with each other, a central and a peripheral, then they start to operate on over 37 channels, in the outside of those 3 advertising, so they have a lot more space to work with, and that reduces the congestion. If you have beacons in a specific area and they're all advertising very frequently, then you might run into issues within the same area or space that you're operating in. So it really just depends on the different parameters that are set, the different modes that the devices are in. But as with any RF situation, it could be affected by other BLE devices, but it could also be affected by Wi-Fi and other technologies operating in the 2.4 gigahertz spectrum.
Okay, I see. We have one more question here from Useful Electronics. That's pretty nice name. So last versions of BLE supports communication direction/angle. Is this possible to achieve with any of ESP32 series?
I don't know off the top of my head, but I think it is not. That requires multiple antennas to be able to operate, whether an angle of arrival or angle of departure. That's the direction finding feature that was introduced in 5.1. So it's not just support for the stack, but you actually need the hardware to support that. And usually it's multiple antenna array with multiple antennas in order to be able to achieve that.
Yeah, maybe we can try to answer this question because it's like specific to the ESP32, not like specific for the BLE specification. So we can try to answer this one in the general Q&A. Yeah, so far we don't have any other questions here. So we do, sorry. Additional question.
is it possible to measure distance between communicating devices in air?
Yeah, so there are certain ways. In BLE, it's more about a proximity and approximation of the distance, at least so far, with using RSSI, Received Signal Strength Indicator. There are new specifications coming out for Bluetooth Low Energy that it's called channel sounding. The draft is actually of the spec is up on the Bluetooth SIG website for anyone to download. So it's not like it's a confidential feature that's coming out, but there's not a lot more about that because it's not out officially as a spec. But in terms of that will be very similar to what UWB ultra wideband does in terms of time of flight and determining actual distance in meters and down to centimeters. I'm not sure though about the details because this hasn't been released publicly yet.
Yeah, I see.
But a lot of people use RSSI as at least a way of approximation. And if you use multiple devices as well, you can do more triangulation or trilateration in order to figure out a more accurate distance measurement.
It's quite challenging to do that, but like it is possible. Okay, so thank you so much. First of all, for answering all the questions and for being part of Espressif DevCon23. I will share here the link to download your book. So thank you so much for writing this amazing book that that could be used for everyone interested in BLE. Thank you.
Thank you. Thank you, Pedro.
So now we can go back to the studio.
That was the last presentation at DevCon23. However, we are not finished yet. Our colleague Pedro Menatel has been holed up in the Q&A studio here at Espressif Systems in Brno, carefully collecting the questions that you have been sending in.
Whatever questions have not been answered yet, or whatever issues need further clarification, will be tackled now. For this purpose, Ivan has just joined Pedro in the Q&A session over there, next door. So let's cross over to them.
Hello, everyone. And now it's time for the general Q&A. So we have Ivan here to answer some of your questions, some of the questions that were asked during the 2 days of DevCon. And are you ready for the first one?
Yeah, let's go.
Okay. So what is the main difference between using Arduino IDE and ESP-IDF? Are all the Arduino libraries available for instance?
Right. So generally, we can start maybe with when would you use one or when would you use the other. So Arduino IDE is really good to use for prototyping. So getting something that works really quickly because there are lots of libraries in Arduino. Arduino is pretty high level, so you don't sometimes need to write as much code as you need to write just in plain C to do the same thing. And in general, it might be easy to find some existing sketches and kind of glue them together. So Arduino, this is, I think, the primary case when you might want to use Arduino. For ESP-IDF, typically you would spend more time on designing the application, what are the internal interfaces, splitting it into libraries, and so on. In terms of availabilities of Arduino libraries, in theory, it's possible to use most Arduino libraries if you use Arduino ESP32 project as an IDF component. So there is this migration path where you can start with Arduino, write the application in the Arduino IDE or in some other environment where you can use Arduino, and then migrate it to an ESP-IDF application by using the Arduino ESP32 project from the component registry, or just using adding it as a component from Git. One thing to pay attention to here is sometimes licensing. So Arduino core licensing and many Arduino library licensing is different from ESP-IDF. So ESP-IDF is Apache licensed, and some Arduino libraries are LGPL licensed, which you need to consider when when using this in some product.
Yeah, I mean, complied with the license.
You have to be compliant with the license. Yeah.
Yeah, for sure. So we have one more question here. What is the difference between ESP32C6 and ESP32H2?
Yeah, ESP32C6 has Wi-Fi BLE M15.4. ESP32H2 only has BLE M15.4, so no Wi-Fi. C6 also has more RAM than H2, and C6 has higher CPU frequency and higher APB frequency than H2. So for the same application, C6 will be a higher performance compared to H2. On the other hand, H2 is cheaper, and if you only need, for example, BLE or only need data 2.15.4, then H2 might be the right fit.
Yeah, and H2 is also like recommended for Matter devices like smart lights and switches.
Yeah, you can build Matter devices with Wi-Fi connectivity as well, and for some devices it's actually might be preferable over 15.4. But yeah, this is one of the this is another difference. H2 indeed is the recommended device for Matter.
Yeah. Okay, so next question. What is the maximum number of devices in a thread mesh network?
So in thread, I think the theoretical maximum is pretty high. In practice, what you're limited by is that you can have up to 32 nodes, I think 32 router nodes in the network. And in practice, each of them has some limitation how many child nodes they can serve, usually between 10 and 20. So this depends on the specific device, just due to memory constraints. In theory, I think the number is larger. So practically speaking, it's more than 200 nodes you should be able to get in a thread network.
Okay, I see. Yeah, so this next question is quite interesting. Will there be improvements for the SDK config to compete with STM32's Cube IDE and make configuration for ESP32 easier?
Actually, if you used SDK config in the command line, you might be familiar with this curses style text-based interface. In the IDEs, you actually have a graphical interface where you can select the same settings just from the UI. So I think maybe you can try that in IDF Eclipse plugin, or IDF or Espressif IDE. There is a graphical interface, and also in VS Code there is another graphical interface. So if you're, for example, in VS Code, if you're familiar with the settings interface of VS Code itself, then the configuration interface of ESP-IDF is almost exactly the same as the built-in settings interface.
Yeah, so you should try or Espressif IDE or Visual Studio Code extension.
If there is something specific that you would like us to add, so some capability that you're missing that you would like us to add in SDK config that will make configuration easier, then some specific type of feedback is very welcome. You can open a feature request on either of the IDE repos like VS Code or Eclipse.
Okay, so next question. Why don't you have an IDE like STM32Cube or Microchip Studio? IDF is cumbersome and slow. It's no fun having to work with it. In addition, the Linux and Windows variants are not compatible.
So quite a lot to unpack here. Honestly, it's a bit disappointing for me personally to hear that IDF is cumbersome because we do try really hard to make it nice to use for developers. So we'll take this feedback. In terms of being slow, one of the issue that we do know about is that, especially on Windows, if you have some kind of an antivirus, because IDF is typically compiling lots of source files, the compile times can be very high. So the solution that we recommend is adding some exclusions or adding the directories where ESP-IDF and the tools are located to some allow list of the antivirus. This can improve performance by quite a lot. So that is one of the things I would say about the build performance. This is specific to Windows. On Linux and Mac, you usually don't notice this, but in many cases on Windows, this is happening. The other part about the IDE like STM32Cube or Microchip Studio. So ESP-IDF, for ESP-IDF, there are some IDE options, like we have the Espressif IDE that is based on Eclipse with the IDF Eclipse plugin. It is in many ways like the other vendors' IDEs that are based on Eclipse. I think we're using a different version of Eclipse as the base, but otherwise you will find them very similar if you're working with other types of semiconductor vendor IDEs. One thing that we don't have right now that, for example, STM32Cube has is configuration or like graphical configuration editor, I would say, right? Yeah. So when you can sort of select which pins will be used for different peripherals and so on. This is something that we are actually working on. I hope that we will bring this functionality in one of the future versions. It will not be limited just to our Eclipse-based IDE, but just going to be a general tool that will facilitate creation of new projects, addition of peripherals, drivers, and other components. So this is something that we will try to improve.
Yeah, that's really nice to hear. So next question. I have seen that ESP32 that have an external flash chip are much easier to hack compared to those that have embedded flash. Will there be an ESP32 P4 with embedded flash/PSRAM?
Yes, I actually now remember that I probably answered that one in the chat, but I'll answer it again. Yes, definitely the fact that we have a package and the flash is integrated, and especially when the flash pins are not bonded to the package pins, so you kind of don't have a direct way of accessing the pins. That adds one extra step that the potential attacker needs to do to get to those flash pins, and this is another layer of protection. So maybe the attacker, not that it's impossible to do compared to all other things the attackers have to do, this is not very difficult, but maybe they will just look for another device to hack.
Okay, so you mean that the flash pins are not being exposed?
Yes. So basically the flash is directly connected to the die of the chip, to the actual silicon, like bonded inside the package, and there is no pin of the package, like QFN package, that connects to the flash pin. So you cannot just easily attach some probes or read or write flash. So yes, we definitely will have embedded PSRAM versions of ESP32 P4 because that will allow us to have much higher speed interface. It's much easier to like match all the wires with length and so on if we put this inside the package. And we probably will have embedded flash. Typically, embedded flash plus PSRAM packages might come slightly later in the device lifetime. For example, for ESP32, you probably remember we had this ESP32 Pico, Pico D4, and then we had Pico V302, which had PSRAM. So that came much later than the initial ESP32 came out. And for ESP32S3, we had packages with PSRAM from release, but we didn't have a package. Well, we had packages with flash and PSRAM as well, but what we didn't have was like fully integrated package with Crystal and other things. And now we have it. So now we have the ESP32S3 Pico, which is a fully integrated package. So I think we will have different kinds of packages. Maybe they will not all happen initially at the release of the chip.
Okay, I see. Thank you. And second, another question: how to lock code in ESP? As in production level, we need to protect our code so that people can replicate the code.
So generally, this is possible using flash encryption on Espressif chips. Typically, external flash is used, so the flash chip is not inside the silicon die of the ESP, but is another chip. Sometimes it's integrated into the same package. What flash encryption does is it makes sure that all the content in this flash is encrypted, and the decryption happens transparently to the software when the MCU accesses external flash. So that can protect your code in external flash from reverse engineering. It is required to enable flash encryption together with secure boot. Enabling just the flash encryption is not useful because you also need to prevent the attacker from running some code which will just read out the whole flash, right? So you have to make sure that only the code you authorize gets run on the chip. So basically, the two features, flash encryption plus secure boot, they do provide some mitigation for flash readout attacks. That being said, if you have been following the vulnerabilities that have been reported, like for hardware attacks, there have been successful attacks on the ESP chips using different methods like fault injection or using DPA, differential power analysis. So it is not impossible to defeat flash encryption, provided that you have the right tools and you invest some time into that. So basically, we generally recommend to focus on protecting device-specific secrets. Like if you have a device-specific private key that needs to be that device uses to access the cloud, then this is the thing you should be trying to protect. Protecting the firmware is harder. So there are more ways to get to the binary of your firmware. But even if someone else has the binary, it's not yet still so easy because even cloning the device, if you have the complete binary, is not always not always so easy. You can add some mitigations in your application to prevent your application from running on some cloned hardware.
I see. So we have more questions here directly from the audience. Yeah. So any specific one that you prefer to start?
Yes. Okay. There is a question about preview datasheet of ESP32P4. I think we will have it in Q4. So far, for now, we don't have something that we can distribute, but this has been worked on, and before the end of the year, I think there will be a datasheet of P4 published.
Okay.
The coexistence module for Wi-Fi and BLE is a hardware device or a software configuration. ESP chips, all ESP chips, they have both hardware and software mechanisms for Wi-Fi and BLE coexistence. The newer the chips, the newer the chip, generally the better the hardware mechanism is. So on the ESP32, we had to do quite a lot of things in software still to get coexistence to work well in different scenarios. But on newer chips, the hardware is taking over more and more functionality, and we are fixing some of the bugs that existed in the previous chips. So it's both. There is both hardware and software part to it, and it is being improved. So the newer chip, generally, you're going to get the better performance out of it. ESP32P7, we are also looking to it. We would like to get a P7 preview datasheet, but maybe not yet. Are you thinking about improving an SoC for automotive industry? There are a few specific things that we are looking at right now that are related to automotive, although we are not specifically targeting automotive yet. But you can think of that as a kind of stepping stone to get there. So one example has actually been demoed by our colleagues at the recent Zephyr Summit. It's a methodology based on Zephyr RTOS, where we can run both the application code and some safety critical code on the same chip on two different cores. So for instance, we can use ESP32S3, run some application that's connecting to to the cloud, or just a connectivity application on one core, and some control application that maybe monitors some GPIO or some sensor on the other core, and isolate them so that they don't interfere with each other, and that the other part can be certified for safety critical standards. This is, of course, far from getting into the automotive applications with all the safety certifications, but we are initially going to target some industrial safety standards and consumer safety standards.
All right. So I think that's it. Yep. So we do have one more from Yusuful.
There was a question about, a question and a comment. I love working with ESP-IDF. Thank you for that. Once I managed to debug ESP32 over JTAG, and it was quite hard. So is it straightforward to debug ESP32 S3? Actually, yes, S3 is easier to debug, primarily because in ESP32 S3, in C3 as well, and in most newer chips, what we have is a new peripheral called USB serial JTAG. And this is basically a built-in USB device that has two functions. It is a USB to serial converter, and it also is a USB to JTAG adapter. So you don't need to have an external JTAG probe, like you might have an ESP probe lying around. You don't need an ESP probe. You can just connect USB port directly to the ESP32S3, and through that USB port, you will have both the console, so virtual serial port, and you will have JTAG. That JTAG is not a high-speed device unlike ESP-PROG, so it's going to be a bit slower. And in some cases, when you're maybe stepping through the code, or if you have many breakpoints or something like that, you will notice that it's slower than debugging with a dedicated JTAG probe. But the point is that you don't need anything external. So if you get an ESP32S3 DevKit C, then you will notice that it has two ports. For one port, which is labeled UART, it's just the normal external USB to serial adapter, and the other port that's labeled USB is by default that USB to serial JTAG. So just plug it in, and in Espressif IDE, for example, you can select USB serial JTAG as the debug adapter, and then debugging should start. You don't need to connect anything. So the other thing is that also those two pins that are used for USB, they don't overlap with anything else. So for instance, on the original ESP32, there were some 4 GPIOs like 12, 14, 15, and something else that were used for SPI, for SD, for JTAG, and maybe for some other things. So we don't have that anymore. And on ESP32S3, those two USB pins, they are just USB pins, and they don't interfere with other peripherals.
Okay. So you mentioned that basically if I buy a ESP32S3, I already have the JTAG and the serial interface. Is that right?
Yes,
okay,
that's right.
And any other chip with the same peripheral or the same capability?
We added this initially in C3. So C3, S3, C6, H2, P4 is also going to have this. The only chip out of the newer ones, like after C3, that doesn't have this is the C2. And C2, we are starting to get some interesting questions in the chat. And if C2, C2 was cost optimized, so that's why we couldn't put this USB feature in there. But otherwise, all the newer chips do have that. Maybe we can take one more question, and that is, I've noticed that Espressif offers PCB design review services, but is there any help service related to firmware development? There is, there is no service in the same way as the PCB review service is. So PCB review service is free, and we provide it basically for any customer of any size, pretty much. Firmware review, we do not offer that by default. Some of the bigger customers, of course, if they have specific agreements with Espressif, can get it, but I'm afraid we don't have this just for all our customers. It's we definitely need to become a bigger company for that.
All right. So I think we are like almost 9 hours or over 9 hours long broadcast. I'm so sorry if we can't answer like all the questions. We have like a limited time, and we are like pretty tired as well. It's been like a long day. But I was pretty happy, like to help answering questions here, like managing this Q&A. So yeah, thank you for the opportunity. Yeah, so any final consideration for the Q&A?
No, I think that's, thanks everyone for some interesting questions there.
Okay, thank you everyone. And now we can finish this last Q&A. I'd like to thank you for all the questions, and now we are ready to go to the studio.
So that's it, guys. We have reached the end of Espressif DevCon23. We're very pleased we managed to bring Espressif's official developer conference to life for the second year in a row. It was a blast, wasn't it?
Absolutely. What eventually took the form of a 2-day online conference needed more than 6 months of preparations. 26 talks were recorded by 30 speakers residing in 4 different continents: Europe, Asia, Latin America, and North America. 10 of these speakers were guests and 20 were Espressif employees. It took them about 2 months to complete their recordings, so I'd like to extend a heartfelt thank you to each and every one of them.
The above-mentioned content filled nearly 20 hours of live broadcasting over 2 consecutive days. Our graphics team, our documentation team, our marketing team, and our engineers in Brno, Pune, Campinas, Singapore, and Shanghai worked tirelessly until the last minute in order to ensure that the finalized conference content would be of the highest quality. We thank them sincerely for their dedication and hard work. And before this outro becomes any sentimental, I'd like to ask everybody who's been here in Brno, and here they are, my lovely colleagues, so you can now see them because we need to give them the credit they deserve. So I'll mention their names. First of all, Wojta Bartoszka, our project manager and DevCon's broadcasting director, very hard job. Ondra Buchta, project manager as well. One of them was not enough for this type of event. Then we have obviously Ivan Grohodkov, VP of Software Platforms, Pedro Minatel, Espressif's developer advocate, and quite literally the beating heart of DevCon. Without him, Espressif DevCon would have never come to life. Radim, software engineer from Espressif's branch here in Brno, and my co-presenter for today. Our super efficient ladies from the HR department and, of course, the HR manager, Annie Tselianou. Without them, there wouldn't be an Espressif office in Brno, let alone one that's working as successfully as this. And myself, Yanis, from Espressif's digital marketing team, we would like to thank you all for attending DevCon23 and for sending in your questions, comments, and greetings. See you next year for DevCon24.